esteemed guests, professors, scholars, and friends. It is a moment of great joy to welcome you all as we begin this journey of ideas and innovations.
Today shines as a celebration of knowledge, curiosity, and the courage to explore boundless horizons.
Music gives the mind wings, the imagination flight, and the universe a soul. Beautifully quoted by Plato, I kindly request everyone to rise for the prayer song and Tamil Thai Valtu, presented by the KT Choir.
விநாயகர் துதி. ஐந்து கரத்தனை ஆனை முகத்தனை, ஐந்து கரத்தனை ஆனை முகத்தனை, இந்தின் இளம்பிறை போலும் எயிற்றனை, இந்தின் இளம்பிறை போலும் எயிற்றனை, நந்தி மகந்தனை ஞான கொழுந்தினை, நந்தி மகந்தனை ஞான கொழுந்தினை, புந்தியில் வைத்தடி போற்றுகின்றேனே, புந்தியில் வைத்தடி போற்றுகின்றேனே, போற்றுகின்றேனே.
Every great journey begins with a spark. The ceremonial lamp glows as a symbol of wisdom, a flame of hope, a beacon guiding young minds towards brilliance.
With immense pride, we invite our esteemed chief guests to the stage to light this flame, marking the radiant commencement of ICAMND 2025.
A lamp that shines brightly, shares its light endlessly. May this flame inspire brilliance in every heart gathered here today.
gesture of gratitude and deep respect, we now move honoring session.
Now let us invite our Tangaraj sir to honor Professor M. Lakshman, Bharidasan University of Tiruchirappalli. Now let us invite our principal sir to honor Dharmaraj. Dharmaraj sir.
I now invite our principal sir, Dr. S. Ramkumar sir, to invite Dr. N. Dharmaraj sir, Professor, Bharatiyar University, Coimbatore. I invite our director, RIC, Dr. P. Thangaraj sir, to honor Dr. D. Selvakumar sir, scientist DRDO. I request our principal sir, to honor Dr. K. Kadirvelu sir, scientist DRDO.
With the flame glowing brightly, we now turn to the guiding voice of vision.
We invite Dr. S. Ramkumar, the principal of KIT, for the welcome address.
So good morning, everyone. Good morning. Distinguished guests, Dr. N. Dharmaraj, Professor, Bharatiyar University, Coimbatore. Respected Dr. D. Selvakumar, Scientist G, DRDO, Bengaluru. Respected Professor Dr. K. Kadirvelu, Scientist G from DRDO, Bengaluru. Chief guest, Professor M. Lakshmanan from Bharidasan University, Tiruchirappalli. Respected Professor and my esteemed colleague, Dr. P. Thangaraj, Director, Research and Industrial Collaborations for Kangeyam Institutions, heads of departments, faculty members, participants from other institutions, ladies and gentlemen. Good morning once again. I'm really happy to propose the welcome address on behalf of Kangeyam Institute of Technology. I take this opportunity to congratulate the organizers, the Department of Science and Humanities, in particular the Department of Physics, for having taken the initiative and organizing this international conference. This is a two-day conference being organized by the Department of Physics for 26 and 27 September. Thank you for the support from the DRDO. I think they have sponsored this conference. A special thanks to Dr. Selvakumar, who has been a constant support for all of us. Ever since he visited the campus, he has been pushing us to organize this international conference. A few words about the Kangeyam Institutions and Kangeyam Institute of Technology to the respected dignitaries on the dais. Says Kangeyam Institute of Technology was started in the year 2009 under the auspices of Erode Builder Educational Trust. Initially, it was started as Erode Builder Educational Trust group of institutions. Now, the institution has been named as Kangeyam Institute of Technology, since we have two more institutions under the banner of Kangeyam Institutions. The other two institutions being Kangeyam Institute of Commerce, which is an exclusive commerce college, and we have Kangeyam Institute of Pharmaceutical Sciences and Research. The vision of the management is to become Kangeyam University by 2030, with the able support from the management and the dedicated faculty members, and this vision should be a realistic one. Coming to Kangeyam Institute of Technology, this is an autonomous institution offering 9 undergraduate programs and 4 PG programs. The institution is accredited by NAC with A+, and all eligible undergraduate programs are accredited by NBA. The total intake for this year is 600, and there are 1,889 students pursuing undergraduate and postgraduate programs. There are 122 faculty members, out of which 45 faculty members are with PhD, and the other faculty members are pursuing PhD. The idea is to have faculty members with PhD across all the departments. The institution is recognized as a research institute by Anna University, which means all eligible supervisors can guide PhD, not only for insiders, for faculty members outside the institution as well. The institution is promoted by Erode Builder Educational Trust. Sri N. Ramalingam is the chairman of the institution, and Sri C.K. Venkadachalam is the secretary, and Sri S. Anandavadivel being the correspondent, and Sri C.K. Balasubramanian is the treasurer of the trust. So this is about the institution and the trust. Now coming to the conference, it is supported by, financially supported by DRDO, thanks to the magnanimity, and with your support, and we are able to attract large participants across India, and hope this two-day international conference will provide a lot of insights into the topics mentioned. It is advanced multifunctional materials and non-linear dynamics for strategic defense, biomedical, energy storage, climate, and civil applications. So these are the topics I think that are covered under this conference. I always believe that this particular subject, physics, is very, very important from engineering perspective, because electronics being an extension of physics, and we should give a lot of importance to this subject when we frame the curriculum. So therefore, I'm requesting the experts on the dais to be part of our academic deliberations when we frame syllabus. You can help us so that the students will be industry ready when they leave the campus. I hope this two-day deliberations will pave a way for the researchers and the faculty members to come out with a lot of research proposals and publish quality journal publications. So with these few words, once again, I take this opportunity to welcome all the dignitaries on the dais and the participants from different institutions. Thank you very much.
Thank you, sir, for your encouraging words. Your support gives our meeting a sense of purpose and excitement.
It is our privilege to listen to the chief guest address. I request Professor M. Lakshmanan to kindly deliver the address and grace us with his words.
guest address. I thank the college for their kindness of inviting me to this very nice international conference on advanced multifunctional materials and nonlinear dynamics for strategic defense, biomedical, energy storage, climate, and civil applications. A very interesting topic of multidisciplinary departments of humanities and science, in particular the Department of Physics, having thought of organizing such an interdisciplinary meeting at this college. I am sure after hearing the broad perspective of the Kangeyam Institute of Technology and in particular Kangeyam Institutions people had described will definitely end up in the formation of Kangeyam University in the near future, and I wish to convey all my best wishes. I must also congratulate the organizers of this meeting, in particular Dr. Prakash, Dr. Shyam Vinod Kumar, and Dr. Premlata for having taken all these efforts to organize this meeting. When you look at the speakers and the kind of topics they are going to discuss during the next 2 days, it's going to be extremely exciting and of interdisciplinary nature. Advanced multifunctional materials and nonlinear dynamics. They appear to be somewhat disparate, but if you look at closely, these two areas are quite interrelated, as I hope to explain in my detailed talk. And as the principal mentioned, physics is a very important aspect of engineering sciences. In particular, in my own example, for example, many years ago, when one of my former students, Dr. Murali, who had later become a professor at Anna University, when he was a PhD student, we happened to collaborate with an electrical engineer, a well-known electrical engineer, Leon Shua, from the University of California, Berkeley. And we invented a new electronic circuit, which is now called Murali Lakshmanan Shua circuit. In the literature in nonlinear dynamics, MLC circuit, which is considered to be a very basic electronic circuit to explain the behavior of basic nonlinear dynamics, bifurcations, chaos, complexity, and so on. And when you consider a large number of such MLC circuits interconnected, you have a very large network of nonlinear dynamical systems exhibiting very complex behavior. So this collaboration lot of experts on advanced multifunctional materials from DRDO and other institutions who are going to give talks on these advanced materials, and I do hope that young people will get benefited from this from these lectures. So these few words of inauguration, and once again congratulating the college, the principal and the faculty members, as well as the faculty members of the Department of Physics. Let me start directly my lecture on nonlinear dynamical systems and networks. Can I start with my transparencies? Anima? Oh, thanks. Okay. So, with those few introductory remarks, I would like to conclude my inaugural address. And then, as soon as the vote of thanks is completed, I will start with my lecture. Okay. Thank you very much.
Thank you, sir, for your valuable and encouraging remarks. Science becomes most radiant when it uplifts humanity, and we are blessed with such examples among us today.
We now come to a symbolic and significant moment, the release of the abstracts. This release marks the scholarly essence of our gathering, showcasing the collectivity, knowledge, and contribution that enrich this event. I request our chief guest, along with the dignitaries, to kindly release the abstract volume.
Thank you, sir. The release of the abstracts is a proud reminder of the academic spirit we uphold.
We now invite Dr. T. Prakash, convener ICAMND 2025 and Associate Professor, Department of Physics, to deliver the vote of thanks.
Good morning, everyone. With the spirit of gratitude, I rise to deliver the vote of thanks on this september occasion of the International Conference on Advanced Multifunctional Materials and Nonlinear Dynamics for Strategic Defense, Biomedical, Energy Storage, Climate, and Civil Applications. At the outset, I extend my profound gratitude to our chief guest, Professor M. Lakshmanan, Professor of Eminence, Bharathidasan University, and guest of honor, Dr. N. Dharmaraj, Dr. D. Selvakumar, and Dr. K. Kadirvelu for his inspiring and visionary address, which has set a meaningful tone for the conference. A special word of thanks is due to Dr. R.V. Mahendra Gowda, CEO of Kangeyam Institutions, for his motivating address, and to our beloved principal, Dr. S. Ramkumar, and Director RIC, Dr. P. Tangaraj, for their continued support and guidance in making this conference possible. My sincere appreciation goes to the organizing committee, faculty, colleagues, staff, and our student volunteers whose tireless efforts have shaped today's success. Last but not least, I thank all the delegates, participants, and well-wishers who have joined us today. Your presence endears the spirit of this conference and inspire us to continue striving for academic excellence. On behalf of the Department of Physics, KIT, I once again express my heartfelt thanks to all. Thank you.
Thank you, sir. With the formal inauguration beautifully concluded, we now step into the heart of ICAMNT 2025, the scientific sessions.
It's an honor to introduce Professor M. Lakshman as the distinguished speaker of this session.
I request Dr. P. Shyam Kumar Vinod, AP, Department of Physics, to introduce our speaker.
I feel immense pleasure in introducing our distinguished speaker, Professor M. Lakshmanan. Professor M. Lakshmanan is Professor of Eminence, DSTNR of National Science Chair. Currently he is in Bharatdasan University, Tiruchirappalli. He is a world-renowned theoretical physicist and a pioneer in the field of nonlinear dynamics with nearly 5 decades of research and teaching experience. He has made fundamental contributions to solitons, chaos theory, and their applications across physics and engineering. With over 400 international publications, 22 books, monographs, and nearly 20,000 citations, Professor Lakshmanan is among India's most influential scientists. His research leadership has been supported through numerous high-impact projects, including the establishment of the Center for Nonlinear Dynamics at Bharatdasan University. He has guided nearly 36 PhD scholars, delivered invited lectures across the world, and served on national and international scientific committees. Professor Lakshmanan is the recipient of prestigious awards including S.S. Bhatnagar Prize, Dr. APJ Abdul Kalam Award, Rashtriya Vigyan Puraskar Vigyan Shri, and the Lagrange Award for Lifetime Achievement in Nonlinear Physical Science. His international recognition includes being cited a foreign member of the Royal Academy of Sciences, Sweden, and a fellow of TWAS. He continues to inspire generations of researchers in India and abroad with his leadership in nonlinear science. Now I invite Professor Lakshmanan to deliver his talk.
And following this introduction, the stage is graced by pioneer in nonlinear dynamics. I now hand over the dais to Dr. K. Kadilvelu sir to start this session.
So very good morning everyone. It's a great honor for me to listen to sir's lecture. So without further delay, let us have a listen to sir's lecture so that we can have after presentation we can have a discussion. Thank you very much. Sir, please.
So thank you very much, Professor Kadirvelu. No, why not? Some of the participants come to the front. They're all sitting in the back. This light is bothering. So thank you very much. Inviting me. So I plan to speak on the topic nonlinear dynamical systems and networks. So nonlinear dynamical systems, first I will talk about nonlinearity and dynamical systems, and then about networks, and then I come to the kind of topics I would like to discuss today. So I see a number of distinguished scientists, young researchers, and so on, who may not be familiar with these notions of nonlinear dynamics. Can you put off this slide? Do you need? Yeah. So what is nonlinearity? So the main aim of my talk is to present an overview of the relationship between dynamical systems and network. Dynamics, things that evolve in time. Anything and everything that emerges in this universe keeps on changing. Change alone is unchanging, as Lord Krishna tells Arjuna during the war. So, matram enbade marada ondru. So, to describe these changes, about 4 centuries ago, the great Isaac Newton formulated the basic laws of physics, in fact, basic laws of science, in the form of the 3 laws. Laws of motion. Motion means something moves, something changes. So about changes. In particular, the second law states that the rate of change of momentum is directly proportional to the force acting on the system. So as the force acts on a particular system, changes do take place. To consider any physical system in this universe, one or more forces are all the time acting on the system. So take the case of a pendulum, simple pendulum, which you do experiments in your high schools. So you have restoring force. So like that, take any physical system or biological system, living systems or non-living systems, one or more forces are acting. So changes do take place. How do you describe these changes? Changes are represented in terms of differential equations, where the dynamical variables like position, momentum are the dependent variables, and they depend on the independent variable, namely the time. So you have differential equations as fundamental entities describing the evolution of physical systems. But these differential equations, you can distinguish between linear and non-linear systems. Linear systems are characterized by linear superposition principle. So take the case of a second order differential equations. You can have 2 linearly independent solutions if the differential equation is linear. Then the sum, the linear sum, is also a solution. So this linear superposition principle leads to lots of interesting further possibility of identifying the properties underlying these systems. So linear systems are smooth and continuous, and all their physical properties can be easily identified. But once you have non-linearity present in the system, the underlying dynamical equation is a non-linear dynamical equation, non-linear differential equations. But these non-linear differential equations are characterized by invalidation of linear superposition principle. As a consequence, you have very little possibility of completely solving these systems. But in turn, the analysis of such systems in recent times has shown lots of fascinating facts, bifurcations, chaos, complexity, non-linear ways, in characteristically differing from linear ways which we are familiar, like throwing a stone in a pond. So you get progressing waves. The linear superposition of these waves can form wave packets, but these waves disperse and die down in due course. That's how when you send information from a radio station or a television station, they spread, but they disperse, die down after a certain distance or time. So the question arises whether you can have localized waves of permanence, permanent waves like a tsunami. Can you have such waves? Yes. if you have appropriate nonlinearity and so on. So the study of such nonlinear dynamical systems has got impetuous. The modern origin of this nonlinear dynamics started in the beginning of 1950s, at the end of the World War in the 1950s, 1940s, and the facilities that were created for the war purpose, in particular at Los Alamos National Laboratory in New Mexico, where physicists, engineers, mathematicians, and so on, at the advice of Albert Einstein to President Roosevelt, to overcome the kind of the weapons that Nazi scientists are trying to identify. So Albert Einstein suggested to President Roosevelt, unless you make suitable effort to overcome this, collect top scientists and make coordinated research, the Axis countries will overcome the whole world. So he advised. President Roosevelt listened to Albert Einstein's suggestion, and he formed a group of scientists very secretively at Los Alamos in New Mexico, which is a very remote part of the United States. And this Los Alamos National Laboratory is still there. A lot of defense-related research is being done, where scientists from other countries are also allowed to visit, but they are allowed to work only in the periphery of the lab. I do visit Los Alamos fairly often. Even next month I am going to visit the lab. But you are not allowed to enter into the interior of this lab, so we don't know what kind of research that is going on. But in that lab, so a lot of activities were carried out during the late 1940s by great physicists like Hans Bethe, Richard Feynman and others. And due to their collective effects, nuclear bomb was discovered, atomic bomb was discovered. And then when this bomb was dropped on the cities of Hiroshima and Nagasaki in 1947, the World War II ended. But a lot of computers, for example, computers, John von Neumann and others had invented computers, and these computers were used by this for this research for atomic for invention of atomic bomb. So at the end of this World War, these facilities at Los Alamos were thrown open to scientists from universities. So early 1950s, Enrico Fermi was one of the leading figures who was associated with Los Alamos National Lab during the war effort, and he wanted to understand the working of a computer. Fermi, along with the help of John Pasta and Stanley Ulam, a mathematician and a computer scientist, she suggested these people, I am giving a particular problem, you tell me how this problem can be analyzed with the help of the computer, so that I will learn how the computer works. And that led to the problem of Fermi-Pasta-Ulam. So, my first point of discussion will be this Fermi analysis of Fermi-Pasta-Ulam unharmonic lattice, FPU lattice, and which led to the notion of nonlinear waves, solitary waves, and later on solitons, integrable nonlinear dynamical systems, which is very novel compared to linear dynamical systems, linear waves, leading to the notion of solitons. That was one of the important developments during the past 40, 50 years. FPU lattice dynamics and its analysis leading to the integrable soliton like nonlinear dynamical systems. But I will also point out, when you consider very simple weather dynamics, climate dynamics, one is the standard weather is described by a very complex system of nonlinear partial differential equations called Navier-Stokes equations. But a very simplified description of that was taken up by the meteorologist or physicist Edward Lorenz, again in the 1960s, which led to the notion of bifurcations, chaos, complexity in simple but nonlinear ordinary differential equations. When you study the dynamics of many such coupled systems, you get collective dynamical states, synchronization, and many new possible dynamical states. Well, all these things also leads to the analysis of very interesting biological systems, including the brain dynamics, neuronal dynamics, the underlying nonlinear dynamical equations, how the neuron allows propagation of information along the axons. And this analysis also led to, in recent times, the development of artificial intelligence, neural networks, and so on. So the connection between neuronal dynamics and nonlinear, neural networks, the study of neural networks, machine learning, artificial intelligence arises as a natural entity. And then, as a fundamental nonlinear dynamical systems, you can consider electronic circuits, which I mentioned in my introductory talk, the Murali Lakshmanan Chua circuit, as the simplest nonlinear dynamical electronic circuit. And then you study the dynamics of coupled such systems. So the networks of such nonlinear dynamical systems, and then you get fascinating novel results possibilities. Okay. So this is my broad description in the next 30 minutes or so. So this is the famous Fermi Pasta Ulam. This is Fermi Pasta, John Pasta and Stanley Ulam. So as I said, at the end of the Second World War and during the beginning of 1950s, Fermi, great physicist who was instrumental to the development of atomic bomb, he suggested to these people, let us consider this fundamental problem of an n particles. All these dots represent a mass point, an atomic mass point with mass m. All of them are equal mass. And they are connected through springs, through abrupt nearest neighbor coupling. So if I consider, for example, the ith particle, it's connected to the I minus 1 and I plus 1 particle, and there are finite number of particles, so the boundaries. So use the Newton's equation of motion as I mentioned just now. The rate of change of forces, the force, because of the nearest neighbor, you have the force between the ith and the I plus 1 particle here, and the ith and I minus 1 particle, the force, the rate of change of momentum for the displacement. So you have a collection of n coupled second order differential equations. These differential equations will become linear or non-linear depending on whether the force is linear or non-linear. And Fermi suggested three types of forces: non-linear force, a quadratic force Fy equal to Ky, that is a linear term, and a non-linear quadratic non-linearity alpha y square, and a cubic non-linearity Fy equal to Ky plus beta y cube, and then a broken non-linearity, which is again piecewise non-linearity. So for these three types of forces, he asked these people whether you can identify how the system behaves. So you consider these dynamical equations and go to the linear normal modes with the initial energy distribution. This is the famous Fermi Pasta Ulam experimental results, numerical experimental results. So what these people did was they made use of the Maniac 1 computer that was available at Los Alamos for this purpose. In those days, the early days of numerical analysis, numerically analyzed, given the energy distributions. So they have taken, for example, n equal to 64 mass points. So initial energy, you give the maximum energy to the first normal mode and all the other normal modes. This is the time axis, this is the energy of the normal modes, different normal modes. So first normal mode, maximum energy, the other normal modes, very little energy to start with. So analyze this as an initial value problem, the so-called quasi-initial value problem, and see how the energy gets distributed. And this distribution of energy, this is a large system, n equal to 64 mass points. So how this energy gets distributed is a statistical problem, a statistical mechanics problem. So you see, as the time increases, the energy gets mixed up. So all the modes gets energy redistributed. The theorem of equipartition in statistical mechanics seems to be valid, but to their great surprise, they found after a characteristic recurrence time, the initial energy comes back to the first mode and all the energy in the other modes get lost. This, if you continue the computation for any amount of time, after the same recurrence period, this phenomena repeats. So this is the phenomena of Fermi-Pasta-Ulam recurrence. So this had set in motion lots of questions to physicists and mathematicians at that time. How is that this system connected, coupled through non-linear forces, does not follow equipartition theorem? Does this mean statistical mechanics is wrong or anything fundamentally wrong in our understanding? And this analysis of this problem led to a lot of physicists and mathematicians scrambling to understand what is happening. And one particular approach was taken up by this person, Martin Kruskal, and his co-workers, Norman Zabusky, and later on Gardner, Green, and Mura, and Kruskal in a joint paper. They analyzed this problem as a continuous system. I said, here there are 64, n equal to 64 particles. Well, it's fairly large. You can extend this to n equal to 128 or even very, very large number. So in that case, you can treat this as a continuous system of mass point. In that case, you can go to the continuum limit. So this is standard procedure in physics. In basic physics, you do convert the discrete number of differential equations into a continuous differential equation. And then after certain transformation, you end up with a particular non-linear partial differential equation in certain leading order. So this is the third order non-linear partial differential equation. Why non-linear? Because of the middle term, the 6u du by dx. And because of that term, the linear superposition principle fails and the standard wave phenomena does not occur here, the wave packet. The dispersion, the linear dispersion does not occur here. Instead of that, this system admits a very interesting structure, completely localized structure. So you have a solution. These people showed in their famous paper that this system admits a solution of the form, some amplitude c by 2, secant h square root c by 2, x minus again ct. The amplitude occurs here. So that means the larger size of the amplitude and the velocity will be higher and vice versa. And more importantly, this has a structure of hyperbolic secant h, which means you have a completely localized structure. The standard wave will be infinite number of progressing waves. But here you have a completely localized structure. So this is a solitary wave. And later on, they went on to show that you can obtain even more general solution, for example, corresponding to two solitary waves. So larger one and then a smaller one initially. By construction, as I have pointed out, the velocity is directly proportional to the amplitude. So that means the larger wave will soon interact with the smaller one, catches up with the smaller one, interaction. After interaction, the larger one will comes to the right and smaller one to the left, as if two billiard balls are colliding. So when two billiard balls collide, they get scattered. So they don't lose their shape or speed except for a phase shift. So solitary waves, they call as solitons, just like protons, neutrons, etc., because due to that stable structure. Thus, they have identified the Quatermain-de Vries equation as admitting the stable soliton structures, and later on they went on to solve the Cauchy initial value problem by developing a new mathematical technique called inverse scattering transform. So that Cauchy initial value problem associated with that system is completely solved. Later on, over the years, many important dynamical systems, for example, I had shown in the year 1977, the magnetic solitons, Heisenberg ferromagnetic spin chain, is a vector nonlinear differential equation that again admits soliton structure, similar soliton structure in optical fibers, wave propagation in optical fibers, intense laser beam when you send, it satisfies the nonlinear Schrodinger equation, and the associated wave packets satisfying the solitonic picture, Sine-Gordon equation, soliton equation, and so on. In recent times, we have shown in my group that coupled nonlinear Schrodinger equations again admit this kind of soliton structures, very fascinating newer type of collision properties, and soliton molecules can be identified, and many novel properties, vector soliton molecules can be identified, and their collision properties can be, different properties can be discussed over the years. So thus, at this point of time, so there are many other possible localized structures these nonlinear partial differential wave equations can admit. So one class of nonlinear dynamical systems admits very novel localized structures with very fascinating collision properties, solitons and their generalizations. So that is one aspect of nonlinear dynamics. There are many properties. You have rogue waves, breathers, and so on. So I'm not going into that details further. So that is a fascinating area, the theory of integrable soliton dynamical systems. Now, diametrically opposite kind of structures can also emerge when you study even simple nonlinear dynamical systems. Which systems will show the kind of property I have pointed out just now, and which dynamical systems will show the new properties I'm going to point out. It's very difficult to answer that question, though some progress in recent times have been made. So, this is a model called Lorentz attractors, or Lorentz system. So, Edward Lorentz is an atmospheric physicist working at MIT in 1960s. So, as I pointed out earlier, the weather dynamics, climatic weather, is represented by what is known as Navier-Stokes equation, a highly complex system of nonlinear partial differential equation. And through appropriate reduction mechanism, Edward Lorentz reduced that equation to a simplest possible description in terms of three variables. A first order total differential equation, dx, x dot means dx by dt, y dot means dy by dt, z dot means dz by dt, where x is the amplitude of convection and y z are the temperature variation in the horizontal and vertical directions. So you can reduce the dynamics to this particular system of simple but non-linear differential equation. Why non-linear? Because of the term xz and xy here. Otherwise, it will satisfy linear superposition principle, but because of that term, this becomes a nonlinear differential equation. And this simple system of nonlinear differential equation, there exists no way of exactly solving this dynamical equation. But more interestingly, for appropriate parameter, for example, if you integrate this equation and plot numerically x versus t, using, for example, Runge-Kutta fourth order method. This is a very simple dynamical system. Any of you can take up this problem and try to solve this numerically with appropriate initial conditions. So I am plotting x of t versus time. Now this is a bounded dynamical system. So I start with certain initial value here, and then integrate, suddenly it increases, but then decreases, but not periodically, but irregularly it changes. Since it is bounded, it always changes, but increases, decreases, etc. And more importantly, if you plot these dynamical variables, for example, if this is y, and I plot this for a particular initial value to start with, I am plotting this in two curves. First, I start with one initial condition, and I draw the time series. And then I take an initial condition which is extremely close to the previous one, and I plot it in terms of a blue curve. But initially, you don't see the distinction between these two curves, the pink curve and the blue curve. The pink curve corresponds to one initial condition, and the blue curve corresponds to another initial condition which is extremely close to that. You see, these are all initial value problems. So, for the first initial value, you have this pink curve going like this, aperiodically, but bounded. Okay, it goes like this. Then I start with the next initial condition, plot it in a blue curve, but since initially there is no distinction, you don't see the distinction. But here there is some deviation, but here if you come to some 400 time units, etc., these two curves deviate, and then this deviation can be as large as the system size itself. And this goes on repeating. So, on the average, we see these two curves exponentially diverge. So that means, what is the significance of this? For example, weather dynamics. You start with initial conditions very close by, but after a finite time, they can deviate, the developments can deviate from each other enormously. This is called Lorentz phenomena. As small as a butterfly fluttering its wings somewhere in the Amazons. So where is Amazon? Amazon is in South American continent, in Brazil, for example. So to exemplify the kind of phenomena that emerges out from this analysis of this simple set of nonlinear differential equation, one points out that as small as a butterfly fluttering its wings somewhere in the Amazon can lead to a tornado, a cyclone-like situation in the state of Texas in a few days' time. Had the butterfly not fluttered its wing, the weather would have developed in the state of Texas. Where is Texas? Texas is in North America, North American continent in the United States, very far away. So, the weather would have developed in a particular place. But here, because of the next initial condition, just the butterfly fluttered its wings. So that means there is an extremely small change in the initial condition. Because of that, the weather would have developed into a tornado, a cyclone-like situation in the state of Texas in a few days' time. Small changes can lead to very large changes. Prediction becomes impossible under certain circumstances. After all, the basic idea of science is what? Is to make prediction. That's what Newton's law tells. You can write down the equation of motion, you can make prediction by solving this Newton's equation of motion, how the planet where the planet will be situated next year, after 100 years, 1,000 years, a million years, and so on. Different planets, solar systems, stars, and so on and so forth. But here you see, yes, I formulated the equation in a very simple way. Yet, because of this nonlinearity, small changes can lead to very large changes. Prediction becomes impossible. And this I can demonstrate in the form of examples of very many other systems. The Duffing oscillator, a second order equation with cubic nonlinearity and forcing, driven van der Pol equation, Matthews-Fluxman oscillator, which as a student, a PhD with my mentor, P.M. Matthews at the University of Madras, we identified this system, but at that point, not damping and forcing, a very nice regular system. But later on, during the past 20 years or so, we had found that with forcing, damping and external forcing, this system also shows such complexity, sensitive dependence on initial condition. Very recently, a general Lennard type oscillator in my group we have identified. So, all these behaviors as a function of one of the parameters, for example, there are several parameters, control parameters, for example, the forcing parameters. So, for small values, you have a periodic motion, then period doubles at a critical point, that is called bifurcations. So, period 1, it loses stability. In place of that, you get period 2, and then suddenly period 4, period 8, period 16, 32, and so on in very narrow time. And then very complex states, and that is where sensitive dependence on initial condition arises. And that is chaos, complexity. So very simple, even very simple nonlinear systems can show this kind of complex bifurcation behavior, ultimately ending up in chaos, sensitive dependence on initial conditions. If, for example, in this case, if I drop this nonlinear term, no such sensitivity will arise, no such bifurcation will arise. Only because of the introduction of nonlinearity, this bifurcation arises. Now you can ask the question, what happens if I couple many such systems? Couple the networks of oscillators. Then you can make coupling in very many ways. For example, nearest neighbor coupling. Each oscillator is connected to the nearest neighbor, as in the Fermi-Paz-Tavula lattice. Or each oscillator is connected to all the other oscillators, global coupling. Or each oscillator is connected to some L number of nearest neighbors, non-local coupling, and so on. So you can consider the coupled dynamical system, and then ask on many other networks, multiplex networks, multi-slice networks, and so on, networks of networks, and so on. You can ask what kind of collective dynamical states. I said individual systems lead to very different kinds of periodic dynamics and then complex dynamics. But when you connect these various dynamical systems, what kind of novel structures can arise? So I have different kinds of synchronization. All oscillators, even though evolving chaotically, they evolve in a synchronized way or desynchronized way. Very many possible synchronizations. And then part of the systems are synchronized and partly desynchronized. We call as chimeras, like YALI. Chimera states, amplitude chimera, frequency chimera, cluster states, steady states, and so on and so forth. So these are the typical examples of these various collective dynamical states. And then characterization. In my group, we have given how you can characterize these states, and I'm not going into the details. So that is network dynamics. Now from network dynamics to artificial intelligence and machine learning, how the connection comes. So you know, the human brain, you take this brain, take a slice and go to the fundamental unit, neuron. I think many of the students will be familiar with neuron. And the neuron has three basic entities. the central soma nucleus, the dendrite tree-like structures emerging from this, which collects information from other neurons, and then axons, electrical cable-like structures, through which information propagates in the form of electrical signals. So this is a single neuron, then you connect 2 neurons, 3 neurons in networks, different kinds of networks, and you have very complex dynamical systems. How do you describe this dynamical system? So you see the neuronal firing patterns, regular spiking, phasic spiking, tunic spiking, and so on, adapting, chattering, and so on, different kinds of information propagation along axons. And these are obtained from different neuron models to capture this earlier firing pattern I mentioned, Hodgkin-Huxley model, Fitzhugh-Nagumo model, simplified version, Hilmar-Rose model, Iskevich model, and so on. Through different couplings, local coupling, non-local coupling, global coupling, random coupling of neurons. And for example, the fundamental neuron model was developed by Hodgkin and Huxley in the 1960s for the membrane conductance, membrane voltage, V, conductance, activation and inactivation probabilities, etc., in the form of these differential equations. This nonlinear system of complex nonlinear differential equation by treating the axons as a cable. Just like you develop cable equations in physics for electrical wave propagation, you can identify the simplest fundamental unit of axon in terms of these electrical components, and then you can write down these equations of motion. Hodgkin-Huxley equation, for which they got Nobel Prize in 1963, I think, for physiology, Hodgkin-Huxley model. And there are various simplifications, Fitzhugh-Nagumo, Iskevich model, and so on and so forth. So analyzing these models for single neuron and couple them, many such, couple them appropriately, simple coupling or complex coupling, in memory-state, but recent times one use memory-state synaptic coupling, you can get all these kinds of buzz I mentioned. So lots of progress has been made in understanding neuronal dynamics. And this also leads to, in very recent times, relate to artificial neural networks, which is a subset of machine learning procedures. And machine learning is a subset of artificial intelligence. In recent times, both engineering students and science students, physics students, you all heard, frequently hear the words artificial intelligence, machine learning, neural networks, and so on. So information can be propagated now through artificial neural networks. Data, if you have large number of data, just like neurons, you have inputs. Feed in the inputs, and then, so that's a neuron-like structure. And you have large number of hidden neurons, these dots. And this information is fed into these different neurons through appropriate weight functions. W11, W12, W2 through, for example, an active linear function. And then these neurons interact and the output is collected through appropriate weight functions. You get the output and you connect that, relate that to target output. If there is a difference, then you feed back and then you try to reduce the difference. So this way, you can try to use machine learning algorithms to artificial neural network. There are different kinds of artificial neural networks that have been developed. K-means clustering, random forest, convolutional neural network, recurrent neural networks, and then so many associated memory retrieval algorithms can be developed, like half-wheel neural network, Boltzmann machine. In 2024, the Nobel Prize in Physics was given to two scientists for identifying this, half-wheel, and another person for identifying this neural network in Boltzmann, using Boltzmann machine and so on. So physics is intimately related to these engineering developments. So there are many other prediction algorithms, which I don't have time. So this is a reservoir computing which we had developed in my group, where I use nonlinear system as a reservoir. I have inputs and outputs. I train reservoir as a training set. Using this reservoir, training the system from given inputs for a set of outputs. I use for unknown inputs for a unknown set of data to extract the outputs. So that is the reservoir computing. So lots of details. Finally, couple of minutes, electronic circuits, nonlinear dynamical systems, electronic circuits. So this is the Murali Lakshmana Chua circuit I mentioned in my introductory talk. So that's nothing but the standard LCR, the inductor, capacitor, and resistor with an external source. This is a sensing resistor. So this LCR circuit, you are all familiar, students of physics or students of engineering. You are all familiar in your basic electronics experiments. You study that. The outcome is, you see in a CRO as a closed orbit, a limit cycle, limiting periodic oscillatory motion. Now, to which I add a non-linear resistor in parallel. That is what is called Chua's diode. So this is what Murali Lakshmana Chua in the year, 1995 or slightly earlier, 1994, in IEEE proceedings, we published this. So this Chua's diode, normal resistor is a positive slope curve, straight line passing through the origin. But this resistor N has, apart from that positive slope, you have a 3 piecewise linear negative resistance. Piecewise linear is a highly nonlinear form, but you can write its form exactly. In each piece you have a linear term. So introduce that nonlinearity. You write down the Kirchhoff's law for the current and voltage. You get this coupled system of nonlinear differential equation. And numeric, this cannot be solved exactly over the entire range. You can go to your computer, use piecewise, Rinjikuta fourth order system, and you see bifurcations, period 1 oscillation, period 2, period 4, etc. And then chaos, this numerical analysis. This is experimental. Initially, if you, for example, if you change the resistor, a periodic oscillation, period doubled, period 4, and then very complex chaos, double band chaos, and so on. So this is the corresponding structure. Period doubling route to chaos. Now you connect such oscillators, for example, nearest neighbor. You ask what is the kind of structure emerges. You have spatio-temporal patterns emerging. So you have lots of spatio-temporal periodic and chaotic oscillations, etc. emerging. You can consider cellular neural nonlinear networks and then analyze their structures and so on. Very many interesting developments take place and so on. I'm not going into the full details. So, to conclude then, I have discussed in my talk 4 possible nonlinear dynamical systems involving networks. The first one, the Fermi-Pasta-Ulam lattice and its generalization, which led to the idea of non-linear waves and localized structures in the form of solitons and their generalized versions. Completely integrable, infinite dimensional, non-linear dynamical system, very novel phenomena. But on the other hand, I had also considered some simple non-linear systems which can exhibit sensitive dependence on initial conditions. And when you couple such oscillators in very many complex ways, different topologies, they give rise to very many fascinating, novel, collective dynamical states. That is one possible, another possible outcome of nonlinear dynamics and networks. Then I came to biological systems, namely neuronal systems, starting from basic neurons and its dynamics, which can be deduced from Harkin-Huxley analysis. Then connect such neurons in all possible complex way, then you get different kinds of bursts which you identify in the analysis of neuronal dynamics. But this analysis has also led to the possibility of making use of information from large amount of data in the form of artificial neural networks, machine learning, and reservoir computing. Finally, I pointed out that you can consider even simple electronic circuits, which you are all familiar in your labs, like LCR circuit. Connect to it a nonlinear element, in my case, a nonlinear resistor, a Chuvas diode. If you do that in an appropriate way, and then you change, for example, one of the components, the resistor or capacitor, whatever it is, then you see period doubling, bifurcations leading to chaos, sensitive dependence on initial conditions. All information that you study obtained from Lorentz equations or other nonlinear oscillators can also be obtained from the study of, for example, MLC circuit. Then you connect large number of such MLC circuit, you identify interesting spatio-temporal patterns, complex nonlinear networks analysis. So thus, there is a close connection between our understanding of natural systems and nonlinear dynamics and networks. I think with that, I will conclude my talk. Thank you very much for your attention. If you have any questions, comments, I will be happy to answer.
Thank you, sir, for a very informative, very advanced lecture. Rakshya Vigyanashri, Vigyan Puruskar and Vigyanashri Physics Professor Lakshman, sir, has given a very clear talk about nonlinear dynamic systems and networks, starting from introduction to Fermi-Pasta-Ula and integrability, and also bifurcation chaos, including your coupled techniques in networks, as well as your collective dynamic status, and also neural dynamics and electronics in cellular neural networks. So finally, very clearly concluded. I think it's very useful lecture to all the youngsters assembled here. With it's based on the kind of time, we can allow one or two questions. Please come forward.
Yeah, you ask any questions.
Please,
any
complex,
it doesn't matter.
Please.
You have fundamental doubt. If you want, you can ask. I can answer. Yeah, please.
Thank you, sir. Sir, some of the equations you have fantastically solved and find the solutions for the several existing systems. I want to know whether the solutions applied for the bulk systems are applicable same to the nanomaterials of the latest findings also.
Yeah, I mean, if you treat the materials as a system of collective networks, then starting from your understanding of the individual individual nodes, you can try to identify collective dynamical states. And from that point of view, the nanomaterial properties can be explained in certain way. I think efforts are being made, and I think the lecture by Professor Jürgen Kurz perhaps will be related to that kind of aspects.
Thank you.
Sir, you are very clearly explained from simple to complex systems.
Which one?
Simple to complex solving systems. If you look at recently in the field of synthetic biology, structural biology, computational biology, how we can apply this nonlinear dynamics in that system? Any ideas, sir?
Yeah, I mean, the first, the individual nodes, how the nonlinearity comes in. So that will lead to different kinds of dynamical structures, dynamical states, as I said, through bifurcations and then chaos, sensitive dependence and initial conditions and so on. And then how you couple them, individual nodes, how they are connected. They can be connected in very many possible ways. The topology of the system, so you can have just nearest neighbor connections or global connection. Each node is connected to all other nodes or to a finite number of nodes in a particular way and so on. So depending on this connection, the ultimate collective dynamical states for the entire systems can differ. Okay. Novel structures can emerge. So that you have to investigate, depending on the nonlinearity, on the nature of the coupling and so on. So that will give you novel, newer and newer results. Yes.
Any questions from audience? Faculty members? Otherwise, thank you very much, sir.
Okay,
for a very wonderful talk.
Thank you.
Thank you, sirs. With the wisdom shared and ideas flowing, it is now time for refreshment. We will gather again after a tea break. The refreshments are arranged outside the hall. The participants are requested to have your tea. Thank you.
I now request Dr. N. Dharmaraj, Professor of Bharatiya University, Coimbatore, to honor and give memento to Dr. Professor M. Lakshmanan. I request the participants to take the refreshments which is arranged outside the hall. I repeat, I request the participants to have the tea outside the hall. You can just arrange back after 10 minutes.
at Bharatiyar University, Coimbatore. With an illustrious career spanning more than 25 years in teaching and research, Dr. Dharmaraj has made significant contributions in the field of bioinorganic and coordination chemistry, catalyst, nanomaterials, and spectroscopy. He has guided numerous PhD scholars, published over 60 high-impact international papers, and his research has been cited nearly 6,000 times. Reflecting the wide influence and relevance of his work, his scientific standing is further highlighted by an impressive H index of 38. Dr. Dharmaraj's career includes prestigious international appointments, including serving as a postdoctoral researcher and brain pool visiting professor abroad, as well as being an INSA exchange scientist. He has been invited to speak at several international conferences where his research on metallodrugs, nanomaterials, and advanced catalysts has been highly acclaimed. Through his scholarship, guidance, and dedication, Dr. Dharmaraj has played an integral role in advancing chemical science in India and beyond. Ladies and gentlemen, please join me in welcoming Dr. N. Dharmaraj.
Good morning, everybody. It is my privilege to to be chairman for this session. And under this session, there will be two lectures will be there. One by from Professor ND, we call him very fondly, Professor Dharmaraj, who is also a guide to me during my PhD when I did my PhD under him in Bharatiya University. He is an eminent professor, a good academician, and with respect to the research, he is also into the basic as well as applied research. Applied in the sense, lot of like you take anything like catalysis or gas sensing or biological applications. He has contributed a lot to the scientific community with respect to the materials and also the coordination compounds in inorganic chemistry. I welcome Professor ND to deliver his lecture. Thank you.
Thank you, Dr. Selva Kumar. It's really a wonderful opportunity. My student is introducing me for this session, and he is the chairperson for the session, and he rightfully deserves to be a chairperson for my lecture, since he is equivalent to me in terms of science and chemistry. Thank you. So my lecture will cover the fundamental techniques involved in the synthesis of advanced materials. That advanced materials includes not only nanomaterials, that may be bulk materials also. Generally, all the materials with some unique applications or peculiar properties are classified under the category of advanced materials. So the synthesis of advanced materials. Okay, so there are several techniques. I cannot go and brief all the available techniques for synthesis of advanced materials within 45 minutes or so. So I restrict myself to some of the basic techniques by which we prepare. Scientists from any labs used to prepare the materials with unique properties resulting in the applications of the materials. So what are actually the need for the advanced materials and where they find applications? You can see advanced materials are the materials which are having the innovation, and they act as the driving for progress of the research, progressing the science to next level with unique properties are the advanced materials. So materials are advanced when they have an innovative property, thereby it leads to progress in the applications side. So where they can find large applications are in energy storage, the energy conversion, and the renewable energy technologies. Then in the case of environment, the pollution control and sensing and the remediation of the polluting agents using the advanced material as photocatalyst or some in many other ways. In catalysis, as a chemist, I am happy to say that these advanced materials are very useful catalysts for organic transformations in the large scale industries as well as in the pilot scales in research laboratories. Then in terms of healthcare, these advanced materials are used as diagnostic agents. The diagnostic agents are the one which will tell what is the problem inside the human body or any other biological systems. Once if you can give a good diagnostic result, then it is easy to understand the real problem, how to cure the problem using drugs, that involves the drug delivery and some other kinds of biomaterials. These are all the advanced materials and where they are significant in the world. Then what are the synthesis and characterization? And synthesis is nothing but the designing of some experiments and how to execute the experiment to yield up the required product. We may interest to get so many materials, but we may not be successful in all our attempts. There are some synthetic strategies which can lead to the production of some novel materials which are advanced in their properties. So we will see why we need to characterize. Once if you synthesize, then you need to characterize. The significance of characterization is, as a man, if I say I'm a man, we need to have some basic characteristics. If we say that I'm a woman, basic characteristic properties. Like that, when we say a material as a catalyst, a material as an energy storage device, or a photocatalyst, something unique properties must be associated with the material, and that should be known to others by way of characterization. So characterization is the fundamental tool which will tell you what is what. Only if you know what is what in science, you may be able to find an area where these materials can be applied. So for that sorts of applied purposes, we should know the characterization of the materials. That is why the characterization of materials gains significance in science than the synthesis of the material. Sometimes you may get a material by synthesis. If you don't know its properties, what is what, you may get confused where to use the material. So that is where the significance of the characterization lies. Then what the results we obtain from the characterization methods? Exactly, you may know what means the chemical composition of the material what you prepared. If you synthesize a new compound in your laboratory, we can get its composition through some of the characterization methods. Similarly, we know its exact structure, followed by the properties, particularly mechanical properties, surface properties, chemical properties, physical properties, optical properties, biological properties, so on. It's go on a lengthy way to say which are the properties associated with the materials. So some of the way how to know the material compositions by characterization and how to know the structure of the synthesized materials, what are its surface nature and what are their photochemical light properties as well as biological potentials, we will see in the following slides. So these are the ways how we can get nanoparticles or any advanced materials. Nanoparticles are certainly advanced materials with unique characteristics of the large surface area that leads to unique properties associated with the nanoparticles. Generally, advanced materials can be synthesized by two different methods, the top-down approach and the bottom-up approach. This top-down or the bottom-up approach is the basic methodology or the strategy for synthesizing any nanomaterials. Ultimately, the advanced materials with good functional properties. So there are more than several ways how you can prepare the materials. Just I say mechanical milling. It's by application of a mechanical force, just like a grinding of the bulk materials into smaller materials, you can bring down the size of the materials. And other one is electrospinning. This is a very novel methodology where you can make the fiber materials, nanofibers, through electrospinning. This is just by passing of electrical charge through a polymer solution, you will end up with the formation of the nanofibers, which are all very unique. The polymeric nanofibers finds a lot of medical applications. Inorganic metal oxides, where I am interested to work for past two decades or so, they are all good catalytic materials and photocatalytic materials. Anyway, they are all nanofibers prepared by electrospinning methodology. And laser ablation, these are all the various techniques, sputtering, then electron explosion. These ways you can make the advanced materials. But the other side, you can see there are other chemical approaches. Chemical vapor deposition, it's called CVD. You can take a metal organic precursors and you can just decompose it at high temperature. By vapor deposition, you will get the materials get deposited on the surface of your object or the substrate material by chemical vapor deposition. Then sol-gel, a well-known synthetic procedure for making any kind of metal oxides, particularly simple metal oxides, binary metal oxides, and even ternary metal oxides of three different materials or two different metals. They are metal oxides like magnesium titanate, tin titanate, zinc titanate, this kind of binary metal oxides, or lead zirconium titanium called ternary metal oxides, which are piezoelectric materials with their piezoelectric properties. That sorts of all metal oxides can be synthesized by a sol-gel method. This is the very basic material synthesis method in materials chemistry. Even now, this methodology plays a big role for getting very useful metal oxides. Then co-precipitation is another kind of just what we do in our laboratory for making a precipitate of mixing two different solutions. You will get the formation of a metal oxides or some metal precursors which can be decomposed to get the required advanced materials. Then molecular condensation, hydrothermal, like that salvothermal, these are all different synthetic strategies by which you may end up with the formation of new advanced materials that may have the nanoscale dimensions or little above the nanoscale dimensions, but all are very useful materials in terms of their advanced properties. In addition to this top-down and the bottom-up approaches, we have the natural way how to get a material using the greener or biological method. Now every chemist want to make a protocol for making the known compounds without use of much chemicals. That is what is the green chemical synthesis or the green synthesis of new materials with the help of the plants or even microbes, or you can see here plant extracts, then microorganisms and biomimetic one by which you can get some of the metals as a nanoscale materials. For example, you take the gold 3+, Au3+, you add some extract of the plant materials, they get reduced into gold 0. So that is the phytochemical reduction or plant organic extract based. Microorganisms are also capable of reducing the metal ions from the high valent oxidation state into zero valent material, which is one way of synthesizing without use of much chemicals. Then algae, bacteria, fungi, actinomycetes, protein cells, these are all the agents which can result in the production of smart materials without using much chemicals. No need to go for high temperature synthesis, no need of high pressure, large equipments are not needed for making these materials. So very basic way, using the available natural sources which are greener in their nature, we can prepare the smart or the advanced materials. Okay. As I said, the salt gel is one of the very basic technique by which you can make a solution of the required. If I want titanium oxide nanoparticle, we have to take the tip, titanium isopropoxide as the precursor. If you want any material, you should have a precursor suitable for that material. For titanium oxide nanoparticle, we start with the titanium isopropoxide, make a sol of it, allow it for gel to get a gel over a period of time. So the sol is a very dilute solution. During the gelation, it becomes a very thick or a viscous solution. Allow it for calcination to high temperature. You will end up with the formation of titanium oxide. Similar to that, you can make any metal oxide, most of the metal oxides, single or binary or ternary metal oxides using the salt gel technique. Why this salt gel is considered to be a very versatile method in materials chemistry is, you can have so many control over the experiments. The size, stoichiometry, properties and their nature can also be controlled through the salt gel methodology, and variety of mixed materials can also be synthesized making two different salts. If I want magnesium titanate, you take magnesium isopropoxide, titanium isopropoxide, mix it in our choice, maybe 0.5, 0.5 or 0.25 or 0.75 in our stoichiometric composition, allow it for gelation, go for calcination or sintering high temperature, you will end up with the formation of binary metal oxides. Similarly, as I said, the piezoelectric and the perovskite materials like lead zirconium titanate, barium titanate, all these can be prepared by the technique. Very simple technique, just two beakers you have, take the two different salt solutions, mix them, allow for gelation, go for heating to high temperature in the calcination chambers, you will get beautiful materials of our own choice in the required chemical composition. As I said, this is the way how we can go for salt gel technique to make the precursor materials. Then we go for calcination in the calcination chamber. Okay, another very useful technique, nowadays people go for making the same known titanium oxide, zinc oxide or indium oxide, gallium oxide. My own student Dr. Selvakumar has done enormous work on the salvothermal, hydrothermal synthesis of very useful metal oxides, even doped metal oxides as sensor materials. He worked a lot to know the oxygen sensing materials and their quick response time, recovery, reusability, all sorts of experiments have done by him, and we have obtained very good results published in the papers as well as his thesis. So this hydrothermal or the servothermal method is nowadays a very fascinating technique for making the metal oxides at low temperature. No need to go for high temperature and high pressure. Within the autoclave, you can make the, it's like a cooking of the food inside the cooker. You take the precursor, you choose the solvent for that, you put it in the autoclave, go for heating to very normal temperatures, not of so high temperatures. You will end up with the formation of beautiful materials. Here also, the size and the surface nature of the materials can be very well controlled if you add stabilizers, because he has done a lot of work on CTAP, cetyl tripe ammonium, as a surface or size controlling agent. So that way you can use a lot of size controlling or the stabilizing agents which will protect your material from agglomeration or aggregation. You will end up with a fine dispersed nanoparticles or very low dimensions. Okay, then as a chemist we always feel interest to do some chemistry. You take the metals in the high valent oxidation state, go for photochemical reduction just by passing. As I said, you take gold 3+, you pass 365 nanometer radiations to the Au3+, tetrachloroauric acid solution. Fine particles of gold 0 nanomaterials will be deposited inside the beaker just by a photochemical reduction, because the UV light is capable of reducing Au3+ into Au0. There also We have the CTAP and other size controlling agents, which we want to avoid the aggregation of the materials. You can control the morphology, control the size by adding some of the stabilizers or protective agents. He has beautifully applied polyvinyl alcohol as one of the size stabilizing agents during his synthesis of indium oxide, gallium oxide and other materials. There's a good chemistry in it when we go for size controlling with the molecules having the hydroxyl group, where you have the non-bonding electrons available in the oxygen atom. They will go and coordinate to the metals. Since we use metal oxides, thereby it controls the size. You can avoid the aggregation. So good chemistry involved in making the stabilization of nanomaterials synthesized by either hydrothermal or solvothermal, even in the photochemical reduction. In some cases, here we don't add the stabilizers. Once if you make a synthesis, you will know what is the size, how they get agglomerated. Then repeat the experiment by putting some of the stabilizing or the size controlling agents. You will reduce the size of the material. So this is how the research is developing from a very basic into some of the advanced materials with the required characteristic properties. Then phytochemical, I told in the beginning itself, using some of the plant extracts. You know, the plants are the good chemical laboratory. The soil itself is a good chemical laboratory where you have so many acids and basic things like the metals, you have phosphates, sulfates, nitrates are also there. Like that, the plant itself is a good chemical laboratory where you will have so many phytoconstituents which are very active in their own way. Some of them are good reducing agents because plant extracts, maybe from the stem or the bark or from the leaves, will have a lot of polyphenolic compounds. Almost all plants will have the good load of polyphenolic materials. Any phenolic component is capable of reducing the metals in the high valent state into low valent or zero valent oxidation. That is how the phytochemical reduction takes place. So you take the metal precursor, you add the phytochemical extract, you will find the formation of beautiful gold, silver or platinum, copper or nanomaterials inside the beaker. That is how the phytochemical, the responsible factor in that is the presence of polyphenolic compounds. Almost all plant extracts will have so many phenolic compounds. When you have more and more of hydroxyl groups, phenolic groups in the components, they act as a good reducing agents. Okay, so for some of the techniques by which you may prepare the advanced materials, there are so many methods. I cannot go and elaborate all the methods in the available time allotted to me. Something to know how we get the materials. So next, why we want to characterize. I got a material, straight away I can go and use it. No, scientifically you have to validate your material. The validation of your material can be done only by knowing its characteristic properties. That is why we have to characterize, to understand their chemical properties, physical properties and their structural characteristics. We need to do the characterization of the synthesized materials. So once if you know the synthesized materials properties, then only they will be converted into useful outcomes. If you know what is what, that can be selected for a selected area of application. For a gas sensing application, you cannot go with some of the alkali metals. You need to have a transition metals with semiconducting properties. That is how it works as a sensing material. So that can be understand if you do the characteristic analysis of the synthesized materials by UV visible spectra and knowing its band gap energies, you may select whether it can be a good gas sensing material or not. That is how he has identified some material. Even to tune the property, he has loaded with some other additives like platinum, palladium. Just they are all added to the existing tin oxide, indium oxide, gallium oxide, and they have altered the band gap energies of the material, which will be beneficial for sensing of the gases. So like that, we need to know the materials and their properties. Once if we know the property, we know its outcome, where it can be applied, and it can help to design the application of the materials, and that materials can be translated into technological applications. From lab scale to technological applications, you know, all the semiconductor materials are used in the chips. Directly they are not come into the computer applications. They have been synthesized, characterized, their band gap values have been estimated, they have been tuned, and their aggregations are avoided. Then finally they will come into practical or technological applications in the smart devices. So this characterization method will bridge the gap between the discovery. Discovery means the preparation. and their innovation, how it is innovative than the existing material, finally end up with the industrial use. So that is why we need to characterize the materials for changing this laboratory material into a technical device. Okay, so what are the available techniques? So since it's engineering college students and some of them with the basic, not of particular research focus, here attending the participants of this conference are one or two maybe from research labs, they may get interested. That's why I have made my lecture to be touching the very basics. Some of you may interested can ask me, or you can go through the literature, what we do or what others are publishing. So I am not going in depth of any technology. If I need to go for an in-depth discussion, only one characterization can take 1 hour or so. So we will see how they are useful or what is the fancy behind each of the characterization techniques. So these methods, FTIR, NMR, these are all some of the names given to the instruments. Like we say a computer, we say a printer, we say the so and so, like that. These are all instruments used in chemistry or material science for characterization. So structural characterization through XRD, X-ray diffraction. Morphology, the material's surface nature, how it looks, that can be analyzed with the microscopic images like SEM, TEM, AFM. Then surface properties, what is the surface area, how much pore size, pore volume, and how depth the pore, all these can be known with the surface characteristics through bed surface area measurements. And optical properties, light emission oriented properties. This is very useful. You know, now we have lot of LED materials. What are they? They are all metal organics. Okay, they are all some metal oxides with fluorescence emission properties, light, blue light, yellow light, white light, green light. Like that, their light emitting properties all can be known with the help of optical studies. Then finally it comes to how far the material is environmental friendly and human friendly. Whenever we chemists synthesize some material, we should not pollute the world, we should not harm the human nature. For that purposes, we need to understand how far the material is good for environmental or biological applications. For that purpose, any material before being recommended for use in biology or as a biomaterial, it need to meet out some of the characteristics like histocompatibility, biocompatibility, no side effect, no harmness to the human cells. All that sorts of analysis can be done before using any material for life science applications. For that kind of a characterization, we need to go for cytotoxicity assays. Suppose if a material is recommended as an anti-cancer agent, as a drug for cancer treatment, you should characterize it thoroughly. Then finally you should know their compatibility with the human cells also. For that purposes, we go for MTT assay. LDH is the lactose dehydrogenase release, which are all the consequences of cancer affecting the normal cells. Followed by DNA binding, protein binding. Why we need to know the protein binding, DNA binding? The mechanism of drug action for specifically cancer treatment. But for all other kind of a treatment also, the drug has to interact with the DNA and the protein of the body so that they will repair the damage in the body. For that, the binding ability of the drug molecules with the protein or the DNA is the very basic way to tell you whether there is a good binding between the drug molecule and the human system or not. Once if we evaluate the binding property of the synthesized material using the protein binding, DNA binding study, then you can recommend it as a material for further studies. It need to go for trial 1, trial 2, clinical trials before sending for biological applications. So that sorts of assays need to be done for biological usefulness. Then environmental concern, how far they are degradable or they are friendly with the environment or not. For that purposes, there are several studies which need to be done before recommending the material for environmental related applications. Even if you throw the material to the environment, we should know whether it is degradable or not, how it will pollute the environment, whether water body or the soil or the air. If any of the naturally available systems get disturbed by the addition of a new material, that leads to pollution. So all that has to be taken in care before recommending a material for any specific applications. So this is one such a technique where UV visible spectroscopy, some of you may familiar. The materials are possessed various types of electrons. the type of electrons present in the molecule can be understood through the UV visible spectral data. So how we know is the non-bonding electron, sigma electron, pi electrons present in the molecules will be elevated to the next level when you give energy to the molecule. So that n pi star, pi star, sigmas, these are all the type of electronic transition from the lower level to the higher level. So this electronic transition from one level to other level will tell you what kind of an energy is required for this electronic transition. Only this electronic transition and the energy band gap will decide what kind of light will be emitted from the material, whether it is a yellow light emitting, white light emitting, blue light emitting, or green light emitting. All sorts of these applications will be determined if you know fully the UV visible characteristics of the material. In the case of metal oxides, beyond these things, we have charge transfer transition and DD transition. Chemists may feel happy to hear that they will undergo DD transition from d orbitals, or charge transfer from metal to ligand or ligand to metal. So all these properties will decide whether a material is useful to some specific applications or not. So how to record the UV visible spectra? We have a UV visible light source that will be focused through a small, you see this light comes through a small slit, a small orifice. Like that, the UV visible lamp emits the light, passed through a small slit, then that will be selectively sent to the sample through this dispersion prism. It is nothing but a prism which will filter off the unwanted energy bands. Only it will select and send to the sample. That will go through the slit again, focusing on the sample. The sample will absorb the incident UV visible radiation. Some sort of electronic transition like n pi star, pi star, DD transition or charge transfer will occur within the system, which will be recorded as a spectrum through the detector. Any kind of a spectroscopy almost have the similar features. Only the light source differs. Nature of recording will differ. Generally, they have this characteristic. A light source, a selection of the applied light, and the sample to be exposed for the light, then the result has to be recorded. This is the fundamental way how the sample will be studied with the help of a spectral technique. Okay, so this is some of the one or two examples just to make you interesting what is available from UV visible spectra. So this is about the gold nanoparticles and the UV visible spectra. Because gold is the indispensable material in the field of advanced applications. It finds a lot of application from the optical devices up to biological targeted drug delivery level. Gold nanoparticles are fine applications. So this UV visible spectra of the gold nanoparticles, this is the light emission occurs at 524 nanometer. Another one silver nanoparticle which absorbs the light at 420 nanometer. So these bands will tell what kind of the particle size of your material. The emission or the light absorbed by the particles will give you some calculations will be there what size of the material you are obtaining. Also, if you know the size, you can find where it can be applied, because if it's a very big molecule, you cannot say that it is used for biological applications, because our blood vessels and nerves will be of only 2 nanometer, 3 nanometer size. You have to take the particles which will take the drug molecules with a lower dimensions. Another one is the FTIR. This is called Fourier transform in infrared spectra. This is another characterization method. எப்படி ஒரு ஹாஸ்பிட்டலுக்கு போனோம்னா எல்லா டெஸ்ட்டும் எடுக்க சொல்கிறாங்க இல்லையா, அந்த மாதிரி ஒரு சாம்பிளை ப்ரிப்பேர் பண்ணிட்டோம்னா யூவி விசிபிள் எடுக்கணும், ஐஆர் எடுக்கணும், என்னவா இதெல்லாம் எடுத்தீங்கன்னா தான் இது என்னன்னு தெரிய வரும். இது என்னன்னு தெரிஞ்சால் தான் அதை எங்கே யூஸ் பண்ணணும்னு தெரிஞ்சுக்க முடியும். That is why I have shown some of the examples why we have to study all these things. So FTIR spectra will tell you the beautiful functional groups of the molecules. UV visible, first I told that UV visible or the electronic spectra will tell you the type of electronic transitions. N pi star, pi star, sigma star, DD transition or charge transfer transitions that results in the UV visible spectra. Next, some of the molecules may not have this electronic transition. You cannot expect all the molecule will have N pi star, pi star transition. Most of the inorganic materials will have charge transfer, DD transition. Natural compounds and the phytochemicals will have N pi star, pi star transitions. Some of the materials will not characterized in this category. They need to have some other characterization where it is FTIR spectra, which will tell you what is the functional group, whether there is an alcoholic group OH, Is there an amino group NH2? Is there a carboxylic acid COOH? Is there a aldehyde CHO or a ketone C double bond O? These kind of functional groups can be known with the help of Fourier transform infrared spectroscopy. So this is also similar to the UV visible. You need a light source, then you have to pass the light on the material. You will get a detector where the spectra will looks like. Okay, basically a light source, sample holder, interaction of the light with the material, the results will be obtained and interpreted with the help of the detector devices. So this is what is the FTIR spectra looks like. What we come to know from FTIR, I said about the identification of functionality of the molecules, functional groups present in the molecule. Only if you know what kind of a functionality, you can choose its application. If it is a carboxylic acid, you can select its application for making an ester. You can make them into an amide. You can make them for organic synthesis of the drug molecules. If you don't know its functionality, you cannot say where it is utilized. Okay, so this is one way how the infrared spectra looks. In the infrared spectra, there are several important regions. Each region will have a unique stretching frequency, bending vibrations like that. But the very important region is this one called the fingerprint region. You see here, what is the fingerprint? Each human will have his own fingerprint. Okay, no two persons will have similar fingerprint in nature. Like that, no two classes of chemical substances will have identical absorptions. Each class of molecule will have a characteristic absorptions. That is why the infrared spectra of these molecules are said to have the fingerprint region, from which you may able to exactly say whether two compounds are same or not, because no two different molecules will have similar peak in the fingerprint region. In the other regions, they may have similar absorptions, but in the fingerprint region, they are unique. That is how we may identify whether the two compounds are same or not. That is where the fingerprint region helps you a lot to understand the nature of functional groups present in the molecule. Next one is very important tool, nuclear magnetic NMR spectroscopy. You see, where this NMR applied, உங்களுக்கு புரிகிற மாதிரி சொல்லணும்னா MRI ஸ்கேன் எடுக்கிறோம் இல்லையா? அந்த MRI ஸ்கேனுடைய பிரின்சிபல் வந்து NMR, நியூக்ளியர் மேக்னெட்டிக் ரெசனன்ஸ். நார்மலாக MRI எடுக்கிறாங்க. இப்போ ஒரு பிரெயினில் வந்து ஒரு கட்டியோ ஒரு பிளாக்கோ இருக்குதுன்னா MRI எடுக்க சொல்லுவாங்க இல்லையா? அந்த பிரெயினை சுற்றிலும் தண்ணி இருக்கும். In our human body, 90% of our body is loaded with water molecules. Wherever you find, water is a major component, whether liver, kidney, heart or a brain, you will have lot of water molecules. Water molecules are NMR active. Not all molecules are. அந்த chemistry பேசணும்னா ஒரு வாரம் பேசணும். What molecules are NMR active? I can tell you straight away, water is NMR active. If your brain loaded, surrounded by water molecules are subjected in the nuclear magnetic radiations called MRI scan, if throughout your brain is uniform, that result will be shown in the scan report. Suppose if one particular cell or tissue of your brain is damaged by an injury or the growth of anything happens inside your brain, that localized environment will be different from rest of your brain environment. Okay, water molecules in the whole brain will be first taken. If that water molecules in your particular area where you have a growth of a small cyst or something like that, or any injury or block of blood flow in the brain, that water molecule will have a different chemical environment that can be shown a different NMR spectra from that of the rest of the molecules. That is how this MRI scan is very useful for identifying the blood clots, injury or brain cancer where the tumor growth is occurring in the human brain. That is where this MRI scan is used. The basic principle of that MRI scan is the nuclear magnetic resonance. That will tell you any kind of the disturbance in the chemical environment of a molecule. If the entire environment is same, no problem. If any disturbance to the environment, whether in your heart or a brain or any part, the NMR will tell you something happens there. Then it is the doctor's duty to find out what is the problem in the brain of the person. That is where they recommend for going. இதில் இன்னும் பார்த்தீங்கன்னா இந்த MRI ஸ்கேனில் வந்து நார்மலாக டிடெக்ட் பண்ணுறது ரொம்ப கஷ்டம். சென்சிட்டிவிட்டி வந்து ரொம்ப கம்மியாக இருக்கும். அதுக்கு வந்து கான்ட்ராஸ்ட் ஏஜென்ட்னு ஒரு மெட்டல் ஆக்சைட்ஸ் லோட் பண்ணுவாங்க. இந்த கான்ட்ராஸ்ட் யாராவது MRI எடுக்கிறப்ப கூட போயிருந்தீங்கன்னா தெரியும். கடோலினியம் சால்ட்னு சொல்லி கான்ட்ராஸ்ட் ஏஜென்ட் கொடுப்பாங்க. ஒருத்தருக்கு உண்மையாலுமே பிரெயினில் ஒரு ப்ராப்ளம் இருக்கும், முதல்ல வெறும் எம்ஆர்ஐ எடுப்பாங்க. They cannot locate exactly where the problem is. Then the doctor will advise you to give a dose of contrast agent, gadolinium salt. இந்த கான்ட்ராஸ்ட் ஏஜென்ட்டை போட்டுட்டு திரும்ப எம்ஆர்ஐக்கு அனுப்புவாங்க. அந்த கான்ட்ராஸ்ட் ஏஜென்ட் என்னென்னா உங்கள் பிளட்டில் மிக்ஸ் ஆகிட்டு பிரெயினுக்கு போகுது, திரும்ப அந்த போர்ஷன் சேம் போர்ஷனுக்கு எம்ஆர்ஐ எடுப்பாங்க. This gadolinium is having a property to go and attach only with the damaged cells, not to the normal cells. அப்போ உங்கள் பிரெயினில் நல்லா இருக்கிற பகுதியில் எல்லாமே இது போகாது. எங்கே ஒரு டேமேஜ், வெதர் an injury or a block in the blood vessels, அந்த போர்ஷனில் போய் gadolinium will get accumulated, நிறைய சேர்ந்துடும். அது சேர்ந்துருச்சுன்னா அந்த எம்ஆர்ஐ வந்து காட்டி கொடுத்துரும் இந்த இடத்துல ப்ராப்ளம். ஸோ திஸ் நியூக்ளியர் மேக்னெட்டிக் ரெசனன்ஸ் இஸ் அ principle which finds application in the MRI scanning to identify blood clots, injury, the cancer cell growth in the brain through the use of contrast agents also. இது இன்ஸ்ட்ருமெண்டேஷன்லாம் வேண்டாம், இட்ஸ் a big chemistry and instrumentation technique. Just you know how this is useful. இந்த NMR எப்படி யூஸ் ஆகும் ஒரு ப்ராடக்ட் கேரக்டரைஸ் பண்ணுறதுக்குன்னு பார்த்தீங்கன்னா, 2 ஆல்கஹால், ஒன்று எத்தில் ஆல்கஹால், ஒன்று மெத்தில் ஆல்கஹால், ரெண்டுமே ஃபங்க்ஷனாலிட்டி இஸ் சேம். இங்கே பார்த்துக்குங்க, இன்ஃப்ராரெட் ஸ்பெக்ட்ரம் எடுத்திங்கன்னா ரெண்டும் ஒரே மாதிரி வரும். பிகாஸ் HO, hydroxyl group, is the functional group of an alcohol. So methanol and ethanol will have same hydroxyl group. நீங்கள் IR ஸ்பெக்ட்ரம் எடுத்து டிஃபரன்ஷியேட் பண்ண முடியாது, UV விசிபிளில் டிஃபரன்ஷியேட் பண்ண முடியாது. அங்கேயும் N pi star pi pi star transitions தான் நடக்கும். Both are alcoholic molecules. You cannot differentiate. If you take the NMR spectrum, அதுலேயும் நிறையா இருக்குது. புரோட்டான் NMR, C13 NMR, phosphorus 31, nitrogen 15, fluorine 19, chlorine 32. Several atoms can be recorded with the help of NMR. இந்த C13 NMRங்கிறது ஒரு எக்ஸாம்பிள் கொடுத்தோம். பார்த்தீங்கன்னா இந்த NMR ஸ்பெக்ட்ரலில் இந்த எத்தில் ஆல்கஹாலுக்கு வந்து CH3 குரூப், CH2 குரூப், 2 கார்பன் இருக்குது இல்லையா? இந்த கார்பன் இந்த பக்கம் C கூட அட்டாச் ஆகிட்டு இந்த பக்கம் O கூட அட்டாச் ஆகிருக்கும். இந்த கார்பன் வந்து 3 ஹைட்ரஜன்ஸ் கூடவும் ஒரு O கூடவும் அட்டாச் ஆகிருக்கும். ஸோ திஸ் மிடில் கார்பன் அட்டாச்டு டு எ கார்பன் அண்ட் ஆக்சிஜன். திஸ் கார்பன் நோ வே அட்டாச்டு வித் எனி கார்பன், only with hydrogens and this oxygen atom. So the position where you will get the peaks corresponding to this methyl carbon, then methylene carbon, these two differs. Either methyl carbon, either methylene carbon. Here you see these are the 2 peaks corresponding to methyl and methylene carbon. Here you get only 1 peak corresponding to methyl carbon. Only 1 carbon atom is there. This is reference peak. TMS இதை பார்க்காதீங்க, இந்த pink கலரில் உள்ளதை பார்க்க வேண்டாம். Here you see 2 peaks corresponding to an alcohol. Here 1 peak corresponding to alcohol. IR spectrum looks similar, but NMR spectrum looks different. We may say one is methanol, other is ethanol. This is how NMR can be used for characterization of similar materials. Then comes the beautiful techniques called X-ray diffraction technique. This involves a lot of physics, where the materials will have their interplanar distances. Once if you pass a light, if the wavelength of the light incident on the material matches with the d-spacing of the material, they get diffract. That is what is the powder X-ray diffraction technology. Only the light with an energy gap that we call the quanta or photons of incident light, that energy matches with the spacings of the material, that energy will be absorbed. You will get the patterns of the diffraction of the incident light by the metal, whatever particles you are having. So that kind of X-ray diffraction will tell you exactly about the crystallinity, lattice planes, and what kind of crystalline material it is. For example, titanium oxide. Whenever we talk advanced material, without gold and titanium we cannot talk. Always they are the good materials. Titanium oxide is having 4 different crystal nature: rutile, anatase, brochide. So these different materials can be characterized with the help of the powder X-ray diffraction. All are titanium oxide. In chemistry, all are same. IR spectra will be same, UV visible spectra will be same, but powder XRD pattern will not be the same. Because of the different crystalline pattern, they will give different powder exotic diagram. So you may differentiate the material. For catalytic applications of this titanium oxide, the powder XRD is very useful, whether this material can be a catalyst or not. Then comes the advanced characterization of material using single crystal XRD. இந்த powder XRDங்கிறது amorphous materialக்கு பண்ணலாம். Single crystal XRD, when you make the compound 100% pure, that will get into its own crystal. That crystal will give you the right proof. ஒரு மாலிகுலை புதுசாக சிந்தசிஸ் பண்ணிட்டு சிங்கிள் கிறிஸ்டல் ஸ்ட்ரக்சர் கொடுத்துட்டீங்கன்னா அந்த மாலிகுலோடைய ஸ்ட்ரக்சரை பற்றி கொஸ்டின்ஸே கேட்க மாட்டாங்க. ஃபார் எனி பப்ளிகேஷன் ஆர் எனி PhD work, if you give the single crystal XRD data of a molecule, இதுதான் இந்த மாலிகுல் 3-dimensional orientation of various atoms in space. ஒரு கார்பன் இப்படி இருக்கு, ஹைட்ரஜன்ஸ் இப்படி இருக்கா, இப்படி ப்ரொஜெக்ட் ஆயிருக்காங்கிறத in 3-dimensional space you can give the structure of the compounds using the single crystal X-ray diffraction. So very useful technology for inorganic compounds. Okay, these are all some of the powder XRD patterns. From the peak positions, you say these are all 100, 1010, these are all crystal planes. There are various planes in the crystal systems which will diffract the incident light. Once if it interact with the incident light, that gives a peak in that particular position corresponding to 2 theta values. In the 2 theta 36ல வருதுன்னா அது என்னங்கிறது ரிசர்ச் பண்றவங்களுக்கு தெரியும். So we may say what is what in the molecule. Okay, so far we said something about the characterization involving spectral and this kind of NMR followed by the diffraction studies. Next important area is the surface morphology analysis using microscopic technique. So you all know that microscopy is the tool which will give you the appearance of the material. So in that surface morphology studies we use this scanning electron microscopy called simply SEM. Another one is AFM, atomic force microscopy. One more recent development and very useful is the TEM, transmission electron microscopy. இது எல்லாமே வந்து ஒரு மெட்டீரியலினுடைய சர்ஃபேஸை தெரிஞ்சுக்கிறதுக்கு. ஏன் சர்ஃபேஸை பற்றி தெரிஞ்சுக்கணும்னா சர்ஃபேஸ் ப்ராப்பர்ட்டியை வச்சுக்கிட்டு தான் நிறைய இடத்துல அப்ளிகேஷன்ஸ் டிசைட் பண்ண முடியும். நீங்கள் சர்ஃபேஸ் வந்து யூனிஃபார்ம் போர்ஸ் இருக்கணும், முதல்ல சர்ஃபேஸ் ஏரியா நல்லா இருக்கணும். ஒன்லி இட் கேன் பி a, for example, catalytic application, gas absorption, gas sensing, degradation of the toxic substances in the environment. All these require large surface area of the catalytic substances. Once if the area of the catalyst is large, interaction with the substrate molecules are very high, then the photo degradation or anything will be more efficient. For that purpose, the surface need to be characterized with a lot of studies. The first one is the scanning electron microscopy. It's a very good technique where you have the material, you pass the beam of electrons, the focused beam of electrons. Spectroscopy la na sonne UV lights are passed. Infrared la solren microwave radiations are passed. NMR la adu or type of energy irukum. Inga enna beam of electrons will be focused on the substance. நீ எந்த substance study பண்றியோ அது மேல electron beam pass பண்றோம். If this incident electron beam will interact with the substance itself will have its own electrons. All the molecules will have their own electrons. The interaction of the incident beam of electrons with the electrons of your substrate will result in the backscattering or secondary electrons are produced from the substance. The backscattered electrons or the secondary electrons due to the interaction of the incident beam of electron with the substrate electrons will give you the images that is for the scanning electron microscopic image. Okay, this is a beautiful image of 2 different substances recorded with the scanning electron microscopic images. நம்ம ஹாஸ்பிட்டலுக்கு போய் MRI ஸ்கேன் எப்படி இமேஜ் எடுக்கிறோமோ அந்த மாதிரி சப்ஸ்டன்சஸ்க்கும் மாலிகூல்ஸ்க்கும் செம் எடுக்கலாம். அதனுடைய ப்ராப்பர்ட்டி அது எங்காவது டேமேஜ் இருக்கா, கிராக் இருக்கா, வெடிப்பு இருக்கான்னு பார்க்குறது. போர்ஸ் இருக்கா, வாட் இஸ் த போர் சைஸ், போர் வால்யூம், ஆல் தீஸ் கேன் பி நோன். இன்னொன்று இந்த மாலிகுலுடைய காம்போசிஷனும் எடுத்துக்க முடியும். செலக்டட் ஏரியாவை எடுத்துக்கிட்டு நீங்கள் பண்ணீங்கன்னா எனர்ஜி டிஸ்பர்சிவ் எக்ஸ்ரே அனாலிசிஸ். ஓகே, இந்த செம்மில் ஒரு காம்பனண்ட் அடிஷ்னல் காம்பனண்ட் ஒரு பர்டிகுலர் ஏரியாவில் என்ன காம்பவுண்ட் அங்கே ப்ரெசென்ட் ஆகிருக்கு. இப்போ நான் ஒரு மெட்டீரியலுக்குள்ளே வந்து டைட்டேனியம் லோட் பண்ணேன்னு சொல்லுவேன். டைட்டேனியம் இருக்குதான்னு சொல்கிறதுக்கு இந்த செம்மில் இருந்து கண்டுபிடிக்க முடியும். குவாலிட்டேட்டிவ் இன்ஃபர்மேஷன்ஸ் கேன் பி நோன் த்ரூ த EDAX அனாலிசிஸ். திஸ் இஸ் அபவுட் TEM. ஐ டோல் யூ நோ டிரான்ஸ்மிஷன் எலக்ட்ரான் மைக்ரோஸ்கோப்பி. இதுவும் செம் எல்லாமே ஒரு மாதிரி டெக்னிக் தான். ஜஸ்ட் பிரின்சிபல்ஸ் இட் டிஃபர்ஸ். அங்கே வந்து பேக் ஸ்கேட்டர்ட் எலக்ட்ரான்ஸ் வில் பி ரெக்கார்டட் and the image are obtained. Transmitted electrons will be recorded and the images. Here the incident beam of electrons will be transmitted through the fine layers of the substrate molecules. That transmitted electrons will be recorded, how their energy levels get changed. That will give you the image in the TEM microscopic images. These are some of the TEM images of metal organic frameworks. Okay, these are all metal organic frameworks. Metal organic frameworks. Our Dr. Kadrivelu sir will speak a lot about metal organic frameworks. They are very useful functional materials for gas storage and drug loading, drug delivery, even the photochemical reduction of toxic substances. All these are MOFs, MOFs. So that MOF can be characterized with the TEM, transmission electron spectroscopy. This is the TEM image. Okay, this is in the TEM image, HRTEM, high resolution transmission electron microscopy. In a particular area, you will get about its crystallinity. What kind of the crystal? If you get this ring pattern, that says it's a pure crystalline substance. The ring pattern will also tell you the interplanar distances. What kind of the distance between the various planes in the molecule will be known, and the purity of the substances can also be known with the SAED pattern, selected area electron diffraction pattern. Then another important microscopic technique is AFM, atomic force microscopy. This atomic force microscopy also a surface imaging characterization technique, but here there is a moving cantilever will be there. This cantilever will move over the substrate. Namak in the molecule study panamna, the lever will move near the surface of this. There are two modes, contact modes and non-contact modes. The lever can touch your substance, or it is just above the substance. The electrons in the molecule under the tip of that will have interaction between them, and the deflection will take place. The tip will be deflected from its normal position. The deflection of this will be recorded and get an image which will tell you the surface roughness, surface topography. இப்போ நீங்கள் பார்த்தீங்கன்னா ஃப்ளைட்டில் போகிறப்ப மேலே பார்த்தீங்கன்னா அந்த ஸ்கை எப்படி தெரியும்னா அப்படியே வேவியாக இருக்கும், clouds எல்லாம். அந்த மாதிரி உங்கள் பார்ட்டிகல் கண்ணில் பார்த்தீங்கன்னா ஒரே மாதிரி தான் இருக்கும். when you record the atomic force microscopic image, you will see how the topology appears, whether the uniform surface or surface, some deflections are there on the surface. These kind of topological images can be obtained with atomic force microscopy, since surface characterization is very important for some applications. Okay, another one is the surface characterization using the surface area measurements. The surface area எதுக்கு measure பண்றோம்னா, இப்போ வந்து நம்ம அடிபட்டுட்டா பேண்ட்-எய்ட் அப்ளை பண்றோம். இந்த பேண்ட்-எய்ட்லேருந்து ட்ரக் ரிலீஸ் ஆனால் தானே நமக்கு இன்ஜுரி க்யூர் ஆகும். இந்த ட்ரக் ரிலீஸ் ஆகணும்னா அதுக்கு சர்ஃபேஸ் ஏரியா நிறையா இருந்ததுன்னா ட்ரக் ரிலீஸ் will be quick. If that more drugs are released into the injured area, then curing will be better at a faster rate. So there plays surface area as a big role. So the contact between the substrate and any other way, it facilitates with more surface area. அது catalysis-ஆ இருக்கட்டும், photocatalysis-ஆ இருக்கட்டும், degradation of pesticides-ஆ இருக்கட்டும், எல்லா இடத்துலையும் drug release also, surface area is a unique property that need to be analyzed with the bed surface area measurements. Based on that, the materials are classified into three types: microporous less than 2 nanometer size, the pore size mesoporous 2 to 5 nanometer, and the macropores above 50 nanometer. இந்த பார்ட்டிக்கல் போர் சைஸை வச்சுக்கிட்டு எங்கே அப்ளை பண்ண முடியும்னு கேஸ் ஃபில்டரிங் எல்லாம் இருக்குது. கேஸ் சென்சிங்கில் பார்த்தீங்கன்னா the filtration of gaseous molecules can be achieved by selecting suitable membranes with the pore size. If if the pore size is this much, this kind of separation is achieved. For that purpose, we need to know the surface area. Time எவ்வளோ இருக்கு? Shall I continue for a few more minutes or I will wind up? Okay. Then optical properties. So the optical properties are the limited emitting properties, which is very essential for applied materials in electronic devices. The materials upon interaction with the UV light and the infrared or any kind of a photo incident, they tend to give particular light emission. Very important things are the fluorescence or the photoluminescence emission, which are very important for biological applications and optical devices application. That decides this material is suitable for this purpose or not. அதில் பார்த்தீங்கன்னா இந்த ஃப்ளூரசன்ஸ் எமிஷன்ங்கிறது இப்போ நம்ம ட்ரக் மாலிக்யூல்ஸ் எல்லாம் வந்து நேச்சுரலி இஃப் தே ஹேவ் அ ஃப்ளூரசன்ஸ் எமிஷன், அது வந்து நம்ம பாடியில் இன்ட்ராக்ட் பண்ணுது ப்ரோட்டீன் கூடவோ டிஎன்ஏ கூடவோனா அது எமிஷன் மே என்ஹான்ஸ் ஆர் கொஞ்ச், கூடலாம் அல்லது குறையலாம். The quenching or enhancement of the intensity of the fluorescence emission will tell you what kind of interaction between the drug molecule and the cells. If they have pi-pi interaction, molecular stacking, there are so many interactions, groove binding. This will tell you, depending upon the nature of shifting in the incident light, emitter light, intensity of the peak obtained. The intensity of the peak என்னன்னு பார்த்தீங்கன்னா யூ see இந்த பீக்கில் வந்து இவ்வளோ ஹைட் இருக்கு. ஒருவேளை இன்ட்ராக்ஷன் நடக்கும்போது இந்த ஹைட் குறையலாம். இந்த பீக் பொசிஷன் லெஃப்டில் வரலாம், பீக் பொசிஷன் ரைட்டில் போகலாம். தீஸ் ஆர் ஆல் த shift towards lower wavelength, shift towards higher wavelength, decrease in the intensity of the emission. All this will tell you what kind of binding occurs between the biomolecule and the selected drug molecules. So this kind of optical properties also need to be identified. Then for toxicological evaluation, நார்மலாக ஒரு மெட்டீரியல் சிந்தசிஸ் பண்ணிட்டு அது ஆன்டி கேன்சர் ப்ராப்பர்ட்டி இருக்குதுன்னு தெரிஞ்சதுன்னா whether it is affecting only cancer cells or normal cells, this is a very big problem. நம்ம எடுக்கிற மாத்திரை வந்து நோயை தான் குணப்படுத்தணுமே தவிர புதுசாக நோயை வர வைக்கக்கூடாது, நல்ல செல்ஸை வந்து கில் பண்ணிடக்கூடாது. ஃபார் தட் பர்பஸஸ் இன் ஆன்டி கேன்சர் அப்ளிகேஷன்ஸ் த மெட்டீரியல் நீட் டு பி அனலைஸ்டு ஃபார் இட்ஸ் viability on the normal cells and it should kill only the cancerous cells or the tumor cells. For that MTT is one of the best way, you see, by applying a particular nanoparticles in various concentration, the cell viability, when no compound is added, 0% of drug is added, this much of cells, 100% cancer cells are there. By loading 0.5%, 5%, milligrams per milliliter, some concentration, you can see the death of the cells from 100, this comes to about 92 or 93, then 90, then 80. So when go on loading the drug in an increased manner, you will see the number of cancer cells get decreased drastically. At one stage 40 milligram per microliter, there is only around 20% of cancer cells are lived. So the selected nanoparticle or any drug compound is very useful as an anti-cancer drug that can be determined by the MTT assay. இந்த assay எல்லாம் பண்ணினாதான் ஒரு காம்பவுண்ட் ட்ரக்காக யூஸ் பண்ண முடியுமா பண்ண முடியாதான்னு சொல்ல முடியும். For that purpose this MTT is one way. There are several techniques are available, but for you it's information what is happening in identifying the drug molecules. அதே மாதிரி I told you about DNA binding, protein binding. The drug whatever we take should interact first with the protein and the DNA. Protein ரிப்பேரும் DNA ரிப்பேரும் நடந்தால் தான் கேன்சர் செல்ஸை வந்து கொல்ல முடியும். அந்த கேன்சர் செல்ஸில் இருக்கக்கூடிய ப்ரோட்டீன் டிஎன்ஏ கூட நம்ம கொடுக்கக்கூடிய ட்ரக் வந்து இன்ட்ராக்ட் பண்ணுதா இல்லையான்னு பார்க்குறதுக்கு the first and the foremost studies is DNA binding, protein binding. இந்த DNA binding protein இப்போ எங்கே ஆரம்பிச்சு எங்கே வந்தங்கிறத இந்த ஸ்லைடுக்கு அப்புறம் சொல்லிடுறேன், இங்கே புரிஞ்சுக்குங்க. ஜஸ்ட் DNA binding, protein binding அவசியம். ஓகே, இதெல்லாம் தம்பி டாக்டர் கதிர்வேல் will touch about photocatalysis and much. Okay, right, let me conclude with, okay, ஏன்னா நிறையா சொல்லிக்கிட்டே போகலாம், but I need to give opportunity for my good friends, others to discuss their own research topics. ஸோ இப்போ எங்கே ஆரம்பிக்கிறோம்னா ஒரு அட்வான்ஸ்டு மெட்டீரியல் சிந்தசிஸ் பண்ணுற லேபில் இருந்து அது என்ன சிந்தசிஸ் பண்ணணும் அந்த சிந்தசிஸ் டியூன் பண்ணிக்கலாம், ப்ரொசீஜரை டியூன் பண்ணிக்கலாம், நல்ல மெட்டீரியல் ப்ரிப்பேர் பண்ணிடலாம். அதுக்கு தான் இந்த சர்ஃபாக்டன்ஸ் போடணும்னு சொன்னேன், ஸ்டெபிளைசர்ஸ் போடணும், சைஸ் கண்ட்ரோலிங் ஏஜென்ட்ஸ்லாம் போடணும். ஏதோ ஒன்று போட்டுட்டு யூ ஆர் கெட்டிங் எ வெரி பியூட்டிஃபுல் மாலிகுல். ஓகே, அது என்ன மாலிகுல்னு பார்க்குறதுக்கு இத்தனை கேரக்டரைசேஷன் பண்ண வேண்டியிருக்கும். இந்த எல்லா கேரக்டரைசேஷனும் பண்ணிவிட்டு கடைசியாக அந்த பயாலஜிக்கல் ஆக்டிவிட்டி எம்டிடி அஸ்ஸே வரைக்கும் பண்ணிவிட்டு if you are sure that this molecule is human friendly, environmental friendly, no toxicity to normal cells, அதுக்கு தான் இந்த எம்டிடி அஸ்ஸே. நார்மல் செல்ஸை கொல்லக்கூடாது, கேன்சர் செல்லை மட்டும் செலக்டிவாக கொல்லணும். if they are selective to specific cancer cells, they have good binding ability with protein and DNA, that finds application as a biomaterial for anti-cancer activity. இதெல்லாம் பண்ணுறதுக்கு தான் synthesis followed by characterization is very important. Thank you.
Yeah, good afternoon audience once again. Thank you Professor ND for giving a very detailed, comprehensive, illustrious yet very simple, like simple in a simple language. I will not say simple lecture, giving in a simple language. And since you have introduced Tamil, I will also tell Anuvai Puguthu Elu Kadalai Puguthi Kurgadharitha Kura, like that you wanted to bring all the materials, not only the synthesis, actually you have emphasized the interplay between the material synthesis, characterization, application, and most importantly the risk. Whenever we do a material engineering, what are the risks we are going to face, how to overcome the risk by modifying the synthesis procedure, again characterizing them. It's a kind of like if you go to an IAM, Indian Institute of Management, they teach about the product engineering. They teach how to ideate a product, how to empathize the product. Means that get the requirements, ideate, get the specifications, then how to prototype, how do you make the product, and how to test it, how do you evaluate. And it's a process. It's called a product engineering. So we also do that in our life. If we face a problem, we just emphasize what are the factors. We come to a conclusion. This is the thing we have to do. We apply, then we get the results. The result should not affect our own life. That is called the risk and risk mitigation process. And the whole thing in a material science, how one has to approach, Professor Andy has presented. I am very happy that I learned again the basics, because day in, day out, we do only applied science. And also it is, if you are, the way he has explained, if you have not got the pulse of the audience, and if you are not properly communicating, you are not learned. That is what people say. So we have to learn in such a way that we should be able to explain to the heterogeneous audience. It's very, very difficult. That I think he is an expert, and he has done that job, and you have observed it. Now I give it to the audience for any particular questions. Thank you. Couple of questions. We will take a couple of questions. Yeah. Students, please. Yeah.
Good afternoon, sir. So your presentation is very nice. So myself, I have working in the material of now only I work in the green synthesis. Is it possible by using the algae material, marine algae material, in a water purification application? Algae material, marine. Yes, sir. Just now only I'm entering the field of green chemistry.
For water purification.
Water purification by using the algae material.
Okay. You see, nature has taught us good chemistry. When you send impure water or dirty water from household activities or from any activities from industrial waste, when you allow it to pass through a stream of sand, you will see that the water gets purified. That is how the river water becomes good quality water. The nature has beautifully played in a way that the contaminants, impure materials get filtered during the course of flow of the water in the river. Like that, clay is nothing but a natural soil, will perfectly do the water purification.
Okay, sir.
No doubt. You have to characterize, and you may load with some other materials also, if necessary.
So which kind of material we have to apply within that?
No, that you have to see the literature.
Okay.
I am not working with clay or water purification using clay. I am sure that clay will be a useful material for water purification.
Is it
My knowledge is not from study, from the river which purifies the water.
I will add one answer to you.
Okay.
See, the clay is a basic material.
Okay.
So clay is a well-proven absorbent for quite long period. So you have to understand the pollution property, particular dry or even chemical or any pesticide. Accordingly, you have to modify your surface, including porosity, surface area, etc. So that you will have to, because every material has absorption property. But what is capacity? What is the mechanism? Whether it is a chemical absorption, a physical absorption, or ion exchange, it is a huge field. So you have to modification.
Actually, clay is good for decontamination of water.
Okay.
Rest of the things you survey the literature, select for the materials. Okay.
Thank you, sir.
I am not an expert in that.
Okay.
Hello, sir. I'm
Yes.
Nilofir. I'm a research scholar from KPR IET. I work in the field of sensors. I have two doubts, sir. One is, what is the difference between calcination, sintering, and annealing? Like, what is the major difference between this? Because when we read papers, people heat the product and they mention it as annealing. In another paper, it is sintering. So what is the major difference? If there is a difference, when to apply and where to apply it, sir?
Nothing difference. It's getting to materials at high temperature. One way, you can heat the material in the presence of air, in the absence of the air. Calcination inside the chamber, you are avoiding the presence of air. Okay, the presence of air will sometimes affect the quality of the final products formed during degradation. Ultimately, the purpose is to end with the metal oxides. By sintering, some of the materials which are air sensitive should be calcined within the controlled atmosphere. Otherwise, you can do the degradation or annealing. Okay, normally for metal oxides, the best way is calcination or sintering. Annealing applicable to metals. Okay, heating to metal to high temperature, bringing down its temperature to some of the malleability, ductility, that kind of properties.
Like, is it basically for metallurgy, sir?
Yes, yes.
Okay, sir.
Yes.
So, I have another doubt. Now I'm working in lignin biopolymer. My future work is to do the lignin to dope with CNTs for mRNA direction. Like, do you feel is there any scope for it, sir?
Lignin with
Lignin
CNT.
doped CNTs.
CNT.
Yes, sir.
Doping means what you feel, how it gets into CNT. Whether it gets wrapped over the surface of
Wrapped over the surface of biopolymers.
It will not go inside the CNT.
No, sir.
Okay, it's just wrapping.
Yes, sir.
See, the lignin is a biopolymer. The advantage, if you look into the structure, the n number of carbon, n number of OH. So maybe by dissociating OH hydrogen group can make it as a surface negative charge. Thereby can for specific application. I think my understanding, basically the biopolymer have huge functional groups where you will be able to modify as per requirement for your application.
Lignin is a very good material. You can
Yes,
play
sir.
with the material. You can
Yes,
play
sir.
with the material
Yes, sir.
by surface functionalization.
Yes, sir.
You tune the functionality because CNT also functionalized.
Yes, sir.
Nitration, sulfonation,
Yes, sir.
all this. If you functionalize whether CNT or lignin, you can get good binding of your lignin over the surface of CNT.
Okay, sir.
If you succeed in that way, material becomes beautiful. For your definitely it will have merit.
Yes, sir.
Coating
So the
of
lignin, what I do is, it is an extraction from palm kernels or groundnut shells. It is an extraction, sir. It's a soda lignin. It's not a craft lignin. We do extract lignin. So I have a doubt whether if I do with that to dope CNTs, will it have?
Lignin is a very, very best example if you take coir pith. 70+% lignin. It's very, very difficult to separate except using lignocellulosic bacteria. If you do any other extract using chemicals, there will be damage. Best way use the lignocellulosic bacteria because if you look at the big study in the 90s, Professor K. Ramasamy, Vice Chancellor Tamil Nadu University, is a huge work in the viscose, where the biggest problem is this lignin based. So better to go for lignocellulosic bacteria, separate the lignin from the any of your plant material. If you want to have better quality, the best way is a coir pith.
That way you will protect the material functionality. That's what sir is mentioning.
Yes, sir. We do base purification also. So,
Yes.
as sir mentioned, the lignin is getting damaged very soon.
Yes, very much.
Yes,
It's
sir.
susceptible
Yes,
to
sir.
damage.
Yes,
so
sir.
as he suggested, go for the natural purification methods. Get the beautiful material.
Yes, sir.
Okay.
Yes, sir.
Then you can functionalize CNT also, surface functionalization.
Okay, sir.
One may don't functionalize CNT. Coat your material. Then you do nitration, sulfonation on CNT.
Okay, sir.
Add your lignin. See which one is meritorious. Go for your selective application.
Yes, thank you, sir. Thank you, sir.
Thank you, sir, for providing the solutions of the students' concern. So, what is next? Any other questions? Okay.
Thank you, sirs, for your valuable words. I request Swarnika Shivakuma of second year AIML to introduce the speaker, Dr. K. Kadirvelu, scientist, DRDO.
Good afternoon. I'm Swarnika Shivkumar from second year CSE-AML. Dr. K. Kadirvelu is a distinguished scientist G and associate director in DRDO, Bangalore, with 3 decades of pioneering research in environment science, nanotechnology, and biosensor development. He also serves as DRDO coordinator in Industry Academia Center of Excellence, Bharatiya University. A mentor to 16 PhD scholars and 10 postdoctoral researchers, Dr. Kadirvelu has authorized 178 publications, 8 books, 14 patents, earning recognition amongst top 2 scientists in the environmental science worldwide. His remarkable journey has taken him across France, China, USA, and India, and he is a fellow of Royal Society of Chemistry, UK. His contributions have been celebrated with awards such as Tamil Nadu Scientist Award 2022, Icon of Coimbatore Award, and the National Technology Day Oration 2025. Today, Dr. Kadirvelu is a torchbearer of innovation who continues to push boundaries of science and technology for the benefit of both nation and humanity. It's my pleasure to welcome Dr. K. Kadirvelu to deliver his address.
Thank you very much. As I said, after Dr. Dharmara's lecture, it's very difficult to create an impact among the audience, and also it's lunch time. But anyway, I will be speaking in briefly about the general topic, because if you look at the first of all, let me appreciate the team of people coining the title: Advanced Functional Materials, Nonlinear Dynamics, STATPAR, Strategic Defense, Biomedical, Energy, Climate, and Civilian Applications. There are 32 themes. So I'm trying to add how much themes I can, because I'm highly talking about highlight about the advanced materials in the defense. Because I think was already given a lot of definition about advanced materials, characterization, synthesis, exchange, etc. But another important thing here, all of you know that this conference is funded by DRDO. So all of you should know minimum about DRDO. So I will be briefing another 5 to 10 minutes about DRDO. So if you look at DRDO as an organization, it's one of the very, very important, very highly reputed national security organization, headed by people like Dr. Kalam, Dr. Rajaraman, Dr. Saraswat, so many people, up to president. So that way, it's a very prestigious organization. Another thing, important thing, the head of the organization is highly empowered, not even beyond ministers. 500 crores per file he can approve without anybody. So he has access to Prime Minister office on daily basis. See the kind of impact. So that way, this particular organization was the first brainchild of first Prime Minister. Is first to have an exclusive organization for defense R&D to make defense system in self-reliance. That is a major aim. So if you look at initially, we had only 2 organizations. That is technical development with Indian Army, and then director technical development production with the Defense Science Organization. If you look at initially, we were very simple organization till 1982, doing the basic research and certifying the imported weapons. If you see over the period, today we are working from agriculture, high altitude agriculture, agricultural technologies to missile, every aspect. So completely and multidisciplinary interdisciplinary research. So over the period, so you can see this, every subject is number of laboratories. We are under the strategic R&D. We are the number 1 in terms of manpower, budget, and establishment. We go almost 7,700 scientists today, 30,000 crore annual budget, 50 plus laboratories and work centers. Beyond that, 15 center of excellence. So many are there. So here we enhance the R&D. It has to be self-reliant defense system. See, anything undertakes have completely an applied research. It has to lead to the product, not simply a product. It has to be world class. Why it has to be world class? Unfortunately, Indian neighbors are not developed technically or economically. You cannot underestimate. The geopolitics come and play a role. So anything you develop, there has to be somebody can support your neighbor to operate in India. That's why it has to be world class. I think all of you have seen what has happened during Operation Sindoor. So we are also world class. For example, today take India as a country. Only 7 countries got technologies to develop or even produce the fighter aircraft. India is the one, like gas turbine engine. Only 6 countries got a capacity, technology to operate the nuclear submarine using nuclear reactor. 5 countries got a ballistic missile like Agni. Only 4 countries could land in the moon, especially India and South Pole with soft landing. Only 2 countries got a capacity to have a hypersonic and supersonic missiles, India and Russia, like BrahMos. So you can understand the kind of investment what we do, not even 3% out of our GDP. But still India is doing a lot of laurels. India is in the top elite countries in terms of missile defense, air defense, even Chandrayaan program. There are so many other programs. Now India has taken another important program, Samudrayaan, Gaganyaan. All these are very unique programs. So that way, and also you can see, it has to be, we cannot do just like that R&D. As the express needs of Navy, Army, Air Force is called tri-services. Another unique problem here, Because you can see all these things are built in technology area. A small area called life sciences, we call it as soldier support technologies. So why this soldier support technology required country like India? Because India is subcontinent. Our soldiers are subject to operate in the minus 30, 20,000 altitude, underwater, air, bunker, jungle. It's a very difficult task. So it is a plus 15, minus 50. So you can imagine the kind of stress, kind of extreme environment being soldiers are working to save this country. And also, it's a very, very difficult complication. That's why we are having this kind of extremely, systems. And also, it is a vision. We have to basically empower the country with cutting-edge technology. That is a major mission. If we take mission, design and develop, lead to product, provide the technical solutions to optimize competitiveness. Very importantly, all of you should know, the committed quality manpower. When you take a Chandrayaan as a program, Agni as a program, the thousands of people working together. For everyone, mission is important. Not ego, not your contribution, not your development. That's why we take care of the committed. Everyone cannot become army officer, air officer, or even scientist. We have a system in a place to select people for right job. So, like that, you can see these are the areas we have already mentioned. You can see how the people are. This is the way Indian DRDO labs are distributed across the country. So, as I mentioned already, till 1982, we were a simple scientific organization. People like Dr. Rajaramana, Dr. Kalam, Dr. Venkataraman, V.S. Arnachalam, they made a beautiful planning for 50 plus years. Integrated guided missile program, light combat aircraft, main battle tank, electronic warfare system. See, another important thing for all the youngsters, the future, there won't be conventional conflicts. People may not use missile, aircraft, or tank, or now the way in which the entire globe is moving towards, recently what you seen trade war with India and America, knowledge war, economic war, cyber war, nuclear war, biological war, chemical war, these are all invisible. So are we ready to base? In certain extent, not completely for chemical biology, because India is very strong in this. For every chemical agent, we have sensors. For every chemical, we have antidotes. For every biology, either drug or vaccine. That way, we are very strong. India is one of the pioneers in the chemical biological defense. So let's see. See, in the essay, because we represent the life science cluster. So there are 9 labs. Basically, work on the enhancing sustainability, efficiency, capability, and lethability of the soldiers wherever they are deployed for their mission purpose. So if you look at the canvas for soldier support system, they have to be, whether they plus 50 or minus 50 or underwater air, the performance has to be beyond that. As a soldier has to perform. And then selection, as I already mentioned, more than physical strength, everything, education, qualification, the attitude. Say for example, to become a fighter pilot, see how much intelligence we have to have, because in the nanoseconds, you have to escape from the enemy radar, drop bomb, attack to command, 8 air traffic controller, 1,000 km speed. Can you imagine? It's a very, very difficult job. So that's why we make a very critical system, and also we have training, but rigorous training after selection. And then everybody in the army, all of you, we cannot give the idli and sambar in the morning. For information, there are 32 ration scale for military operation, different mission, like Naxal operation, like altitude operation, Antarctica mission, underwater, in the air. So every mission has a different food capsule, starting from energy bar to even prepared packaging or self-eating pouches. So that way we have to put. And then motivation, because they will be under tremendous pressure. They will be from family, culture, 24/7 control. It's a very difficult task. They can speak to family once in a while, only for 2 minutes. So we have to make them motivate. And then one side school dropout soldier, other side man-machine, high-end machine, man-machine interface. Health, when they are in the history and the heat stroke, pulmonary edema, hypoxia, all the big challenge. So we have to make them their health. Then protective. Say for example, face mask, what you have seen during COVID. So it looks very simple. When even COVID is not even listed under the chemical warfare biological warfare agent. You see, real biological agents are very, very complicated. And also cloth. See, clothing, see, when you go to NBC, nuclear chemical biological protection, 7-layer clothing. When you talk about fighter pilot, he required the anti-gravity suit. Because when he takes off from runway, it goes several times against gravity, entire blood goes to his legs. He loses the vision. So we need to give them with the anti-gravity suit. If somebody in the submarine, 300 meters below water, if something happens, he has to come to surface with underwater breathing system and underwater escape suit. See the kind of technological complexity in what we are facing. So like that we have got a clothing, parachute. We cannot drop just like the parachute, paradrop, and submarine escape suit. So like that we have got. So in the textile itself, the huge task with all high-end clothing system. Then shelters. Shelter comes when you have a, suppose assume there's an outbreak of chemical biological agents. The shelter should be non-permeable. So these are all very, very breathable. This system, that's why we have a Trojan support system to whether you have war or not, whether you have a conflict or not, but day-to-day life, we need to develop technologies to make soldiers are comfortable in the even the extreme environment, forward areas, like that. Okay. So you can see the life support system. We got 4 domains: chemical, biological defense, life support systems, and then operational support, and as well as civil military interface. Primarily for information, whatever we develop, primarily meant for armed forces. We always section spin up in the society. There are several things I can list it out. You can see the all chemical, biological, we need to have sensors. Any outbreak, we should have a system in a place to detect it. Once you detect it, how we are going to decontaminate, how we are going to protect individuals, what are the antidotes, what are the vaccines, this is what comes under the, and again, these 2 chemical biological defense, we cannot work just the way, whatever way you wanted. It's only one laboratory approved by the United Nations, that's in Gwalior, the only place you can do it, no other place, because it's not allowed to permitted to handle this kind of agents. And also you can see the operational support, combat ration, as I already mentioned, and then high altitude capability, -30, edema, so they undergo a lot of no. So then you can see the waste management for information is not a municipal solid waste or any other solid waste. The human waste, which is -30, will remain forever. Our people, our team, which works in the Antarctica, they brought the psychophilic bacteria under frozen ice. They did R&D. Today we have got a system for biodigester which can dispose human waste. Same technology we given Indian Railways as a bio-toilet. This is what invention. This is what Clean India movement. So like that you can see the, and then combat casualty care. Like you can see the telemedicine. See, somebody sitting in submarine, somebody in the border, they cannot access a doctor. So we have got complete team of people to telemedicine. And then physiological monitor, because we need to understand the soldiers where he stands, what's body temperature, movement, physiology, wearable sensors. And then anti-G should already mentioned, have a bag, high altitude pulmonary edema bag, which is like your high-end ambulance for them to bring them to base camp. It's a precise bag. And then submarine escape suit, submarine filters. People like you, they have to sit for 3 months in this tubular vessel underwater. The same air you have to breathe, where Dr. Selukmar's works on the carbon capturing. So it's a very, very difficult task. Like that, you can see the high altitude agriculture. In the winter, you cannot carry anything. So you have to support our soldiers with agronomical technologies, what we have, Leh Ladakh area, there's laboratory. And then you can see, now, let's come to the subject. So the topic is given by team, advanced metal for defense application, strategic application. If you look at like, conventional metallic alloys, because combination of various metals, like silver and copper, gold and some other, so like that we have got a, and then metal ceramics, polymer matrices like carbon-carbon composites to carry the payload of even nuclear weapon. This particular carbon-carbon composite only that Kalam wanted to use it as a caliper for polar children's, where he brought out from 7.5 kg to 350 gram. So this is what so how the material which carries the payload of nuclear weapon, nuclear warhead, can be converted into usable caliper for the production. And then you can see the composites, carbon-carbon composites for aerospace application, intermetallics, then electronics important materials, smart materials. Smart materials, in some time, we need a material to have multi-functions, sensing, detection, even so many other applications. And then you also pull the internal tubes, slurp materials, especially when you use strategic materials in the some test facilities. What we did in the Pokhran nuclear test, we used technology, low absorbable materials. So these are camouflage materials. Like that, we have several materials. So you should check and see the, already I mentioned about how the ornamental metals like copper and tin or iron and carbon. And then again, see metal ceramics. You can see the say composition materials, short named as a composite, which are in the common name, which can materials made from the 2 or more constituents materials with the significant different physical properties, where we'll be able to get the enhanced like symbiotic effect. So we can have better properties. The intermetallics, but nothing but intermetallic compounds or intermetallic alloys or ordered intermetallic alloys, long range ordered alloys. You can see the like example nickel metal hybrid, electronic potential materials, because basically for circuits, electronic circuits, especially the radars and other aspects, we have got operation of optoelectronics as well as photonics and microsystems, including sensor systems. So these are the way we have got a lot of materials for application. And then as I wanted smart materials like shape memory alloy, piezoelectric properties, electroactive polymer, you can see all these materials can act as a significantly a change control such as stress, temperature, moisture. So all these have multiple. And then polymer nanotubes, basically like example carbon nanotubes, consist of carbon atoms connected with single and double bonded so that partially closed mesh. You can see the example. Slug material, as I already mentioned, low absorbable technology, basically radar and absorbent for especially including. India is already taken program for AMCA, Advanced Medium Fighter Aircraft, where one of the major program is the slug materials. So only you can see the sound, not an aircraft. So like that we can see the, and see now, nanotechnology, you can see how we are using, like detecting nuclear systems, biological sensing for every bacteria, every virus, every toxin, and then chemical sensing, like chemical like nerve agents, sulfur, suman, even nerve agents like so many other compounds, including, and then our resin, and then you can also the military platforms, robotics, and then nanorobots. All this way we use the so many materials in the, because already SAR spoke about the advanced. These are the applications we do in the defense system. And also you can see what are the key features to be advanced material. Already spoken, but still you can see here unique properties. The materials are engineered to nanoscale, offered enhanced mechanical, thermal, electrical, and optical properties with key features of advanced nanostructure like enhanced strength and toughness, what you have seen through your AFM studies. Then lightweight, improved ballistic resistance for base station, ballistic protection, and then enhanced thermal stability because we are subject to the various domain environment. Customizable properties, corrosion, what it means, suppose you develop a material for naval application, it has to be anti-corrosive, anti-skidding, anti-fouling, slow marine applications. So that way, this is all important. And also you can see how that I can include carbon nanotubes, graphene nanoceramics, nanocomposites. These materials are revolutionary defense technology, offering improved performance, durability, versatility, wide range of military applications. So when you have this kind of materials, we have to look for always better. Say for example, when you synthesize the quantum dot, for example. So it can be quoted as one of the layer in the satellite to understand the fire print. Same material can be used as a drug delivery. Same material can be used as a bioimaging. So we have to focus this kind of applications. Maybe basically you have to fine tune depending on your applications. So what the message is, when you focus the material, it has to be multifunctional, various wide range of applications. So you can see the advanced materials and defense, like CNTs, polymers, composites, graphenes, all these advanced materials have a potential significantly enhanced performance, efficiency, and also defense system, making them crucial the various defense applications. That's what I already mentioned. So you can see CNT, which is lightweight armor for protective gear, because you cannot put something very hard to give to the armor board. And then you can see the high strength composite for aircraft and vehicles, field aircraft transistors and electronics, and chemical biological sensors. And also you can see graphene, especially reduced graphene. You can see the two-dimensional material, excellent mechanical, electrical, thermal. When you have this kind, you can have this kind of lightweight, strong armor material, flexible, transparent electronic devices, high performance batteries. Batteries, suppose assume that if you want a battery device, the long endurance, the chip. So we need to have this kind of. Another important thing is when you talk about batteries, so people think about lithium. But now, if you look at international global scenario, only China got the scope. But no other country has got lithium. 90+% of lithium in this control. And also, if you look at the rare earth materials or magnetic materials, only China can play a role. So what we have to do, we cannot simply sit. There are other materials like alkali earth materials which can be alternative for your battery development applications. Like that we have to work on. And then high performance batteries, energy storage systems, and chemical biological sensor again. So nanostructural materials, you can see the here already repeated, I think. So the next is polymers. Here you can see when you have a textile for defense application, it has to have a fire fighters as fire retardant material, and also bomb disposal people, and again you have to have biological chemical protection, and again by tank crews, because another thing is equipments like shelters, tents. So everywhere we have textiles application, including you can see fabric components, including silver fabric, designed for maximum protection in the hostile environment, including chemical biological outbreak. So here you can see the nano-engineered polymer, which is highly fire retardant resistant, and also hypersaline solution, can also withstand low temperatures, ultraviolet radiations, has been adopted. Different stuff. This is what developed by the DIAT, one of the university what we have in Pune. So you can see waterproof and bulletproof sockets like carbon nanotubes also been used extensively in the pursuit of nano bulletproofs. You can see then ultra high molecular weight polyurethane plus graphene as a good bulletproof material, which is one of the rare application. And also you can see that one of the fiber made from the extremely high grade common plastic polyethylene bullet, also is a bulletproof and as well waterproof material. These are the materials we use in the application. And you can see front batteries. Here you can see imagine uniform that can diagnose and treat soldiers in the field. Say for example, one of the example, suppose there is emergency, you want to deploy people in the high altitude. So they have to be accomplished. So for them to understand their biomarkers based susceptibility. So this also can be, and also wearable sensor. Like that we have got important area. And then the screen printing sensors for the waistband. And another thing is sensor can detect the biomarkers in the sweat. Sweat based, you can identify the people are susceptible or not, risky stress or high altitude. So this is the way you can use the materials for application. And then invisible cloak, as I already know here, improved armor for major focus military technology research like TiO2 nanoparticle embedded with the epoxy matrix, and then SiO2 nanoparticles liquid polymer which hardens the plastic impact, especially for shear thickening fluid. And again, you can see the iron particles, the oil which hardens simulation with electrical pulse like a magnetical fluid. So this is also one of the important fluid which are used in the different system. And if you look at this R&D, in the nanotechnology R&D or advanced R&D, basically focused on improving the structural efficiency. For example, you can see the CNT coated, how the strength is improving, and then energy storage, because here the energy storage, we need to have several, even 5,000 cycles we need to have material for charging and discharging, and also to have a long endurance. And then you can see the nanophotonics, and then you can see the high energy materials, especially nano level of the explosives, RDX or nitro compounds and etc. And then sensors, nanoelectronics, signature management, and also strength improvement. These are the way we will develop the materials. And you can the audio endeavors, you can see here displays, and then EL display developed by this for defense Jodhpur application, this for desert application. The photochromics for adaptive camouflage, PASPER, indium gallium arsenide quantum dots for structure for lacing. We have got a separate facility, gallium arsenide facility in Hyderabad, which actually help on their complete missile program facility. And then you can see this super strong material for carbon nanotubes, CNTR, for discharge preparation, characterization, what we already spoke about. And then you can see the semiconductor in thin film deposition for the PEC and DSC applications like zinc oxide, cadmium sulfide, zinc cadmium sulfide, titanium thin films. These are some of the materials we use in the as a material here. So quantum dots here, if you look about quantum dots, single crystal, zero dimensional, discrete particle having size less than 10 in, especially what we get from this material, transitional metals. Unfortunately, when you take transitional metals for biological application like drug delivery or bioimaging, these are all extremely hazardous. What you have to do, you have to keep core as a nanodot, then you have to make a cell as a higher band metal like zinc. So you have to core cell, and also you have to make the surface passivation. So these are the important topics to make it as a sensing agent or even drug delivery agents or bioimaging agent, etc. And you can see the TiO2 nanoparticle self just smart textures, because in the case of chemical warfare agents, outbreak in the field, we have to have a suitably military actions, terrorist attack incidents, how we are going to present protective gears afforded by the only physical protection, and also barrier against the toxic fuels, where we talk about the 7-layer of NB suit, including one of the layer with the carbon spheres with the laminated fabric. Like that, you got to see the TiO2 nanoparticle has been shown the most promising because the easiness in their synthesis, and also because excellent catalyst, and also very low price, and also there's no toxicity because it's a biocompatible material. So like that we have got a material. Now can see the structure functionality modeling, how we can see the blended wing body for subsonic aircraft, and also can material interface for morphology, can cross-linking, reticulation, organic dope layer, and also you can see the ecological, you can also use it as one of the catalysts for decontamination of the including chemical warfare agents. So this is the way you can use this kind of advanced functional materials. And then composites for smart materials, for synthetic approach, you can see the synergistic approach, you can see how the functional materials have optical fibers, nanotubes, semi alloys. We have all the attractive materials. The main advantage, you can see the act simultaneously as sensors and actuators, as well as perform the control action without any external mechanism, both physical and physical mechanism, and adapt to environmental conditions of different domain, high level of miniaturization, and new functions are developed. This is the way this can use this synergistic approach. When you add the material for multiple material, it has to add the properties for multiple. That's what synergistic applications. You should not one material should not suppress other material. That is the main aim here. Then talk about biomaterial. See, the biomaterials are very, especially they are given on a topic here. It is not, the biomaterials has to be, there are a lot of, especially the biomaterial, the synthesis, characterization, even applications have a very, very tough job. And also we have to prove this is all biocompatible. For that you have to go for phase 1, phase 2, phase 3 clinical studies. They are very complex. You can see how biomaterials are non-toxic should be. Biomedical implants like under prosthetics. You can see the American Health Institute, they are different substances improve the body's function without causing harm. Because it goes, say for example, you take your dental implant or bone implant, it is subject to the body fluid. Every individual body fluid is different. So there will be a lot of side effects. So that we have to make sure, and also ISO standards, biocompatibility such as medical device to perform with appropriate host response. What sir is told about gadolinium. Gadolinium is a heavy metal. Gadolinium is one of the extremely toxic heavy metal. Now, and again, when you talk about imaging, medical imaging, MRI, PT, CA, we have different techniques. Now, what we did is that rhodium disaccharides, manganese sulfate is a composite, single contrast agent, except without even gadolinium, can be made as a contrast agent for all multiple imaging in single contrast agent. This is one of the breakthrough work taken with the DSC support. So this is the way you have to move on. So one is we are avoiding gadolinium. Again this material also we are modifying hyaluronic acid, which are extremely good in the make it as a biocompatible. You can see to be a biomaterial, you can see the biomaterial matters. You can see here this characteristics of biomaterial. You can see it should be nanogauss material, composite material. You can see protein, polysaccharide, sponge. You can see so many polymers, especially from synthetic biomaterials, and then natural biomaterials like exomine, collagen, hydrochloric acid. So all the things are having advanced medical application. And also you can see types of biomaterial. See, like metals, even metals are biomaterial. And you say about stainless steel, the orthopedic implant, and then titanium, dental implant, and then polymers, polyurethane joint replacements, hip replacement, silicone, breast implant or cathedrals and contact lenses, and then ceramics, hydroxyapatite as a bone graft, and then dental implant, alumina, and also orthopedic joint replace. The composites, carbon, imposed polymers for orthopedic implant. So these are the like we have various biomaterials based on their composition. Can go. It has to be to call it as a biomaterial. It has to have a property like bioactive, bioinert, natural, and also synthetic. And also bioabsorbable. All these products you have to have call it as a. Say for example, you take an bacterial cellulose. One of the it can even make a bacterial cellulose. Bacterial cellulose is nothing but if you take asobacterium group, if you give the proper nutrient broth for 14 days, you'll get like a handkerchief. If you characterize this material, the best material for protection, especially Staphylococcus aureus standard organism, 100% filtering capacity is got. And also the crossing is and excellent water holding capacity. When you have this kind of water holding capacity and also have good surface area, you can load the more drug. When you have good soft capacity, soft material, like 3rd degree wound healing is in this up to the wound, the bone, can make it as a soft material. You can also have a more load, can for longer time. So like that we have material, and then you can see some of the, like titanium alloy corneal implant, and then wirelessly controlled drug delivery implant chips, and then carbon fiber screw with the titanium polyaxial head for carbon fiber reinforced rods. So some of the materials, and you can see the ceramic biomaterials. You can see these all all these things are having example aluminum oxide, carbon tetrahepatite is a bone implant, highly biocompatible is a very net material, high module. So that's also very important, and then compressive strength, brittle. So all these we have applications like so many other applications. Ceramic biomaterials like alumina, zirconium, calcium phosphate, silica, and another tetrahepatite are common. Advantage here is you can see it's innate in the body, bioactive in the body, and again high wear strength, especially the orthopedic and dental, and then high modules, stiffness, and also compressive strength, and fine aesthetic properties for dental application. Disadvantage, some of the materials like tetrahepatite are brittle because if you are not able to make the proper calcium composition, the tetrahepatite material, for example, low fracture resistant and also flow tolerance, and low tensile strength, like fibers are exception, and then poor fatigue resistance relates to the flow tolerance. So this is the way I've got some of the other ceramic biomaterials. Polymeric biomaterials, you have they are all sometimes water absorbing like your cellulose or water repulsion for some cases, and then you can see the biostable because the biological fluid is extremely complicated system, and then they has to biodegrade, say for example stitching items, switching items, and then natural materials, synthetic materials, the highly processable. You have all these polymeric biomaterials for various, including drug delivery, skin tissue engineering, bone tissue engineering, then you have what like cardiac tissues. Now people are working on the after 3D printing or even additive manufacturing. People are even planning to develop the artificial organs, including kidney, heart. So there is a lot of things are happening here. And also polymer materials, you can see electrospin materials. What already for converting your polymer into fibers, like electrospinning. There you have to optimize your viscosity, density, even in your electricity. How we are going to see according to the distance between the collector and the cone. Like that we have got so many other. This one of the another thing. This particular electrospin material have wide application. It can be a scaffold. It can be a filter material. It can be a wood killing material. It can be a road carrier, drug loading carrier. Like that we have got a number of applications. And again, the only thing is most of the biocompatible polymers only can have this kind of property for biomaterials. In addition to the other, even industrial application. Now people are using it as for industrial applications, especially in the occupational safety. And then you can see polymer nanofibers, like in how you see and that here polymer materials like filtration, synthetic like this, and then protective clothing, biomedical, all this area they use it. And nanocellulose for wound healing, that you already spoke about this one. Okay, what is importance here? You can see here. See all these implants. You can see some of the finger joint and then breast implant. All this way we are using this kind of products. And again you can see the biomaterials have electrical and medical equipment like in a PDMS, silicon-based device, and then pharmaceuticals, nutrients like in example cellulose or chitosan and silicate clays, and clinical diagnostics like MXenes. MXenes are new compound of material where you have extremely very good property in the electrical conducting properties. When you talk about the quantum dots, have excellent corrosion properties. When you talk about MOF, metal oxide framework with organic linkers, huge surface area. Recently the reports in the ACS journal, 10,300 meters per gram when you take 1 gram of material. So it's 4 times bigger than your football ground. So can you imagine when you have this kind of highly porous material, highly surface material, you can go for energy storage, gas separation. Even you can make it as a material for like like an alternative to batteries. So there are so many applications. So if you make it as a sand layer assembly, you can have a better property with QD, with MXene, with the MOP for the various defense applications. It's going to be a future. And then you can see the classification of medical device. You can see some of the like class 1 devices, class 2 devices, class devices. These are the examples. So lack of time I'm pushing down. And then these are human biomedical implant, medical devices, and biomedical sciences. You can see some of the how from the 2000 to how we are moving towards. Now as I already mentioned, now people are working on the even printing the artificial organs. This is the way these are moving. And then innatness and the activity, you can see the engineered tissues have living composite cells, and then additional factors by biomolecules and biomaterials. Yeah, see biomaterials which are biodegradable, injectable polymers, battery composites have hard tissue displacement, and also have more aggressive role in the body. And also, while biodegradable materials should affect the equilibrium of the body as little as possible, and also have interacting between the material and the surrounding tissues. So, as I already spoken about we have to make sure that materials are very there won't be any toxic, including acute and subchronic and chronic toxicity. Above should not have irritation to skin or muscles. You have a sensitization and hemocompatibility, especially with blood. And then you have short-term implant effects, genotoxicity, and then carcinogenicity of effect, including developmental effects. So, see, another thing is, if you look at the market size, just from 2022 to 2032, how from the 150 billion to 540 US dollars. So that's why, by considering this particular international market size, the way it is going, and another thing, India, we have a lack of all biomedical devices and materials. So we have to invest more. We have to do a lot of things to done. And if we look at like this, government has made a National Medical Device Policy 2023, April 23. If you carefully go through this policy, they have created a lot of how to attract the foreign direct investment, how to give the single window clearances, how to make a center of excellences, how to have academic collaborations, everything will. Another important policy, all of you have to read that E3 bio policy. Economy, environment, and employment. Without this policy, no technology going to succeed in the future. So for all the engineering students, you must know about the biomedical device policy as well as E3 bio policy. These are very, very important, very clearly made it. The government did a lot of effort on this one. So that recent one, 2024 August, they released this particular E3 bio policy, which is going to promote your basically environment-friendly materials, how to make the employment-friendly materials, employment-friendly future, and also economy. Because India is already third largest economy, third largest economy, and third largest in the after Japan, China, and Asia. And again, 2047, when you attain your Vikshit Bharat, you have to be powerful in military power. Another power is knowledge power, economic power. Not by GDP. The economic power is by per capita income. So we have to go in the right direction. For this, all these initiatives are very, very important. And then you can see the metal organic framework. This already has spoken about. And then energy. See, another thing is in 2050, we have to have another 50% energy enhancement. You see the way in which India is developing urbanization, industrialization, foreign direct investment. So another side, we are committed in the Corpus of Partition 2015. Paris will be minimizing 30% of CO2 emission by 2030, 0% by 2050. Our Prime Minister's commitment. So in this case, we have to completely move on to like solar energy, hydrogen splitting, because that's why you got so many missions under the SDG, Sustainable Development Goals, which we agreed by the many countries, the 2019 COP conference. So India has a lot of, because now only we are growing, now only we are investing a lot, so there will be a lot of impact on our environmental resources. So our bound duty to meet out all these national mission as well as requirements. So this I will already spoken. So this I already. Another thing in environmental application. So now, basically what has happened, some of the Tirupur is an example. After maybe 1 kg of dyeing is required for your dyeing process. Because of the conventional method, we require 10 kg. There 9 kg we are dropping out in the wastewater. Now the technology has come up. And again, what we do in the the treatment process, so-called like perchloride or parasulfate as a flocculation, we are converting from liquid to solid. We are dumping like a hills. When again it gets into seepage or even underwater, it goes into this. So what we have to do, we have to find a solution for once for all. Either you have to degrade, you have to use a Another thing is we have to put a lot of effort to bring the modernize the dyeing technologies or any industrial technology so that we are able to minimize the solid waste. Because if you look at solid waste as an example, today there are a lot of challenges under government of like municipal solid waste, even urban, you can see the industrial solid waste, even your many of the things are that's why plastic waste, electronic waste. So you have to have electronics are very, very dangerous because there's a number of lead, so many other mercury components. So there are act has come recently how to handle the electronic waste, how to separate it, how to recycle it. Now there are 5 R's: reuse, reduce, recycle. There so many things have come now. So this will let me know. And also you can use the a mop as a sensing agent. Also graphene for base materials for various other applications. This embassy already told about this one. And these are the organizations from the DRDO. Like we are working for various academic institutions and basically active involved research development. There is the organization working towards developing indigenous nanocell material for to meet out the defense requirements from all these labs. Most of the labs are based on the material based R&D. So especially like if you look at your DMRL, the core laboratory in the country for metallurgy. So like that, if you go there, everything is available, including high-end lithography for even your realizing your medical devices or even your nano devices. With this, I wish to thank the organizers for giving opportunity to come over here to share some advice. Thank you very much.
Thank you, sir.
Thank you, Dr. Kadir, for completing the lecture and time. I think now we can appreciate the advanced materials which are used in DRDO. We are working in all the fields like stealth materials, structural materials, biomedical materials, radars, electronics. You name any field we are working. Probably we are not publishing that much outside, so people may not know what kind of material we are working on in a very in an in-depth manner. Whenever we develop a product, when it comes to the public domain, that time you are able to appreciate. But for developing any product, any smart, intelligent, self-healing or any kind of material, any product, you need equivalent smart, advanced materials which should work in that particular given environment. The material should not work in the laboratory. Making the material working in laboratory is okay, you can demonstrate, but when you are deploying in the actual field scenario is very, very different. From low temperature to high temperature, high humidity, low humidity, cold, very cold temperature, the material should respond to that. For example, batteries, it may work at room temperature very nicely. When it goes to minus 40, what will happen to the battery? It will behave entirely different. So whatever materials we are working, Dr. Kadirvel has nicely brought out. He cannot, I know that he cannot complete the complete spectrum of material we are working on in this lecture. You can further interact with him. At present, I also appreciate his effort to bring all those things, whatever is possible, that we are working in DRDO. And I thank you, sir. And we can have a couple of questions with respect to his lectures.
I spoke about civilian application. I told about implants. I told about your biodigester, even food, MRE, meal ready to eat. There are items during COVID. The only active organizations in the DRDO.
Thanks, because some of the topic I am going to present in the afternoon, because we are coming from the same lab. I was worried when presenting whether he is going to present my thing. I have a new thing, I think entirely new things for you. Thank you very much. COVID application, I will also tell what particularly our labs, how we have transformed the defense product for the civilian application. You know very well the defense product, when the defense products, when they came out in World Wars, they are not only meant for only defense. Ultimately, they reach to the civilians. So you will come to know from my lecture also. Yeah, I don't want to blow my own trumpet now. I have something new to show you. Thank you.
Any questions? Give the mic.
Good afternoon, sir. I'm Sindhu Kavi, research scholar from KPR-IT. Like, as you discussed that chemical warfare, we, myself and Nilofer, we both are writing a project based on it, and we need some insights on the project proposal. Like, what are the major points we have to include?
For chemical warfare agent?
Yeah, neurotoxins. Like,
as academia, As I already mentioned, this only lab which can work in the chemical warfare is the DRDO as per the international treaty. India is signatory. I understand that India is the first country to dispose the existing chemical warfare agent. Maybe you can think of working the stimulants. Stimulants,
okay.
not on the real agents. Because international treaty will not allow you. You cannot even buy a compound, you can do anything here.
No, sir. Actually, we are writing the project proposal for the scheme, the same DRDO scheme.
You see, chemical warfare agent you are talking.
Yeah.
That's why I am telling.
No, it's okay. You want to know how to approach DRDO for the project proposal.
Yes, sir.
My lecture I will cover what are the methods that you can approach to DRDO. If you have a problem that is very well aligning with the DRDO, definitely we will take up. So you can consider my lecture as an outreach program, because I am going to show how you can get the project from DRDO, the methods, what are the different methods available for the institutions, mostly for the institution, even for the individuals also there are some programs are there, like Dare to Dream, how to go about, to whom it will be given. I will give in my lecture. Okay.
Thank you, sir.
Okay, thank you.
Good afternoon, sir. So it is apart from the lecture. So how is DRDO currently leveraging AI on the defense?
For information, this I wanted to highlight. Every institute is marketing the AI. Let me make it very clear. Peter, if you Google it,
yes, sir.
the first time we got India got at least visionaries. In the 1986, India got a first AI laboratory. This is called CARE, Center for Artificial Intelligence and Robotics, established by Government of India 1986 in Bangalore, CARE Prom. You know how much effort taken by those people from 75 onwards. India 1980 we had AI laboratory. So it's very high-end strategic application where our Home Ministry as well as our Defense Ministry closely works for all strategic applications. AI is not, it's 40 years old technology in DRDO, including robotics. So
Presently, when we write the project, we also incorporate the AI component in all the project proposals, and AIs are mainly used now in DRDO for material selection as well as the biomedical applications. We have different verticals in one of the DAACOI center, which particularly talks about the AI. But at present, we are mandated to write in our project proposal how the AI risk mitigation plan, all these things have now come to. So we want to know, the basic requirement is we should know what is existing, then only we can predict. So for that we have the methods we are incorporating in our newer projects. Yeah. Anything else?
Then also, are there opportunities for the academic institution or the students to collaborate with DRDO?
Sir will talk. There are 15 centers, 4 research boards, society, extramural funding, everything will brief.
Okay.
And also we have a paid internship for students. Paid internship for students for final year. Now we introduced paid internship. Even under a project, if somebody gets 50 lakhs project, they can project 2 internship per annum per student. They can propose the 3 to 4 lakhs for conducting workshops or in the conferences in the specific domain. So everything we have are brief.
The apprenticeship.
Another thing, a very important point, earlier they are very difficult to get into this kind of organization. Now the only platform is a gate. Only platform is gate. If you have a 6+ GPA is fine. If you have an excellent gate score, you can be a scientist in ISRO, DRDO and atomic energy. We have so much flexibility as government has made.
Yes, sir. BEML, they are all, once in, I think in Bell, even for the apprentice they have chosen, they took gate as the benchmark. Gate as the benchmark.
So is there any specific skill sets for the engineer?
No, whatever academics you are doing and your internship you will do it, and then project work you will do. What about your CV? Based on your CV, you have to approach that particular lab.
Say for example, you assume that ECE student.
Yes, sir.
Whether you are analog or digital or device, so that will be explored during the interaction. Because basically you are qualified as electronics engineer with GATE to be a scientist. There the requirements are varies. If you go to electronics lab, that's different. If you go to biomedical lab, how they look at how you can use biomedical devices with use electronics. If you go to radar, how you can use in the communication. If you go to the other side, how you can decode the language, the cryptography. It varies domain to domain.
Natural.
We have different clusters that I will explain, and then each clusters have their own problems. to solve. And each cluster needs all the discipline. So now, yeah, if you get an opportunity, you can get into some of the labs and contribute to the nation. Yes. The thing, one good thing is that whatever research we do, we implement to the soldiers. The soldiers are again securing the nation. So we are happy to that extent. Thank you.
I add here, because I have given the topic nation building. For information, 4.84 lakh crore worth product DRDO is delivering to the armed forces per annum. See, when you have this kind of indigenous development, you can minimize your import. You can make your scientific strong. And also, you can invest this kind of money in other like healthcare, education. This is the way you can build this nation. That's why whatever we do is simply not on military. It is for nation building. One side we are supporting industry growth, economic growth, export. We are investing in import of weapons. This is the strategy. So there's a lot of domains to look at. Ultimately, nation building is a aim with military power, economic power, and knowledge power.
Thank you. Shall we close the discussion?
Thank you so much.
Yeah. I think it's again, I thank both the speakers for giving a wonderful insight into the material science through in terms of academia as well as in terms of the defense applications. Shall we conclude the session now? Yeah. Thank you. I think some more formalities there to finish. Yeah.
Thank you, sir.
We'll go ahead with
I request Dr. S. Krishnaveni, Assistant Professor, Department of Maths, to present a memento to Dr. N. Dharmaraj, Professor of Bharatiyar University, Coimbatore.
I request Dr. D. Prakash, Associate Professor, Department of Physics, to present a memento to Dr. K. Kadirvelu.
Thank you, sir. I request the students and participants to break for lunch and assemble back within half an hour. For the next session. Half an hour.
Dr. Selvakumar is a distinguished scientist currently serving as Scientist G and Associative Director at the Defense Bioengineering and Electromedical Laboratory, DRDO, Ministry of Defense, Bangalore. He also heads the Material Technology and Environmental Protection Divisions and serves as Head Quality of Assurance as DBEL. Dr. Selvakumar graduated from Pondicherry Central University and M.Tech in Biotechnology and Engineering from Indian Institute of Technology and PhD in Chemistry from Bharatiyar University. He began his career with DRDO in 1998 as a Scientist B at DMSRDE Kanpur and has since contributed over 2 decades of dedicated service to defense research and innovation. His area of expertise span MOCVD, precursors for component semiconductors, nanostructured metal oxides for gas sensor, electrochemical and fiber optic biosensors, hemistatic biomaterials and CO2 capture and conversion technologies. Dr. Selvakumar has an immense research record with 5 granted patents and 27 scientific publications in reputed journals. His contributions continue to strengthen India's capabilities in advancing materials, defense biotechnology and environmental protection. Ladies and gentlemen, please join me in welcoming Dr. Selvakumar.
Thank you, Shati Ganesh. I now hand over the session to Dr. N. Dharmaraj.
So, good afternoon, everybody. So, after a sumptuous lunch, it's tough to sit in the session, but I'm sure Dr. Selvakumar will handle the session in a nice way. You won't feel sleepy, right? And you should not sleep. I'm happy to invite Dr. Selvakumar to present his lecture within about 45 to 50 minutes. And I am happy to chair the session. Selvakumar was my student for PhD in my laboratory. Now he is the invited speaker. It's my happiness to chair the lecture by my student Dr. Selvakumar, who taught me several aspects of chemistry. Actually, he joined PhD with me. I learned many things from him. He is a very sound person in chemistry, materials chemistry, and even biotechnology also. Please, Selvakumar.
Thank you very much, sir. But I can never be a better person than my guide. I learned many things from my guide. So, thank you for your kind words, sir. I don't know whether I am truly deserving that. Yes, let me start the lecture. So as I was introduced, I am working as Scientist G and I am Associate Director in Defense Bioengineering and Electromedical Laboratory, Bangalore. I thank the organizers for giving me this opportunity to talk in front of you. And my lecture I have designed in such a way that I will just try to introduce
keypad idhula guys.
So I'll just introduce about our organization, that is DEBL. I am working in DEBL. Already our Dr. Kadirvel has introduced about DRDO in a whole, but I will be specific to my lab, that is Defense Bioengineering and Electromedical Laboratory, and the kind of work we do, like hostile environment. We are providing solution to the soldiers who are posted at various places, and they experience various hostile environments. I will explain what are the hostile environments in my subsequent slides. And if you want to provide comfort or the operational capability to the soldier, we have to there are some materials which are also important to provide them the required comfort and functionality. So what are the products at present our DEBL has introduced to the service, and what kind of materials by which they are made or they are fabricated, and what are some kind of, I won't say it's a gap because they are all accepted by the Army, Navy and Air Force, but I will say that is what are the scope for the improvement, and material wise what are the improvement possible, and finally in which way we are now the other part of my discussion is how DRDO and academia collaboration can happen. So this is not known area for many of the academicians. So through this lecture, I will just talk about this aspect also. So in DRDO, we are clustered by 7 clusters. One is naval systems and materials clusters, and the next one is aeronautical systems. Third one is armament and combat engineering cluster, and missile and strategic systems clusters, electronics communication systems cluster, and microelectronics and devices, computational systems and cyber systems. And we are coming under the soldier support system. It was earlier named as life support system, but we have now changed the name into soldier support system. In soldier support system, there were 47 labs, and now it has been reduced to 36. And among the 7 clusters, we are into this cluster, and DEBL is part of this cluster. And you can mostly see in the news about the missile launched and the LCA taken off, those kind of news, but you won't be probably you won't be knowing about the naval systems, missiles and other clusters. But in all the clusters, if you see, the materials is materials is indispensable to take care of any cluster. Like for example, naval systems, there will be materials by which we may have to incorporate in like warships or underwater objects. In aeronautical system also, right from the cone and then the tail, and then there are some material which has to withstand the engine exhaust. So there are materials. And in armament, if you come to the combat vehicle, like our MiG medium combat vehicle, you know that CVRD is working on that combat systems. So we need a lot of composites to withstand the blast, and lot of materials are involved again, and not only high strength material, but also they should be lower in weight. And missiles, again, yeah, there are propellant is a material, and the structural aspect of the missile is again material. Electronics and communication also, there are some materials involved, because without silicon fab lab and then semiconductor, quantum, the compound semiconductor, you cannot achieve a fast electronics. Microelectronics and devices, again, you know that a lot of materials are involved. And I will mostly talk about the possible materials in which soldier support system is being, in soldier support system, these materials are being used, particularly to our lab. So this is our lab, Defense Bioengineering Electromedical Laboratory, which was which was the brainchild of Raja Ramanna in the year 1982, April, to be very specific, April 1st. And our core competence of the lab is to design, develop, evaluate, and technology transfer of life support systems, protective equipment, and biomedical instrumentation and devices specific to armed forces. Armed forces in the sense both Navy, Air Force, and armed persons. The area of work is NBC protective equipments, underwater systems, high altitude protective equipments, life support systems, biomedical equipment, and closed ecosystems. For your appreciation, I will just show some of the, okay, before that, I told that as an India, we have a very peculiar war theaters. Our war theaters are very different from other countries. Like we have high altitude, that is Kashmir, Siachen, where low pressure will be there, low oxygen will be there, -40 will be there. We have a desert area where the temperature can go up to 50, very hot condition, and there are some desert area where a lot of raining will happen as well as humid area. And we have anyway this water and also the terrains, different terrains in which our soldier has to perform. So if we talk in terms of numbers, so India is having a airspace of about 2.8 million square nautical miles, and we have a land of 3.267 million square kilometers, and the sea is 11.085 kilometer coastal line. So everything has to be guarded. Each and every location is very challenging. In all so you can see that wars, in war situation, they are fighting with the arms and then armed vehicles and fighter aircrafts and also the warships. But in all the operation, there is one is very common. That is the soldier. A soldier has to operate. All others are machines, but soldier has to operate the machines. So our lab tagline, that is our double tagline, is protecting the protectors. We want to protect the protectors. We have to give comfort. They should operate in all challenging situations, and also they should perform their duties without any deterioration. Right? Not only the physical, but also mental also. Okay. If I put it in one slide, for example, aeromedical. We are working for aeromedical, biomedical, and underwater. In case of aeromedical technologies for survival and performance of the performance enhancement, we have gas separation technologies. Like sometimes we have to separate oxygen from air, sometimes we have to separate nitrogen from air. For both we are working, and also whenever you see gas separation, the gas sensor also associated with this, because you have to measure how much oxygen, nitrogen you are able to produce, and then you are able to give to the soldier. They are measured by the gas sensing methods. And also respiratory management. Respiratory management in the sense, at a different altitudes, we need different kind of oxygen concentration, different pressure, different flow rate. All these comes under respiratory management. And G protection, you know that whenever there is a fighter pilot is flying, he has to take a lot of maneuvering. During that time, G, that is gravity. The pilot will face about 6G protection. During 6G, 6G. During G, what happens? The blood from the brain goes to our torso and the lower part of the body. So if it is happening for maybe 1 or 2 seconds, the pilot will become unconscious because oxygen is not going to his brain. How it is stopped? There is an automated system which compresses the thigh level veins and arteries, and it pushes the oxygen towards the brain. And also pushing the blood to the brain also depends on altitude, and also how much G that the pilot is going to experience. In this area also we are we have developed. Working in the sense, we have given away our products to the forces. We have impact protection methodologies, then high pressure gas systems, then AI enabled technology. Morning you are asking about what is AI enabled. For example, if we are going for different altitudes, or we are going for the different depth of the water, so every physiological parameter will be captured, and the person may not require that much oxygen at every level. So how to implement the AI? That also is the future work which is happening. And in case of biomedical technology that enhances the physiological and cognitive capability. A soldier can work, but how efficiently he is working is called the cognitive requirement. So in this direction, we have an exoskeleton technology. So the soldier can wear, and he will not, about 60% of the weight he will not feel. All the weight will go down to his toe. So he can carry, if he is carrying about 100 kg, only 40 kg only he will experience it. So that is the exoskeleton. Then wearable health monitoring. When a soldier is performing at a very strategic place, his health has to be monitored continuously. So he will be wearing a health monitoring, a kind of wearable sensor, and all his vital parameter will be monitored, and the feedback will be given, and the doctors who are there away, this data will be transmitted to them. So if there is anything is happening, they can immediately come and rescue them. So we, in this direction, we are even working for the Gaganyaan. You may be knowing that ISRO is going to launch the Gaganyaan. From our lab, we are giving 3 products for the Gaganyaan. One is the wearable health monitoring system. Second one is the dinghy. Once that astronauts, they will be landing in the sea, because that module will come to the sea. After landing, these people have to float safely so that they can be rescued. So that dinghy we are providing dinghy solution, as well as we are also providing emergency escape kits. So when they were staying, at least 3-4 days they should stay. So food is being provided by Defense Food Research Laboratory, and our lab is packaging them to a qualification of aerospace qualification. And we have a HAPO, high altitude pulmonary edema, I will tell, as well as NBC protection. And underwater, we are working on underwater respiratory management as well as emergency escape, that I will explain. This is an emergency escape. This is called submarine escape suit. So when a submarine is abandoned, for example, 100 meters below, for every meter of water, if you go down, 1 bar pressure will increase. So 100 meter means you have to experience 100 bar pressure, and that much bar, what will happen? Our dissolved, we have in blood, we have dissolved oxygen, nitrogen. It is like a compressed soda. When that person is coming out, when you open the soda, all the air is coming out. Like that, nitrogen and oxygen. Oxygen will become toxic, and nitrogen will come from our joint and the blood vessels. So it is a deadly situation. So double is providing a solution for that. So I will just go one by one. Okay. So in a nutshell, we are doing in all the 3 areas prevention. We are prevent something catastrophic should not happen. We detect the physiological parameters, gas sensors, and diagnosis the soldier, and also we suggest the therapeutics based on that. Okay. As a spin-off, we have all the products having some of other spin-off. Whenever it requires, that will surface. It will go to the civilian. So during the COVID situation, we have given 2 major products, major visual product. We have given a lot of products. Among them, I will show only 2 of them. So what is CBRN? Sometime let us consider some enemy countries spreading chemical, biological warfare. They can spread through air, water, or soil. So it can spread through that. Mostly chemical is spread in air. So we have to protect our nasal and our oronasal, as well as skin, eye, everything should be protected. And we should also at that time breathe. Without, just by closing we cannot survive. So we have to breathe. So for protection from the skin, we have the NBC suit, which is made of activated carbon incorporated fabric. Dr. Kadirvel is the expert in that activated carbon. We have respiratory mask. Double has designed the double means our lab. Whenever I say double, you can consider it's my lab, our lab in which I am working. It has developed mask, rubber-based mask. Bromobutyl and neoprene are there, and visor is also there, polycarbonate visor. And these are the 2 canisters. You can see one is here, another one is there. There are the 2 canisters that will actually filter the air. So it will provide the protection for about 4 hours. That also contains an activated carbon. I think Dr. Kadirvel again talked what is the kind of surface area each gram of activated carbon. 1330 meter square will be the activated carbon. It will have a lot of functional groups. So whenever the chemical agent is coming, it will be able to absorb, and it will give a breakthrough time protection. So if somebody is not able to wear, the solution is you have a hood. In the hood, all these things are incorporated. So whenever we make in a large quantity, there is also, the mask has to fit snugly. So we cannot put all the mask to every person and then test it. So we have a test facility. On the dummy, the mask will be fitted, and there is an automated equipment which will tell whether the mask is all right or not. Okay, these are the before the activity. For example, somebody is affected by NBC chemical warfare. So there are resuscitator, manual, as well as the electrical automated resuscitators are also available. And if somebody is not able to move, then you have to put them in NBC evacuation bag and then take them to the nearest hospital. If somebody is able to move, we can put the half, he can wear and he can walk and then he will move to the safest place. So the next one is whether, so this we are talking about the NBC protection. It can happen air also, in anywhere it can happen. So specifically coming to the high altitude. High altitude we have a lot of problem. So when you climb, when you go high altitude, for example, again 2,500 meters, what will happen to the body? First one is we are having lesser oxygen. Second one is the liquid accumulation will happen in the liver, and the soldier can die also because of the liquid accumulation in the liver. So how to prevent it? So you cannot bring, if somebody is facing that kind of symptoms, we cannot bring them directly to some 8,000 feet. So there was a HAPO chamber developed by Devil, in which the person will be kept inside and pressurized. And because we are increasing the partial pressure of oxygen inside, the person will experience an 8,000 feet. So suddenly from, he is there at 2,500 feet, 800 meter, so he will experience an 800 meter kind of height. So he can be rescued, and this whole thing can be transported by the soldiers. So the second one is at high temperature we have a low temperature, I mean at high altitude we have a low temperature, so there are some electrically heated blankets, and for that we have developed the patented technology of stainless steel based fabrics, incorporated patches incorporated in the fabrics, and we also have electrically heated jackets and trousers and electrically heated gloves and foot insole. So these are all regularly used by the armed forces. So you can see that as I have some more slide also, but you can see that everywhere I am mentioning some material. For example, this is neoprene coated nylon rubber, and this one is polyester incorporated carbon, activated carbon. Here I was talking about the stainless steel fabric. There is a lot of materials you can just expose, you can come across. So the next one is for the fighter aircraft. So we have problems. I already explained that at higher, when he is going at higher altitude, in-flight hypoxia, there will be lesser oxygen will be there. Basically the partial pressure of oxygen will be very, very less, because the total pressure itself is going to be less at the higher altitude. So we have to provide the oxygen support. That is one. Second one is G-induced loss. Just I was explaining that when that pilot is taking a maneuver, a lot of the G-force are acting on him, so the blood will be going to the bottom part of the body. Blood has to be sent back to his brain. So there are two problems, and for both the problems there are some subsystems are developed, like onboard oxygen generation system, oxygen sensors, and then if oxygen generation is failing, there are some liquid oxygen. These are all the solution provided, and this onboard oxygen system is a very, very, very interesting, because earlier people were carrying the liquid oxygen. So liquid oxygen is stored in a cylinder which will come in for a very lesser period of time. And if liquid oxygen is getting over, the pilot has no other option and come to land to the ground. So the onboard oxygen system was already developed by Western countries, and Double has developed that, and it was incorporated into the LCA. Recently, all the life support systems were incorporated, and the pilot has taken a flight of up to 5,000 feet above. And in India, I think India is the 4th country to achieve the whole solution for the combat aircraft. And when you want to jump from the aircraft, so you need a lot of requirement, like combat free fall pre-breather console, and bailout oxygen, because he has to eject from the pilot cabin. Then dilution demand oxygen regulator, because at every altitude he needs a different kind of oxygen. So dilution demand oxygen sensor, oxygen regulator, then hoses, all these were incorporated into the services. So the other products are like FR means fire retardant. I told about the anti-G suit, but if the pilot is ejecting, the fabric itself should not catch fire. So there are some fire retardant fabrics are developed, and the whole system is owned by the pilot. And this is the anti-G suit. He is also wearing the flame retardant overall and jacket. And Double has developed aircraft helmets. So when you talk about the helmet, when you talk about the fire retardant anti-G suit, you are talking about the metaramide, which is used. It's a high performance polymer. Metaramide is a high performance polymer. And if you talk about the helmet, you can talk about the composite materials which are being used in developing the helmets. So the whole product assembly has been developed by Debel, and as on date, all the aircraft which are flying, or fighter aircraft, especially fighter aircraft which are flying on air, all provided by the Debel has only provided the complete aircrew protective equipment. So with respect to the biomedical, we have developed a portable rugged telemedicine system which can acquire all the parameters like ECG, blood pressure, respiration rate, heart rate, SpO2 and body temperature. And this is connected to about 63 ships and 12 submarines and 12 remote locations, very confidential locations, 6 islands and 4 hospitals and 4 mobiles. All are connected to through a secured line which goes to the research and referral hospitals. Doctors can monitor the health of the patient and give them the regular, the live remedy. So this is the remote physiological monitor system I was talking about, which was initially developed by the soldiers. Now it is going to the Gaganyaan. And this is a wearable SPO. This is also another interesting product. Like for example, if a patient is requiring some oxygen, that even for the COVID, he doesn't require 100% oxygen always. He requires oxygen what is required. So Debel has developed one feedback system from the SpO2. You measure the oxygen concentration at the finger, and that oxygen concentration signal will go to the one electronic circuit. The electronic circuit will control the cylinder's valve. So only necessary oxygen only input will be given. So there is another product also like portable vital parameter monitor, again biomedical equipment. So during COVID, I explained that there is an onboard oxygen system. This system was converted into a big plant, and Coimbatore also, Dr. Kadirvel also played a major role in developing this, getting this small prototype into a big system, into a reality through Trident Coimbatore. There were 931 plants at 869 sites during the second wave, where oxygen was not at all available. The patients were dying because of the deprivation of oxygen. These were installed, and all the systems were monitored by IoT devices and real-time monitoring, whether they are providing, whether they are functioning, or whether they are providing the enough oxygen. Everything was monitored, and the SpO2 system was also converted into a converted into a patient bed line. Near bed, where the patient can be given the oxygen as per requirement. About 1,50,000 systems were supplied because of from the simple solution. You can see that COVID, how many lives it would have saved. All this funding has come from the PM CARE at that time. Although these products were developed by the DRDO technology. Now, if you come to the materials, so you have seen a lot of materials during my lecture. If you come to the materials for soldier life support systems, you can broadly categorized into 4 areas. One is materials for protective gear and mobility. So you need lightweight and durable fabrics, and then composite also, advanced filtration materials and smart textiles. And there are materials for environmental control and temperature regulation, that is thermo-adaptive material. For example, if a soldier is wearing, one suit is there, if the soldier is going to the desert, or the soldier is going to the high altitude, that material itself should change its characteristics to provide either warm or comfortness to the soldier. That's called thermo-adaptive materials. And also high efficiency insulation, because the soldiers who are posted at high altitude, that is -40, they have their own problem of very low survival at very low temperature. So we have to provide a good efficient insulation. Then the next category may be the material for life support and health monitoring, like advanced polymers. Advanced polymers which are used for protection also, and polymer, then fabric, filament to fabric, and also there may be some polymers, biopolymers, which can be used if a soldier is like wounded or bullet injury is there. Fast blood clotting materials are mostly the biocompatible polymers, because other materials will develop some problem. So the biopolymers are advantageous. Porous materials, yes, we need porous material like materials and membrane, like carbon, activated carbon, we have to remove some toxic agents, and membranes we have to remove oxygen or we have to remove nitrogen wherever required. Then biomedical sensors I explained earlier. And the next category may be the materials for chem-bio threat mitigation. This I already told, but broadly we can tell that materials for sensor, that is for detection, the sensors like sensor platforms may be electrochemical sensors or fiber optic sensor, or the sensor may itself may be lateral flow sensors. So they will be used for the detection purpose. So once you detect, you also need a protection, like fabric you need, rubber and adsorbent you need, which will give a protection. So for example, okay, if the chemical is falling onto your fabrics, then what happens? You should have a fabric which should decontaminate. There comes the work of metal organic frameworks. Then somebody was talking about here the metal organic frameworks. So the chemical comes here, and when it interact with the particular metal ion, it will be converted into a non-toxic byproducts. And medical measures, this is not taken by a devil, we are only giving the soldier health. So this can be many more. I only listed out for the life support system. I have not listed about the stealth materials, radar material, electronics materials here. So let us go to the next slide. So I will, from here onwards, I will tell what kind of materials are present, what are the improvement we can see, and how academia can come, and somebody was asking how academia can come to DRDO. I'll just give some clues we can pick up, and then you can just propose to DRDO. If the interests are matching, definitely DRDO will support the institution. So let's start from the life support system for high altitude. I told that O-box, which is producing oxygen from the engine bleed air. Engine bleed air is cooled and it is given to the O-box system. And in a O-box, the heart of the system is the zeolite. The zeolite will remove the nitrogen, only oxygen will be given, and the nitrogen will be thrown out. The second one, you want, next slide, I'll come. Oh, acha, O-box means on-board oxygen generation system, because this is an oxygen generation system which is on board, which is in the flight. So, and it is taking the air, engine bleed air. How much time I have? I'm going slow, I think. 15 minutes I can. Okay, no, I'll finish. No, I'll go fast. So we have O-box, we have oxygen sensor. So at present, the O-box is working like pressure, vacuum, swing adsorption system. There are two beds are there. So when one bed is removing nitrogen and allowing oxygen, the other bed will get regenerated, and the oxygen will be sent to the tank, and that from the tank it can be given whenever you want, or it can give online also oxygen to the pilot. So now the functional part of this bed is the zeolite. The zeolite is particularly the phagosite structure of zeolite, which is at present what is used is lithium exchanged low silica X-type zeolite. X-type zeolite, low silica means the silicon and aluminum concept. You know, everybody knows that zeolite is the sodium aluminum silicate. Here the silicon aluminum, the atomic ratio should be 1:1. So in this structure we have, for example, we have the framework, we have the, when we, initially it will be sodium. Now you have to exchange with lithium. When you exchange with the lithium, you have a frame, in the framework structure, there is a lithium framework also will be going into various various part of this zeolite. So we have an inside diameter of the zeolite is about 13 Armstrong, and there are some smaller cage structure you can see that is about 7 Armstrong. Totally about 96 lithium ion we can exchange with the sodium per unit cell of the zeolite. Now there is the oxygen and the nitrogen has to separate. What are the basic property which through which these are being separated? One is nitrogen. The quadruple moment is, if you compare the nitrogen quadruple moment, it is 4 times of the oxygen quadruple moment. So the polarizability of the nitrogen by this lithium ion is also is more. So what happens, when you are passing air with nitrogen and oxygen, nitrogen is absorbed and oxygen is given out to the downstream, that is the other end. Now there is a problem. You can see there is an argon. So in air there are 4 to 5% argon is present. So even if you use a very good lithium exchanged zeolite, still in an outlet air you will have about 4 to 5% argon, that is about 95% oxygen only. But in many cases you need more than 99% of oxygen. So this is one of the problematic area. At above 50,000 feet you have to give complete 100% of oxygen. At present, if you look at the requirement of India per year, it will be about 2,500 metric ton, because these zeolites are used in various places, not only in defense. So how to tackle this problem? Now there are a lot of researches are being published. So one particular research which was published in 2024 is that when you exchange some of the lithium, if you remove and incorporate silver, you can enhance the production of oxygen by 3.2%. In the same case, if you are you are exchanging the lithium with the cerium, and you should not completely remove, because you can see that only when there is 30% silver ion only you are getting the maximum performance. So if you exchange in a similar way, if you exchange with cerium 30%, then you can get about 27.4%. This is about 30% more than what you can get when you only use lithium low silica X type zeolite. So in a nutshell, you can see that cerium exchange lithium low silica X type zeolite is performing the best. But so in this direction, we are giving the project to the academia. If any of the professors are sitting, they can take a note of it. And the requirement is the development of the heteroatom exchange lithium, not only silver or cerium, it may be any other metal ion also. The whole objective is it has to generate more than 99% of oxygen at the operational conditions. So here the critical technology, already I told, the lithium ion exchange, as well as these powders has to be pelletized. And during the pelletization, we'll be using some kind of binders. These binders should not obstruct the cage structure, and they should not restrict the production of oxygen through that process. Yeah, so we talked about the oxygen production. Now we have to measure the oxygen concentration which is being produced and also which is being given to the pilot. Now we have sensors. The sensors is based, the sensor means it has to measure at different altitudes how much oxygen is going to be produced. So the sensor materials are mostly yttria stabilized zirconia, and the yttria stabilized zirconia pellet, both the side there will be a platinum electrodes. One side there will be air, you know that it is having 20% of oxygen. So it will, so this will be given from one side, the other side will be the test gas. Now there will be an oxygen concentration difference between across these layers. Now based on the oxygen difference in oxygen concentration, there will be oxide ion diffusion will happen through the yttria stabilized zirconia lattice structure. Now that potential, so here some potential will be generated. That's a standard potential because we are having air. Here there will be a potential difference generated based on the gas that this side is experiencing. That will be definitely from the oxygen, onboard oxygen generation system. So this EMF, potential difference, will be measured, and there will be an electronics which will convert the potential difference into the oxygen concentration. Now these are the material properties, and moreover that the sensors will have some platinum paste, and in some other kind of sensors there will be some platinum incorporated with silica, that is called screen printed fritted platinum paste. This is required for platinum heater. So these are the material technologies which are involved, and we will be looking from the academia. The next one is, I talked about the oxygen, the importance of oxygen. I will talk about the importance of nitrogen. Why nitrogen is required at all? So you know that in flights or in commercial flights or in military aircraft, you have a fuel tank. So in a fuel tank, fuel will be there. When the level of the fuel is getting reduced, what will happen? This area is called ullage space. This ullage space will have because of the partial pressure of the fuel, there will be fuel will be there. And if there is an oxygen plus fuel, and if there is a spark, definitely it is going to blast. Such a thing has already happened. You can go through one of the report, fire in the sky, TWA 800. It happened in US with the Boeing 747-100 flight. So the report is available with the NASA. It is openly available. You can if you go through it, there is a reason for the blast. This is an actual picture which was captured when the flight was burned, I mean, when it was that accident happened, you can, finally what happened is, what happened was, the flight was landed for about 2.5 hours and in the ground, in a hot area. By the time the vapor pressure in this area has increased, when he was flying, to know the level of the fuel, there is a sensor is there. There is a sensor in the tank that will tell what is the level of the fuel. The sensor has short circuited. So when the sensor has short circuited, there was a blast. Now, how can you avoid it? So what was the measures which were taken is, instead of, we don't allow oxygen to enter. So what you have to give? You have to give some inert gas. In the air, what kind of gas, inert gas we can give is, of course, nitrogen. Nitrogen is available. So there are some hollow fiber based module were installed in the aircrafts, and the nitrogen is continuously generated, and nitrogen is given here. So the oxygen is driven out, and it is always enriched with the nitrogen. So the limiting oxygen concentration as per the new rules, it is in the commercial aircraft it is about 12%, in the military aircraft it is 9%. Okay, so nitrogen we have to generate. It means nitrogen we have to generate. How can we generate? This can be generated by the hollow fiber membrane. Hollow fiber membrane is nothing but a fiber which is made of some kind of polymers. These polymers are bundled into a structure, and when the air is sent, only nitrogen has to be produced, and all other gases like oxygen definitely has to come out, carbon dioxide may be there, and also moisture may also be there, so they should come out. If you say the cross section of the hollow fiber membrane, you can find out in the membrane there are a lot of porous structure, and the thickness of this hollow fiber is about 30 micron, and the hole is about 120 micron. So when the air is going inside, the oxygen and carbon dioxide and water molecule, they will be attracted, and they will be they will cross through the separation membrane. So this act as a gas separation membrane. Only nitrogen will go and it will come outside. So these are the potential polymers, and they are like polyimide, copolyimide. Why there has to be polyimide? First of all, they have to withstand sometimes to the higher temperature, and they should have a high glass transition temperature, and also in their structure, the polymeric structure should be in such a way that there should be lot of spaces. They are called the molecular, whenever there is a polymer folding is there will be some spaces will be created, porous structure will be created that should allow the gases to pass through, and also it should be specific to those gases which we don't want. So here the oxygen is having a kinetic diameter of about 3.46, and its electronegativity is about 3.5, which is more than the nitrogen. So oxygen will be definitely attracted towards this polar group, and it will be separated. Nitrogen will be an inert gas. It will not experience any kind of chemical attraction towards this, ionic attraction towards this area. So these are the requirements. I will just skip. Not only that, see, whenever we define some materials, the material should function at the required. It's not like that in the lab we have generated and we got some 100% of nitrogen also, but this kind of fibers has to withstand about 6 to 11 bar pressure, and also flow rate should be 50 lpm. These are all the challenges. So lot of material technological challenges are going on. We are also working on it, and we are also collaborating with the academia. And these are the different, since I told that the soldier will be at a different atmosphere, either cold or hot. At present we are giving for a hot condition we are giving a microclimatic cooling systems. The cooling liquid will be passed through the jacket, and he will feel comfort. And if he is very in the low temperature, we have electrically heated jackets and trousers. So traditionally we have the microclimate. So these are all microclimate material because they are very intact to our body. So, and also giving some microclimatic the comfortness. So initially there were some natural fibers which gave us protection. Then came thermal wear, which doesn't allow our body heat to go outside, and even in the winter season we are able to face the heatness. So can we have a material insulation on demand? That means when there is a change in atmosphere outside, if it is cold or hot, it should change its properties, like latent heat storage, phase change materials can be incorporated, or some chemical reaction can happen, which can either take up the heat, or which can either given up the temperature. Okay. So this is the submarine escape suit. So at a different depth, what is happening, I already told. Below 150, even helium is not going to help. So in this case, there are some recent research that we breathe oxygen at this area. So even liquids can be breathed. So liquid breathing system. At high pressure, at the depth I told that at 100 meter you will experience some 100 bar. The pressure will be enough for the oxygens or gases to diffuse through our body. So if there is a liquid, we are able to give a liquid to our liver, and through the liquid, if gases will be exchanged, so that is going to give a better option for the survival. So chlorofluorocarbons are already reported. There are some initial medical research also happened. Russians and US have they have also started their work in this direction. I'll just skip it. Okay. Now I explained in my slides that we have a lot of clothing, lot of materials, but unfortunately all the fibers are imported. We don't have our own Indian made aramid fibers. So who is going to make? That's still a question. So aramids means meta-aramid or polymer, para-aramid. Other than the aramids, carbons, high molecular weight polyethylene, high strength polyester, nylon 6,6, the polyether ether ketone, polyethyl acetyl ketone, we don't have any fiber manufacturing capacity in India. So we are also working towards that. Now, okay, carbon dioxide. How much time more so that I can skip? Okay. So I will just skip these things. Okay, so how can we collaborate with DRDO? We have got research boards, 4 research boards, 15 center of excellence. We can have also cars. Cars projects are like the lab will place the order on the educational institutes. There are some technology development funds are also there. For professional services. So there are 4 research boards are there. 5 research boards are there. Our life science research, when DEBL is having a life science research board, there are the TRL is nothing but technology reliability level. So 0 to 3, and we have listed a lot of collaborative area like biomechatronics, brain-computer interface, biomedical materials, blood substitutes, regenerative engineering. So there are 15 center of excellence were established all over the country. You can go through this website like Advanced Technology Center, where all the 15 centers will have what are the research verticals, everything is listed. Here the main criteria is that project outcome should have a clear and direct applicability to the ongoing planned DRDO projects, and focus should be on research driven, not for the infrastructure development. And the project should not excessively equipment intensive. It should be product intensive. So just I went through the verticals. At least 91 of the verticals are related to the materials. Okay, so the concept proposal may be sent to any of the centers and it will go to the particular lab. If the concept proposal is matching with the lab requirement, the lab scientist will take care to the next level. Okay, there are technology development funds. Some industries may have enough capability to have a technology readiness level of 3 to 7. They can also invest, and the industry, the DRDO will give 90% of the project cost to the industry, and they can come up with a product which is directly relevant to DRDO. And we have a cars. These are mostly project specific, and there are some mechanism to get a cars project through to DRDO. And there are some, as I told, there are some Dare to Dream projects are also DRDO is encouraging. This is open to the innovators, entrepreneurs, individuals above 18 years, and startups. And selection criteria is the competency of the project and scientific soundness, design completeness, merit of the project, and the technology reliable, whether it is technology readiness level is there or not in this innovation. So with this I will thank you. Thank you very much.
Thank you, Dr. Selvakumar, for technology related discussions on what's happening in the DRDO lab and what kind of expectations from the DRDO various laboratories across the country, what others can think about writing the proposals. All the topics were nicely covered. So due to want of time, I am sorry that we avoid the discussions and questions. He can answer to any questions. Since I was his supervisor, I know his knowledge in chemistry or materials chemistry. The other session from foreign examiner online about to start now. Sorry again, no interactions. If at all you want to interact, Dr. Selvakumar is available from till 6 p.m. today in the campus. Of course, myself and Dr. Kadirvelu are leaving. He is available. You can very well talk to him. He is a very nice gentleman to clear any of your doubts related to materials chemistry as well as polymers. Okay. Thank you, Dr. Selvakumar.
Thank you, sir. I would like now request to Dr. K. Premalata, Assistant Professor, to honor the chief guest.
at IIT Indore. Professor Neri is an eminent figure in the global research community. He is the member of steering committee of the Italy Association of Sensor and Microsystem, has served as an associate editor-in-chief of Chemosensor and an editorial board member of Sensors. With over 435 publications and more than 21,500 citations and an H index of 75, Professor Neri's contribution have shaped the direction of the modern sensor technologies. His work earned prestigious recognition, including the Samson Sate Global Research Outreach Award for his pioneer project on smart sensor for breath analysis. We are truly honored to have him with us today. Please join me in welcoming Professor Giovanni Neri.
Okay. Thanks very much for your presentation. Good afternoon to all professors, students, and all the participants to this conference. I am first to thank Professor Prakash and all organizers for this invitation. Now I will share my presentation. Just one moment. Okay. Just my title for today's presentation is New Advancement in Nanomaterials for Gas Sensing. Before to start with this presentation, let me to present briefly myself. I am a professor of chemistry in the engineering department of the University of Messina. Messina is located in the south Italy, in very beautiful place. Just you can see here some aerial view of Messina is surrounded by Tyrrhenian Sea, and there are just some picture from the Messina city in the center. And around Messina there are also very beautiful place to visit. Eventually, we have the possibility to visit just Italy, in particular Sicily and Messina. You can have to visit a very beautiful place. Okay. Now, starting with University of Messina. University of Messina is just one of the oldest university in Italy and also in Europe, because it was founded about 5 centuries ago. You can see just some location of the University of Messina, the historical building of the Faculty of the Law, the rectorate, and the Faculty of Engineering. Faculty of Engineering is in the prospect of the Messina Strait, and is a new building in our university. Okay. Just a brief presentation about my academic and research activity. Especially in the last 25 years, I focused my part of the activity on the gas sensor and sensing in general, starting with the synthesis of the sensing materials, also because I am a chemist, and then this aspect is relevant in my research activity. Of course, when you prepare materials, it is important to have characterization of these materials by different characterization techniques, but main of my activity is just related to the sense of development for practical application. Among my different activity, I collaborated many times with Indian university academic. In particular, I was invited the professor and have a strong collaboration with University of Alagappa, Professor Sekar, and also was just a brief period in Indian Institute of Technology, Indore. Okay, now just I will present you briefly my laboratory. Okay, I am the head of gas sensor lab. Just historically was this, but now this sensor has also included many other different typology of a sensor, like electrochemical sensor, QCM sensor, capacitive sensor, and so on. But in this presentation, I focused my presentation on gas sensor. This is just some facility in my lab related to sensor preparation, characterization. This is just one experimental test for the characterization and validation of the gas sensor. Of course, material sensing and characterization for these sensors, and also one lab with my colleague Nicola Donato, Professor Donato, for the prototyping and setup of sensors. You can see here just also the deposition facility for gas sensor fabrication. This is aspect is very important, and in the following discussion we have some strong related to this particular preparation of gas sensor. Now, in general, introduction to sensors. Okay, when you have to start with to speak about the sensor, it is important to repeat some question about the sensor. What are the sensors? Okay, of course. How the sensor work? Just this is one important aspect, and this is related strongly to the different typology of the sensor we have. Okay, the description of the sensor, the needs for sensor, because this is important in order to have the application of a sensor for the desired application. Okay, just the first question. What is a sensor? Okay, when you have to speak about the sensor, it's important to define very well what is the measurement objective. In this case, it's possible to have a sensor for measure many different parameters, for example, physical, chemical, or biological. And the sensor is the device converting just these quantifiable properties in just one readable signal. For example, an electrical signal or other different signal. Having made this, okay, just we can have just the two different typology, the main different typology of a sensor. One of these is the physical sensor, of course, where the device, in this case, give information about a physical property of the system. Some example of this physical sensor, there are temperature or pressure sensors, for example. On the other hand, we have a chemical sensor, okay? Chemical sensor, of course, is related to the chemical typology and give information about concentration of specific component and just give the analytical signal related to this. For example, the sensor related to CO in the atmosphere, or one glucose sensor, a typical sensor related to chemical sensors. Okay, Of course, the application of a sensor are very, very large, and I want to show you this picture where main sensor are here shown. We have different topology based on different also mechanism of transduction, and in particular in this common lecture, I want to specify about gas sensors. You can see just the very simple composition, arrangement, geometry, size of this sensor. This is important because as a definition, once the sensor, there are very small device. Okay, now focus our attention on gas and sensor and give here just one overview of this device. The device related to gas sensor are simple device, integrate a sensing element with a transducer. In this case, having this configuration, it's possible to produce one electrical signal which is proportional to gas concentration. This is very, very important. Then this very simple device, okay, is able to have many important information about the gas which surrounding the sensors, okay? And then the active layer is the key of the sensor. This is important then to have a very beautiful characterization in order to obtain a practical sensor for our desiderated scope. Now, we can see just the advantage of the sensor. Why, in fact, is necessary to have gas sensors? Because on the right we can see just the analytical techniques used conventionally. Okay, we have many of these techniques. Okay, they are very precise and also accurate, but there are just some disadvantages, especially for in-field analysis. Is for these techniques, they are time consuming. They are very expensive in this aspect, and is necessary expert personnel to perform the analysis. On the other hand, the gas sensor, they are very simple, they are very low cost. It's possible to have for this max production, okay? And there are also many very small device. In this case, it's possible to have response in field also fast. And at last, they are user-friendly. In this case, okay, there are just for many decades studied different gas sensor based on different transduction principles. We have mass sensitivity sensor, also called QCM sensors. We have calorimetric sensors. We have optical sensor, electrochemical sensor, and capacitive sensor. We have here just the objective of this presentation. The so-called resistive sensors, based in your case on different sensing material. This is about metal oxide. Now, I will show you better how is made one resistive gas sensors. Generally, it is important to have for this typology of the sensor to have one insulating substrate where is printed one interdigitate electrodes. Above the interdigitate electrodes, there is the sensitive layer, And in case of metal oxide, some people use different metal oxide having sensing properties for some gases. But there are also different sensing layer based on non-metal oxide, such as conducting polymers, carbon nanotubes, graphene, etc. Okay, but why is the resistive gas sensor among the best in case of gas sensing? It's important, for example, to see here what is the the sensitivity and the load of these sensors. Load indicate the lowest quantity of gases, in this case, a concentration which will be detected. In fact, most typology gas sensor have very, very large calibration curve starting from 1% or more and arriving up to 1 ppt. Then it's possible to have this very, very low concentration detect of gas in one mixture only by this typology of gas sensor. Other advantages and disadvantages for the gas sensor, especially in comparison to electrochemical and optical, are shown in this table. The most important characteristic for one gas sensor are listed here. There are cost, lifetime, sensitivity, selectivity, response time, and size. You can see like just our chemoresistive sensor display many advantages with respect to other. In fact, there are have a low cost, long lifetime, high sensitivity, fast response time, and small size. But they have just one disadvantage. It's necessary to have to be very accurate when use just chemoresistive sensor, especially in complex gas mixture. Okay, having in mind this, okay, now I will show you just some typology of gas sensor. The geometry, the size, there are completely different, starting from on the top, the first gas sensors patented, the Wuji chemoresistive gas sensor. We can have just some planar resistive sensor. It's possible to obtain a flexible gas sensor on plastic and so on. Also, just integrated with the silicon technology for more reliable data. Also, in order to include the transmission of data and so on. Okay, now this is important when working with gas sensor to know very well to adapt what is the parameters for one gas sensor. Okay, just they are listed here. We have in any case shown before, and here a beautifully representation of this showing starting with the response. What's the response was when gas sensor? Okay, the gas response is related to the response when the sensor is surrounded by the gas with respect when is surrounded by one reference. Generally, the reference, practical reference is air. It's possible to see just we have a quickly response increases in the resistance with respect to the baseline. Okay, in this case, quantitatively, it's possible to define the response as the ratio between the resistance in air or in gas, or vice versa in gases versus air, because depending on the sensing material, depending on the gases, it's possible to obtain one increase of resistance, like just show for the sprayed tin dioxide film versus NO2 gas, or one decrease. In this case, to define the ratio, give the opportunity to have just value that are positive, starting from 1 to higher value ratio. This is, in any case, the response. It's possible also to indicate the response as the response we have at one particular concentration. And then when we have to indicate the response of one of a gas sensor, is necessary to indicate what is the concentration for this measurement. It's possible, okay, in general, to obtain one calibration curves. And in this case, we can obtain the sensitivity. The sensitivity is the slope of the responses versus target concentration. In this case, we can see very well linear between the response and the target gases. In many cases, we have a Langmuir 2 configuration, starting with the one saturation of the signal at a higher gases concentration. In any case, just this sensitivity, of course, depend on the sensing material, the sensitive layer, and the gases nature. In many cases, we have a very, very large sensitivity. In other cases, it's possible. But there are many strategies in order to obtain larger sensitivity with this gas sensor. Okay, most important is the cross sensitivity. We have just speak about many cases of the poor selectivity of these materials. And then it's necessary, okay, when you have to design a new sensor, okay, to measure the cross sensitivity of devices having many different interferent gases with respect to the target gases. In this case, we have just some indication about different gases in air. We have NO2, CO, acetone, ammonia, and so on, with respect to the target gas, in this case, which is ethanol. You can see the very low response of the other gases, and response to ethanol, in any case, is very high for this. In this case, we have a good cross-sensitivity with respect to ethanol. If we have not good selectivity with just one sensor, it's possible to use more sensor, meaning the nose or human nose. In this case, this device is also called electronic nose, and it's possible the different signal coming from the different sensor, okay, mathematically just interpreted and used. It's possible, okay, to classify the different gases in just one mixture. After that, response and recovery time, there are also many important, because especially when it is necessary to have a very fast response or recovery time, just in order to increase the frequency of measurement. When it is necessary to have a very fast response for especially particular application. For example, sensor lambda is one oxygen sensor, is necessary to to acquire just at 5 hertz frequency, and this it means the response of the one lambda sensor is around 200 milliseconds. Okay. At last, we have the stability, of course, of the sensors. Okay, this depends on many parameters. For example, the stability of the sensing layer. This stability is it's possible to be influenced by the surrounding gas mixture. There are just some poisoning interference and other. In this case, you can see the different response from 5 to 40 ppm of carbon monoxide for very long time, and the sensor replicate any time the same response. Okay, and then in this case, the stability is very, very good. Okay, after having just this in mind of the parameter of the sensor, this paragraph I want to show you what is the sensor history, starting from the first experiment to obtain very, very good sense. Just in the first 1905 period, it's possible to individuate that certain metal oxide give some change when exposed to air condition, okay? But it was necessary to reach the 1962 year in order to have the first paper describing one gas sensor. These gas sensors was okay one semiconductor gas sensor because used zinc oxide. Professor Seyama, Japanese scientist, described the gas sensor for the detection of one hydrocarbon, okay, and just show this very, very good new device. Compared to that time device, for example, thermal conductivity sensor or method, the sensor indicated by Professor Steyama was very, very sensitive with respect to the other, but it have just some problem. The problem was, of course, the fact the temperature needs for the actuating of this sensor was very, very high, near to 500 degrees. In this case, the sensor was with a not very long lifetime, of course. In the next year, okay, there are just some advancement in this case. The first patent arrived in the 1962 from by Professor Taguchi, which have a very simple device for the gas sensor, having tin dioxide and zinc oxide as the sensing materials. Improvement are related, of course, to the chemistry of the sensing layer. It was possible to include additive, it's like palladium, it is possible to increase the surface area, having just different calcination temperature in the presence of some organic component, and so on. In this case, just Taguchi obtained the first practical sensors, also called Taguchi type sensors, gas sensor. Where in the 1968, here, and it's possible to use, especially in the USA, to use this very simple sensor for flammable explosive gas detectors in home. Of course, there are just some problems related to the interference with some other gases present in our home. And then false alarm, there are very, very frequent. But what's possible to improve this, and Takuji founded the first gas sensor company in 1969, okay, also is still present on the market, this in just the figure of sensors. Okay, but is not only you have metal oxide. In the 1983, just arrived the first gas sensor based on conducting polymers. Just you know, the polymers are not conducting. When it's possible to dope this polymer, like polyphenol, for example, possible to obtain conducting polymer. In this case, it's possible to use these conducting polymers for chemical sensors, especially gas sensors. Just that shown his is first, the first report for one gas sensor based on conducting polymers. In 1991, just was one very precise point for the gas sensor, because Professor Yamazo individuated that you have the sensing layer in the nanometric form, having a nanometric particle form. It's possible to increase very strongly the response, okay? Because for a particular reason, just a very small particle have just different electronic control with respect to the larger particles, okay? And this increase the sensitivity. At just this period, okay, were now included some carbon nanophone. Just one of these, okay, was the carbon nanotubes, okay, and were used by Professor Day in the gas sensing. The particularity of carbon nanotubes was, of course, the high surface volume ratio. There are also many conductive that are possible to obtain mechanical stability, and also with respect to common carbon, also thermal stability. And recently we can have just different particular typology of dimensional structure, like nanowires, nanobed, and so on in this case. And at last we have the graphene, like just one bidimensional carbon structure. Okay. Now, having just this panoramic view about the materials for gas sensors, we dedicate our attention on the first material used for this. Metal oxide. Metal oxide generally are semiconductor, okay? And in this case, just tin oxide was one of the most used for gas sensing. In the oxide, just show any type of conductivity due to the stoichiometric defects, general oxygen vacancies, and then is one of the best to be used like pristine or modified sensing materials for the gas sensor. Just here, okay, it is important to give some indication about the gas mechanism in this case. This is the functioning, of course, of the sensor. If you imagine to have only just the two grain of tin dioxide, zinc oxide, or similar metal oxide, okay, we know just that in air there's particles are covered by oxygen surrounding just these particles. Also, we know just the oxygen adsorbed on the surface of these particles withdrawn electron from the bulk. Okay, when we have just large particles, okay, in this case we have created on the surface of the grain just one depletion layer. This depletion layer create one Scotty barrier, okay, and this determine the baseline resistance in air, the baseline resistance in air, okay? In case we have just down part, case just some reducing oxidizing gases on the other, which can interact with oxygen, there are just this reaction with the oxygen. In this case, the oxygen leading one electron that are very, very reactive. This lead to the reaction, in this case, CO with oxygen lead to CO2, and electron come back in the bulk. In this case, okay, we observe one decrease of the resistance because increase the number of the electron in the bulk, and of consequently the barrier rate decrease, and we can see here the classical response of the sensor. You can see here at lower concentration we have one decrease of the resistance, and when you come back in air, this reach the baseline. If you have another time just including in the gases also the new CO at higher concentration, the decrease of the resistance is larger. In this case, it's possible to have one simple materials, okay, that have a different resistance in different gases concentration, target concentration, in this case for sure. The same, we can extend this mechanism for different metal oxide, for different gases to be detected. This is the general mechanism, very simple to interpret. Now, it's possible to change the sensitivity of one materials, in this case, MOS, metal oxide semiconductor gas sensor. Yes, of course. It depends many strongly from one aspect related to the particle size. When you use thermal treatments in order to change the grain size of these materials, sensing materials, it's possible to see when you have to move from larger particle size to lower particle size, it's possible to increase very strongly the sensitivity. This effect is related, like before discussed, to the electronic of the or particles, because when the particles that are very small, especially smaller with respect to the bylight, just these particles do not contain more electrons. There are with large, and sorry, just one. Okay, and we have the different grand size. Okay, when the grand size are very large, it's not possible to withdraw almost all electrons. This is related only on the surface. This aspect is very well presented just in one graph showing the resistance versus the crystalline size. This variation is related especially at very low crystal size, below 5 nanometer. In this case, also as before discussed from the Professor Yamazo investigation, we can see here at this very low nanometer, it's possible to increase okay. Now, just I go very fastly in order to give you a representation. There are just some other parameters to metal doping. We used just this in order to include the presence of additive and to increase very strongly the response to, in this case, to hydrogen. Okay, now some indication about the new nanomaterials and devices at the sensor lab. This is very quickly our sensor device is very small. The dimension there are 2, 4, 6 millimeter. It's possible to include just holder and have the final sensor device and to test directly in the chamber test for the validation of our sensor. In this case, it's possible to having the right sensor to produce sensor for practical application, and in the case, just one very simple sensor for automotive application, having one Britain Atoll tester. Okay. Important now is the search for new nanomaterials, of course. When you have a new nanomaterials, it's possible to design the new sensor with higher performance with respect to the previous. In our case, we have just dedicated our research to the nanomaterials based on core shell heterostructure, having just some different sensor covered by very thin layer of other metal oxide. We have here, in this case, used atomic layer deposition. You know, of course, atomic layer deposition is very good in order to use for performing and depositing few layer of sensing layer materials. In this case, you can see effectively the deposited metal oxide on the carbon nanotubes, and inside the carbon nanotubes. It's possible to have very conformal thin film of 2 nanometer or 10 nanometer. Why this aspect is important? This is important because it's possible to relate the sensor response directly to the metal oxide thickness. In this case, it's at just the double length of the titanium dioxide, we have the maximum of the response. And in effect, it's very simple to design sensor in this way. We have just also investigate the carbon quantum dots, okay, because they exhibit very high surface, and then for gas sensing application there are very interesting. Also, another aspect important for carbon dots is the fact they have different typology of composition, because they can we obtained from different sources. In this case, there are obtained by olive oil, okay? And it's possible to tune just from different region, different ways, and have a different typology of sensor. In this case, it's possible to discriminate just the response to NO2 or to NO based on the different carbon dots we have used. Okay, and this is important because NO2 and NO sensor are based sensor for automotive application, metal organic framework, also in this case with Professor Sekar at Karayiduki University. We used just this in order to prepare just one single sensors which operating at different temperature is possible to tune the selectivity towards acetone or NO2. Then we have only one sensors. The change of color of the sensing layer, the different temperature is well evident, and also it's possible to see the different response of the sensor when, okay, just additioned with the two gases. Okay, automotive application for CO sensors, environmental application also in this case, biomedical application. There are all just important target for these sensors. Just I conclude here my presentation with a recent case study. We have one objective in this case, to identify the composition of malodors in landfills. Generally, in landfills, there are the development of many gases, such ammonia, CO2, H2S, methane, and also, but especially there are ammonia and H2S. This is important because there are dangerous, but also there are very, very strong malodors in this case. And then people living around these landfills just suffers of this aspect. With the conventional analytical techniques, it's possible, but they are very expensive. It's necessary to have this in not in real time, for a long time, just for any landfills in different position, the landfills and around the territory of these landfills. Having a sensor for these gases is very simple because is the limitation, economic limitation are not a limitation. Then we designed one particular sensors, okay, starting with the sensing materials development based on nanostructural metal oxide additive and prepared in one particular way. This materials is very sensitive to H2S and also to ammonia when you have to prepare in different way. And then in fact we have under evaluation these materials and the sensors. You move it from the sensor to the device, just very small chamber, in this case, having the sensor in a very few milliliter or less chamber, having the possibility by a micropump to extract the signal coming from the external. And just this is one demo cup of our and prototype of our sensor. Then also the designated software for this in collaboration with one local enterprise, BioAge Advanced Electronics. Here you can see just this validation, but in our validation validation test chamber and in using just this very, very small portable device validation. I have concluded that this scientific part, but for me, knowledge and of course of my sensor groups here, and thank you for your attention. I hope to be in time. Thank you. Okay. Okay.
Participants, if you have any questions, you can ask now. Any questions?
Sorry, I have some problem to hear you, please.
Good evening, Professor. Can you hear me? I think so there is an issue.
Sorry, I have some problem with your microphone. I do not understand well.
Good evening, Professor. Hel- Good evening, Professor. Am I audible?
Hello? Yeah, but no, I do not understand. Ma non si sente. No, sta sentendo. Uso quello. Okay. Sorry, I change computer. Oh. I open now. Okay. Okay. Okay, please. Just some question for me.
Hello?
Okay, please. Just I do not see. Just any question for me. I do not hear.
Hello?
Ok, possiamo sentire una cosa per dire che poi magari... Ok, ok. Dove? Ok.
Hello, Professor. Can you hear me? Am I audible?
Okay. Okay. Non so se vediamo se la aspetta, dammi un flash. Hello. Hello, Professor. Am I audible now? Prakash. Non sente niente, non so se è il mio, se è il loro. Io dovrebbe ora sì. Allora togliamo. Bene. Togliamolo questo così vediamo se mi torna. Ok. Yeah. Now it's okay. There's no problem. Okay. Okay, thank you. You can continue eventually. Send me just the okay. Vieni? No. Perché non capisco perché. No, sto scrivendo, dai. C'è problema. You can see my reply. Okay. Okay. You can see just my reply now. Okay. Please, eventually, we have just some other question. Please write here. In this case, it's possible for me to see your question. Okay. Okay, just I am sorry for this problem, but I wanted to thank again Professor Prakash, all the organizer for this. Okay, and wish to you very success in this conference. Okay, tomorrow will be just some other my collaborators in just in this conference as speakers, and See you tomorrow. Bye bye.
Thank you, sir.
I can close.
Yes, sir. Thank you so much, sir.
Oh, okay. Bye bye.
I now invite Sindhu Kavi S from KPR IIT Coimbatore to present her topic. I now hand over the session to Dr. D. Selvakumar, sir.
Only speakers are available. Huh? Yeah, please come. I mean, I don't know your biodata, but anyway, I welcome you for presenting. Please come.
PhD scholar,
India.
doing PhD
Okay.
in KPR.
KPR.
Yes.
Okay. Good.
Thank you, sir.
Good afternoon, everyone. I am S. Sindhu Kavi, Research Scholar, Department of Physics from KPR Institute of Engineering and Technology. So here I am to present my work on voltammetric detection of gallic acid using carbon ferrite at graphite carbon nitride modified glassy carbon electrode. The main scope of the study is to prevent the adulteration in food. So what is gallic acid? So gallic acid is a naturally occurring phenolic compounds which is present in tea, fruits and tea bags like etc. It is an antioxidant and a therapeutic compound. Uh, there is a limit in the intake of gallic acid when it is high. Okay, high intake causes the oxidative stress, which results in the health risk. So it is important to monitor the food quality to prevent the adulteration. So electrochemical sensing results in the high sensitivity. It even traces the trace level presence of gallic acid in the food compounds. So here I have used copper ferrite and GCN and used the synergistic effect to sense the gallic acid. So why copper ferrite? It is an advantageous material with remarkable structural and electrical properties. Copper ferrite has an inverse spinel structure that exhibits good electrical conductivity, thermal properties, electrochemical stability and catalytic activity for sensing applications. So, and it is also a cost-effective material as copper and ferrite are like very much abundant in our nature. Next is graphitic carbon nitrate. Graphitic carbon nitrate is a 2D semiconducting polymeric nanosheet, and it is very easy to synthesis. You have to take just the nitrogen-rich sources such as urea and melamine and thermal polymerize it, and finally we can get graphitic carbon nitrate, which is a 2D nanosheet. So this nanosheet and inverse spinal structure of copper ferrite together creates a synergistic effect, and which increases the electrical conductivity and surface area, which promotes the good electron transport, and which results in the increased sensitivity of our sensor. So this is the synthesis route. I have synthesized copper ferrite using reflex synthesis method, and graphitic carbon nitrate by thermal polymerization of urea, and I have got the graphitic carbon nanosheets. So next I have studied the physicochemical properties of copper ferrite and graphitic carbon nitrate. So this is the graphical abstract of the work I have did. I have used a 3 electrode system to sense the gallic acid presence in the real samples such as green tea and black tea. So structural analysis, which is XRD. Here we can see the peak 202, the plane 202 at 27 represents the presence of graphitic carbon nitrate, and the peaks obtained for copper ferrite finally aligns with this JCPDS, which gives the inverse spinal peaks, inverse spinal structure. So this is the XRD of the nanocomposite. Here we can clearly see the occurrence of the 002 plane, which is the graphitic carbon nitrate. So this XRD shows the successful nanocomposite formation at the nanoscale level. So this is the morphological analysis SEM. This is the copper ferrite I have synthesized, and this is the urea, which I have thermal polymerized under 2D nanosheet graphitic carbon nitrate. Here we can see the fine anchoring of the copper ferrite over the layers of GCN sheet. So this morphological studies confirms the successful composite formation with strong interaction between copper ferrite and GCN. So next I have studied the electrode performance analysis. So here I have performed cyclic voltammetry for 5 different combinations, which is the bare electrode, and I have optimized the ratio of copper ferrite and graphitic carbon nitrate as 1:1, 1:1, 1:2, and 2:1 in 3 ratios. And the resultant I got is the good conductivity for this 1:2 ratio, which we can see in this Enquist plot, where the semicircle is small for this 1:2 combination. So throughout this study, I have used 0.01 molar concentration of gallic acid, and CV studies denotes the electrode performance, and the better performance was shown to this 1:2, which you can see this black color one. And the Enquist based better sensing performance was for this 1:1 combination. So this whole study I have conducted for this 1:2 ratio. So next we have to optimize the sensor because it sensed my gallic acid, but still we have to get the better sensing performance. We have to optimize the buffer solution we are using. Here I have used the phosphate buffer solution, and this red color peak of pH3 clearly indicates that this pH3 in this acidic medium, my electrode is performing a good electrical conductivity. As you can see, like there is a shift left towards the left side, but for this pH3 there is an increased electrode current, and also there is a loading concentration which is 8 microliter. Over my electrode, I have loaded different kind of combinations like 2 microliter, 4 microliter, and 6, 8, and 10. For this series, I have got increased current at 8 microliter optimization. So I have completely optimized my electrode, for which that 1:2 combination in the PBS of acidic medium pH3 of 8 microliter loading, I have carried out the whole I have carried out the whole experiment. So next is the analyte concentration. In this study, I have checked whether my electrode is performing the same even if I increase the concentration. Yeah, like the results were so very good. As I increase the concentration from 50 micromolar to 500 micromolar, still the concentration is linear. There is no shift in the electrical current. And the same lies with the scan rate also. For scan rate, I have fixed concentration of 50 micromolar, and I increased my scan rate from 10 microvolt per second to 190 microvolt per second, and I even increase in the scan rate. So this examines the main aim of the scan rate study is to examine the electrochemical kinetics. So next is the linearity and sensitivity of my electrode. This is differential pulse voltammetry study. I have used various concentration of my gallic acid, which is a very diluted one, and the concentration I have used for the study, and this is the concentrated gallic acid, like raw concentration. Here what I did is, like, I added the minimum, like diluted concentration of gallic acid until it is saturating. Like after saturation of this 0.001 molar, I added like 0.1 mole. Then again after saturation of this, I have added this 0.1 molar concentration. So the linearity of my electrode was up to 1491.6 micromolar. So which is a very good linear sensitivity. So next is the interference study. The main aim of this interference study is to analyze whether the compounds which are similar to the gallic acid, because gallic acid is a phenolic compound, like similar compounds may interfere with my electrode. So in order to study whether there is an interference or not, I have used the materials which is similar to gallic acid, and I studied this. I did the same DPV analysis in which there is no change in the there is no presence of additional peaks, so which results in the no interference, and there is also no reduction of peak current. Like it is around 7.5 to 7 to 7.5, which is which tells that there is no interference of any other material while sensing. So the main thing for electrode is the repeatability, reproducibility and stability. I have repeated the same experiment, which is repeatability, like same experiment like five number of times, and there is only very slightest shift in the current. And same for reproducibility, I have taken like other kind of electrodes just to check the reproducibility of my material. I have taken like other electrodes and did the same experiment, and there is only lightest shift in the current. And stability, like stability is the important parameter for the electrode. Here I have recorded the experiment for 20 days, and you can see like there is only a slightest decrease in the current. Like this also shows that the electrode is having a good stability. Real sample analysis. Actually, the gallic acid is a material which is used to increase the shelf life of the packaged food and everything. So here I have bought, like to increase the shelf life, they will be adding like synthetic gallic acid to our food materials, whatever we are consuming. And it is also like illegal to add the high amount of gallic acid to our packaged food. So I have bought store-bought black tea and green tea, and I was real sample analysis. Real sample analysis were done for this black tea and green tea. The result shows that only the spiked concentration, only after spiking the material is increasing, which results that the material is free from gallic acid. But our result shows that even if it is spiked, if other concentrations are present, our material can sense it effectively. So the highlight of this study, the synergistic effect of copper ferrite and graphite carbon nitrate, so like increase the electrochemical performance of my electrode. electrode sensing, like even in acidic medium, like the linearity, the DPV studies was so good, and microliter optimization was 8 microliter. Even layering of copper ferrite over graphite carbon nitrate increased the surface area of high electrical conductivity. Anodic peak current increase, like that, this is the result of DPV. And the sensor exhibited, even under the acidic medium, it exhibited a good limit of detection, which is 0.38 nanomolar. And the interference study shows that the sensor is having a good selectivity towards gallic acid, and there is no interference. So these are the highlight of my studies. That's it. Thank you.
Yeah, good work, good piece of work.
Thank you, sir.
And you have started from a simple problem and try to solve that in a real world situation.
Yeah.
Any query is there from the audience? No, so just I will ask only
Okay,
some.
sir.
So why you chose the carbon nitride?
Graphite carbon nitride.
Graphite
Like,
carbon.
yeah, it is a 2D material, and it will increase the surface area of, like, it is a nano sheet, right, sir?
You could have taken any other 2D materials. Why graphite carbon nitride? Even graphite itself is.
Yeah.
You should do that.
Okay,
Wherever
sir.
you are telling, no, this area, there is some interaction between. Morphologically, it may mislead also.
Yeah.
You have to fire on that spot and then get the response of
Okay, sir.
element analysis. It will add strength to your justification.
Okay, sir. Like, I have XPS, but I didn't include it.
EDS, XPS is another XPS. So before going to XPS is very costly, you know. So before going to XPS, with the SEM, EDS, you should able to do it. And XRD also. XRD I already shown. Have you calculated the particle size from XRD? You have to do it, because when you have a data, whatever information you can extract. And for all the, I hope that you must have done XRD for all the combinations.
Yes, sir. All the combinations.
So all the XRD you have to present.
Okay, sir.
And then each XRD, what is the particle size? Is there any shift in the peak? Each and every information is very important. Then you can do that. Okay. What is your next? Now you have done it.
Yes.
But have you used any? Because you started some molar values. Have you used any design of experiments kind of software which will predict the amount of the range? If you give a range, that itself will tell what are the parameters you have to apply. Yeah, just to go through, it will be very useful, because many parameters when you vary, like pH, like concentration, they are all interlinked. One will affect others. So manually it's difficult. So there are some softwares available. You can use it. It will be good. Just to read about design of experiments. It will be good for long term. Otherwise, this work is really good. So what is the next? What is next after this?
Sir, next.
With this, what is your future plan? Means
I'm
now
going
you
to
have,
extend this
you have
work.
presented as if you have concluded the work.
Yes, sir.
But I don't think it is concluded there.
Yeah.
So what is the next step? You may
Sir,
have a problem with the
it is
classic
like
carbon
sensing
electrode.
in a nanoseconds. Like LOD, you have seen that it is sensing like around.
What LOD you want? What is the permitted level of gallic acid in food?
Permitted level of gallic, like natural occurrence is around 50 to 100 milligram per ml, I think so, sir.
Have you reached that LOD?
Yes, sir. If
you have reached, then what else you are having? Have you reached that LOD? You have reached the LOD.
Yeah, like I have reached the LOD, but for this real sample analysis, like this is to just to know whether it is adulterated or not.
Okay.
So my sample has not.
Have you spiked the LOD value?
No, no, sir.
You should have done the LOD value, whether your system is going to respond to the LOD.
Okay, sir.
Otherwise, the system itself is questionable, it will become. Okay.
Okay,
there
sir.
are some areas are there below that red color.
Okay.
You can still do that. So you can reach to the LOD and prove that yes, you are getting a current difference, and then it is the LOD, within LOD you are able to measure.
Okay, sir.
Okay. Glassy carbon electrode, how do you clean?
Like electropolishing.
Electropolishing. Have you heard about screen printed electrodes?
Yes, sir. I have heard about screen printed electrode. Actually, this work I didn't do in my lab. Like I did in my internship lab, and I was new to electrochemistry, so like I was in initial stage of electrochemistry. So they gave me this classic carbon electrode. Further studies I'll continue in screen printed electrodes and LIGs also.
Because many times, no, you cannot in practical situation, you can't use that glassy carbon electrode everywhere.
Yes, sir.
So you should use screen printed electrode. So you are doing PhD. This is your PhD work?
Yes, sir.
Okay, good. So what is your PhD title?
Sir?
Topic of your PhD?
PhD title is like metal. Sir, ferrite based nanosheet. Yeah.
Definitely. Calic acid is one of your chapters, isn't it? What is your overall PhD title?
Overall work. Like, so overall work is gas sensing, sir. I like initially I was working on metal oxide gas sensors. After this work, like I went to my internship and I completed.
It's okay. Good work.
Thank you, sir.
Do good. Thank you.
Thank you, sir.
Any other question?
Sir, like
tell me.
Sir told that you have worked on gas sensors.
We'll discuss later. Yeah.
Okay, sir.
We'll call for next speaker. Madhumita. Okay. Yeah, can you just please introduce yourself and then start your talk?
Myself, Madhumita, sir. I'm doing my PhD in KPR Institute of Engineering and Technology under Ranjit Kumar, sir. I'm working on nano materials towards antimicrobial and photocatalytic work, sir. Full screen ಇದೆ sir. Good evening, everyone. Myself, Madhumita. Now I'm going to present my review on ferrites as eco-friendly catalyst for photocatalytic degradation. Okay. The major problem that we are currently facing is pollution. There are many types of pollution, and water is one of the most essential for all living organisms on Earth. And now I have done my review on regarding water pollution. Water pollution from, the polluted water from industries, domestic treated and hospitals, agriculture and chemical waste are improperly disposed. So there are many issues. There are conventional methods like using anaerobic and aerobic microorganisms for degradation, coagulation, flocculation, and UV treatment, etc. These materials, these conventional methods possess many drawbacks like costly, inefficient, energy intensive, and generate many secondary pollutants too. So I tried switching to ferrites because ferrites are very eco-friendly, stable, and non-toxic magnetic materials, and With ferrites, I also included biomolecules. So this work emphasizes on ferrites as green catalyst with biomolecules. Next, I'll give just overview on ferrites. Ferrites are nothing but magnetic nanoparticles. Magnetic nanoparticles composed of both mainly constitutes iron oxide with other metal oxides. This chart represents the classification. Based on magnetic corrosivity, they are classified as soft ferrites and hard ferrites. These soft ferrites are of cubic spinel structures, and whereas hard ferrites are of hexagonal structures. Soft ferrites are of low correctivity, hard ferrites is of high corrosivity. Next, based on the crystalline structure, spinel ferrites. Spinel ferrites here. Spinel ferrites consist of two crystallographic axes, tetrahedral and octahedral. It contains two types of ions, divalent and trivalent ions. Divalent ions are occupied on tetrahedral crystallographic sites, whereas in octahedral, trivalent ions are occupied on spinel ferrites. Whereas on mixed spinels, both the trivalent and divalent are randomly located on both tetrahedral and octahedral crystallographic axis. In inverse spinel ferrites, the trivalent ions are located on tetrahedral sites too. Next classification is hexagonal ferrites. These hexagonal ferrites are also having tetrahedral and octahedral crystallographic axis. Here the metal atoms may be of barium, calcium and lead. Next, garnet ferrites. It consists of octahedral, tetrahedral and docahedral crystallographic sites, and here the metal atoms are rare earth elements, and orthoferrites are very similar to garnet ferrites. Here also the metal atoms are rare earth elements, but the crystal structure is orthorhombic. Next, biogenic material assisted synthesis. Here, in biogenic material assisted synthesis, we are using the extract from the natural products like plant, microbes, algae, fruits, dairy products and other bioderivatives like honey, oil from cloves, etc. Next, these extract contain many phytochemical constituents like flavonoids, aldehydes, ketones, polyphenols, etc. These all phytochemicals plays the role of both reducing and capping agents. So here we avoid the use of chemical capping and reducing agents. These use of extracts contributes to eco-friendliness, less toxic generator waste, and less toxicity and economic feasible. So I have switched to the biogenic materials for ferrite synthesis. Next, these are the basic characterization techniques that we can carry out to know about its physiochemical characteristics. Like XRD can be used for confirmation of crystallite structure, phase composition, crystallite size, lattice strain, crystallinity, etc. BET helps us to know about the surface area, pore volume and pore characteristics. Whereas VSM, here we are looking for VSM because these ferrite nanoparticles are magnetic in nature. So we are in need to know about its magnetic properties like corrosivity, remanence, magnetization and anisotropy. Next, UV and PL studies helps us to know about its optical properties and band gap. As its photocatalyst, the band gap plays the major role. So UV and PL study is very important, and SEM and TEM too. SEM and TEM used for the morphological analysis, both internal and external morphological can be analyzed, and particle size, its agglomeration, everything can be noted. EDAX and XPS used for the elemental composition study. FTIR is used for functional groups. As we are using the phytochemicals, we can also know what is the role of phytochemical here with the ferrites, with analyzing the functional groups. Then TG and DTA used to know about the stability, thermal stability, and Raman similarly used for confirmation of chemical structure and its composition. Next, this is a photocatalytic mechanism. This is a mechanism that which ferrites works on the wastewater to degrade the pollutants. First, the step here, once it receives radiation source. The radiation source maybe of any radiation source. It may be UV, it may be visible light, whatever. Once the material, we know the material has conduction band and valence band. In between we have band gap. So once the radiation source is enough or more than the band gap energy, when it excites, the electrons get excited to the conduction band, it leaves the holes behind. So here the electrons combines with the oxygen and forms superoxide radicals, and here the holes react with the water, that means water content in air, and form hydroxyl radicals. So both the hydroxyl and super hydroxyl radicals both react with the pollutants to both react with the waste pollutants and remove it. Here after this we receive, there is no many toxic byproducts. These are very friendly. It's very less toxic. Next, ferrites in wastewater treatment. Here few of the literature studies that I have gone through, and these are the, I think it's not visible properly, these are the bioresources that I have been employed. Here I have used only the metal, like I have reviewed on the ferrites and doping with ferrites, and also the nanocomposites with the average crystallite size, and the pollutants. Pollutants I have chosen all the class of pollutants, like it may be antibiotics, dyes, and etc. Degradation efficiency and surface morphology. These are the reviews I have even done for the chemical synthesis and physical synthesis, but I have added only the green synthesis results. These results were around, it showed the maximum efficiency. It's a less amount, 78% is less amount, and maximum is around 99%, 99 to 97%. So this, from this literature review, these are the findings. Like these findings, this high light reactivity, high stability, magnetic nature, high surface area, and reduced electron hole recombination, inexpensiveness, environmental friendly, and stable structure. These are the properties that these are the properties that have shown effective action. That these are the functional responsible for the ferrites as good catalyst, and these formation of heterojunctions with the semiconductors, doping with metals, non-metals, and noble metals, and production of metals with doped ferrites, and also creation of nanocomposites. These were found that these were the reason for increased efficiency than the ferrites when we are doping with it, or when we are creating nanocomposites. These gave the good results. So the overall we found that surface properties, structure, grain size, and synthesis method are also playing major role as catalyst generally when we employ in wastewater degradation. So this slide compresses the findings. Next, challenges. Like since we are using the bioresources, each of the bioresources contain different constitution of phytochemical constitution. Like it may contain, it's not, even if we use the same biomolecule, the biomolecule, example, if I use honey, the honey's chemical constitution may vary depending on the regions, etc. So it's very difficult to optimize the phytochemical constitution. So that was the challenge that I observed. And high agglomeration, since these are magnetic nanoparticles, they are of high agglomeration, and increased chemical reactivity. These were the challenges, and limited understanding on photocatalytic reaction mechanism. I mean, there are many radicals like superoxide anions and hydroxyl radicals. These are responsible for degradation, but sometimes it's very difficult to know which played the role of degradation here. So the mechanism, which radical was difficult to know, which radical played the major role. That was difficult. Then the future work, I have planned that expanding ferrite towards air pollutants. Since it's effective on water pollution, I have observed it. We can also extend towards the air pollutant removal too, like dual role, both the air and water pollution. and it's very essential to know about its recyclability and reusability. We can know how many cycles it can undergo, still it can be effective. It shows some degradation, but we must know how much cycles it can work effectively, and reusability. Like after removing the catalyst from the polluted water, still we must know the quality of water. So this method, seed germination test, was it would be very useful if we know still the water is in good quality or not. And majorly I found that since ferrites are of high agglomeration nature and it gets sediments, so I thought of implementing on floating photocatalyst. These floating photocatalysts are nothing but that floats on the surface of the water, and we are trying to embed these ferrite nanoparticles on the like foams, aerogels or polymers, and we make them to float on the water so that it gets direct sunlight, and also it does not sediment, so the surface area of contact for the photocatalyst is increased. These are the things, these are the future outlook that I found. And floating photocatalyst has been implementing ferrites on photocatalyst has been, I found that it could be very useful if we try embedding ferrites on the floating photocatalyst. Okay, these are the conclusions. I found these ferrites were capable of degrading various classes of pollutants like dyes, antibiotic, herbicides and insecticides too. And found this photocatalytic activity was influenced by particle size, surface area, morphology, porosity, band gap, photostability and number of active sites too, and catalyst dosage and irradiation time. These contents fully I have included in the table, but due to the time constraint I'm not able to include it, but I found these factors are also majorly influencing its catalytic activity, and found the smaller and porous nanoparticles had more active sites and better, because it had more active sites, so they record better photon absorption and faster they record the hydroxyl radical. And reduced electron hole recombination was also the major reason. So I conclude that biomolecular stirred synthesis produced from nanoparticles would be very useful in the wastewater treatment. Thank you, sir.
Any questions, please? No question. I have a question.
Yes, sir.
Because I am only listening. Others are not listening. Okay. Why this topic?
Sir, I did my PG project on photocatalytic degradation, sir. Okay, then but I worked on the chemical synthesis, sir. I always had a thought to look towards environmental remediation, so I switched to the biomolecular stirred synthesis, sir.
No, it's my question was different. You are presenting this topic.
Yes, sir.
You could have presented any other topic.
Yes, sir.
And whether this topic is related to you are doing PhD?
Yes, sir.
Is it related to your PhD?
Yes, sir. It's related to my PhD.
So have you done any work on ferrites?
No, sir. Currently, I'm working on metal oxides towards antimicrobial, sir. Same I'm trying to imply on the photocatalyst too, sir.
You are presently you are working on ferrites for antimicrobial property or metal oxides for
metal oxides, sir.
Okay, but this is away from your PhD research.
No, sir. Like I am having an idea to. I'm actually working on metal oxides towards antimicrobial, sir. I'm also using the same. This is also a kind of metal oxide.
Which metal oxide you are using for antimicrobial?
Like silver doped metal oxides. I'm trying, sir. Silver doped.
Which metal oxide?
Zinc oxide, cobalt oxide, copper oxide.
They are not having photocatalytic activity?
Yes, sir. It
then
too
why
has,
you chose a new material for photocatalytic?
Sir, I found that ferrites was very. It's very easy to recover from the wastewater treatment, sir, because of its magnetic nature.
Okay, because of magnetic nature. How will you separate?
Sir, generally for testing purpose, they're using some magnets and separating, sir. In large scale, we have some. It's not completely recoverable, sir.
So what is your strategy? How will you do it? If I have a beaker of water, and how will you do that? How will you use that ferrites to clarify the water?
Now after this literature review, I got an idea to embed ferrites on the
floating photocatalyst, as floating photocatalyst, sir. So
Yes, you are going to use an environmental application.
Yes, sir. Yes.
So floating means, see, which kind of reactor will be used for floating?
Direct, we can try based on the materials, like it can.
How it will float? How it will float on water?
Sir, like creating aerogels and embedding these ferrite nanoparticles on it.
Why
sir.
it should float?
Float in the sense, it floats similar to the.
You are going to do in a reaction container only.
Yes, sir.
Not on the pond.
Yes,
then
sir.
Why it should float? You can always do a what is that? The stirred reactor you can use.
Yes, sir.
Why
But
floating type you are very much interested?
Due to when it ferrites, generally when we use photocatalyst, sir, it gets sediment down, sir. So it's surface area contact with the sun, with the irradiation. Sir?
You can mix it. If you aerate it,
yes, sir.
You can produce more superoxide
yes, sir.
and
We
peroxide that will act as
yes, sir. Generally we use the procedure like stirring and using it. But due to the sedimentation, there is still efficiency is decreasing, sir. So when it's in the surface with water and air interface, it also gets contact with the
Anybody
air.
is published with the floating type of photocatalyst?
Yes, sir. There are few papers, sir, but still I'm working on it, so I'm not publishing. I'm just reviewing the literature, sir. There are few papers, sir.
Okay, I think you should do some research and then present. Okay. In any case, why this cannot be used for antimicrobial? These ferrites?
I'm not using ferrites for antimicrobial.
Whether any reports are there as an antimicrobial property? Whether they are having antimicrobial?
Sir, I'm not using ferrites, sir. I'm using copper.
No, whether reports are there?
Yes, sir. It too has the nature, sir. Yes, sir. It too has ferrites.
See, because when you are writing a thesis, no, one
yes,
chapter
sir.
to other chapter, there should be some
yes,
continuity should be there. You cannot have one standalone chapter and next then trying to justify between the chapters in the conclusion. It will become difficult. Huh? Okay, good. I did not see any research. Some literature survey is there.
Yes, sir.
Okay. Literature survey, it's a good, but otherwise there should be some research component
yes,
should be there. Otherwise, nothing we can ask. Thank you.
Thank you, sir.
Thank you, sir.